Outh Radio, η φωνή της γνώσης.
What is love anyway? But a fire that burns too close. I gave my heart to the flame, and it turned me into smoke. You said forever, I heard goodbye. The echo still lingers. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. Your words cut like a knife, and the scars still sing your name. I thought love was my savior, but it played a crueler game. You said forever, I heard goodbye. Your shadow's a dagger. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. You're the love that
Another midnight, another drink. Silence wraps around me. Can't escape this noise inside. Need the world to stop. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Crowds keep pressing, always wanting more than I can give you. Lost myself in all their needs. Time to disappear. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms.
Yes, I can. Can you hear me?
Don't come looking.
Apologies because I was not aware of the
Don't
time
come
difference. So
calling. I'll be where the silence falls, where loneliness feels like home, and I can finally be. Let me breathe into rooms where your voice can't follow.
Hello, good
Tired
morning.
of all this damn pretending.
We have a roundtable, a peculiar, let's say, perspective of AI literature. And we have the honor to have guests that are arriving from Portugal and also connect with Spain. They're connected with Coimbra University, which is actually connected with UNESCO. You know that is a very big library there. And we discussed today about how they deal with the digitization of this Ioannina library. And we try to see what are the challenges behind this endeavor of shifting from the, let's say, traditional way of handling the information in libraries to the digitization of the information, and what are the challenges both in terms of literature and what are the challenges in AI. So we have the honor to have with us Delphine Leaud. He's a full professor at the Center of Classical and Humanistic Studies at the University of Coimbra. And his main areas of interest are ancient history. Actually, there are a lot of books that he wrote for Solon, Platon, all the Greeks. And I think he's very deep in this. And also the law, the political theory of the Greeks, theatrical pragmatics, and the ancient novel. He also has a strong interest in open science and scholarly communication. He's a vice rector for culture, communication, and open science, and a member of the Executive Assembly for Operas, and is participating in European projects like Opera Spi, Triple, Operas Plus, Palomera, Atrium, Lumen. And he's responsible with his team of developing the collaborative translation platform Audacious and the Digital Ioannina project, where will be the topic of today. We have also here Manuel Portela. He's a full professor in the Faculty of Arts and Humanity of University of Coimbra. He's director of the General Library and one of the coordinators of the project Digital Ioannina. His research addresses writing and reading media and how they impact on the literacy forms and practices. And he has a lot of publications in the area and also related books. It's an honor. He traveled all night because his connection in Barcelona was lost. So he's with a lot of coffee, but a lot of ideas to share with us. And Javier de la Rosa, he's online. He's a senior research scientist in the Artificial Intelligence Lab at the National Library of Norway. And he was a postdoc fellow at UNED Digital Humanities Innovation Lab. He has a PhD in Hispanic Studies with specialization in digital humanities from the University of Western Ontario and a master's in AI by the University of Seville. He worked as a research engineer at the Stanford University Center for Interdisciplinary Digital Research and as a technical lead at the University of Western Ontario Cultureplex Lab for Cultural Complexity. He's working in the natural language processing and actually applied in historical text. So I think we have a good breadth and depth of the context of how we approach the literature in terms of the political, institutional content and AI translation. So I call here Manuel to start the presentation. Then we have a comment from Delphi. We have a short presentation from Javier, and then we have some questions from my side to close the discussion.
Well, thank you, Leontios, for your introduction and for your presentation, also for organizing this panel. It's a pleasure to be here. This is one of the occasions where it's not the audience who's going to fall asleep, it's the speaker, because I didn't sleep all night, so, but bear with me. So, as Leontos was explaining, we have an ongoing project at the University of Coimbra, which is to digitize our old book library, our major old book library, the Joanina Library. So before I go into the process of digitization, I'll just briefly introduce if I get this to respond. Oh, it's not responding now, I don't know why. Oh, okay. So before I talk about the digitization, I just say briefly what the Joanina Library is. So this is a picture of the Joanina. It's an 18th century library, originally opened in 1728, and currently it houses about 60,000 books, of which 30,000 are on the main floor, and these are books, mostly printed books. We don't have many manuscripts in the library, in this library, and the collection goes from the 16th to the 18th century. And our digital Joanina project aims to digitize this entire floor. So the project is to digitize the library itself as a structure of knowledge. We have made some progress. We already have an online platform that has about 300 volumes. It's the result of the pilot project that we used to test all the issues that I'm going to talk about here today. It's about 1% of what we have to do, so we still need 99% to get to the final stage. Besides this public platform, we also developed so this is another view when you enter the platform, the interface that allows you to filter books according to different metadata, and we are also going to introduce natural language queries. And besides that platform, we also developed a second platform for the workflow, for controlling the entire workflow. And in both cases, in the public platform, so the publication that we saw, and also in this kind of back office platform for managing the process, we are introducing artificial intelligence tools and for many different functions. So I have 3 questions, and I think these are crucial questions for this kind of large-scale projects. No? How do you do them? For whom are we doing this? And what are the effects? What are the consequences of doing this kind of large-scale digitization? So in terms of the how, I think there are many challenges. We have to address many different dimensions of the process, of the modeling, and I'm going to talk about this organizational dimension. So this is one of the first aspects that we have to really solve as one of the challenges of this project. So how do you organize the workflow to digitize 30,000 volumes and 18 million pages? So we have to think about cataloging and also recataloguing, because some of these works have not been fully described, and so we are going over the catalog, so improving the catalog. We already have more than 5,000 new entries in the catalog. Define how we describe, so we need to have templates for bibliographic description with different levels of granularity. Also, the issue of conservation and restoration is very important, because some of the books will need to be restored before they are digitized. Digitization is also causes some damage to the books, so we have to be careful in doing that. And then the whole process has to be streamlined so that you are aware of where each book is at any given time. So from the moment it's taken out of the shelf to cataloging to scanner and back to the shelf. And the monitoring of the process has to happen in real time. The quality control and workflow control is also done with AI tools. For instance, we have used the pilot project to identify forms of detecting errors in image processing, for instance, in terms of the focus of the image, in terms of the framing. So different forms of detecting errors that we try to model, and now it's controlled through AI. Also, the process of error correction, iteration, and then the whole process of contracting with companies that do this large-scale digital processing. I think we also have to think about the conceptual and technical dimension of the project. And this is crucial for anyone doing digitization of cultural heritage, because we have one kind of artifact that we have to model in some kind of digital surrogate, and so the modeling is a crucial element in the process. So we have to define, in this case, image encoding and compression standards, and we have to really navigate our capability of storing large files, and also the public less data field files. So we have at least 3 different files. And we have to define the XML file structure, naming conventions, the data model for the entire system, the platform design, interfaces, presentation and hierarchies, search, also document production, so the flow chart for the different files that are generated, because all of the files are not just various image files with different resolutions and different information. There are also XML files related to the structure and the metadata of the files. We also have OCR files that process the text. So we have to adapt international norms to our own context. And here we can also model some of these processes in that platform that I mentioned, using AI tools for checking that we are complying to the model. So the other big question is, for whom? Well, so we are digitizing millions of pages, and there's a general understanding in the world that artifacts, cultural heritage should be digitized, but what for? For whom? Who's going to use it? No? In this case, I think we can talk about the infrastructural dimension of the collection, because that will determine the uses that we can encourage for the collection. So what features have we designed for the digital collection? Multiple forms of visualization, navigation and search, integration between descriptions and objects, aggregation of data and metadata, separation and integration of sub-collections, cross-disciplinary areas. So the library, we can say that this project is digitizing the library itself as a knowledge structure and an information system. And that information system reflects the way knowledge fields were structured at that time. So, so even the library, when you look at the disciplines, there are represented in the different rooms of the library, you will see that knowledge system. Also, we want to introduce collaboration and crowdsourcing tools so that researchers and maybe the general audience can engage with descriptions or images or specific elements in the collection. And then we want to introduce AI to analyze texts and images, also to do automatic translation, because we have many different languages in the collection, mostly Latin until the late 17th century, but then other European languages. And then we can also think about the social dimension of the process. No? So who will be the users and what will be the uses of the Joanina Digital? If the project is successful, we would like it to have to address different types of users. So general readers, students, experts and researchers. We want to have data mining tools that will allow us to do different analysis. And we also want to engage experts in mediating the collection and making some of the most attractive and interesting aspects of the collection engaging for a general audience. So last week I just gave a talk about how we want to integrate the collection with Wikidata and the general outlook of the Wikidata. So linked open data, curated exhibition, so different ways of making the collection not just a repository of files. Finally, what are the effects of large-scale digitization of a heritage library? I think here we have to think about an epistemological dimension, in the sense that we can ask ourselves about what impact will this have on knowledge and on knowledge of knowledge. So what impact this will have on knowledge, in the sense that we can computationally analyze all of these works in ways that have not been done before, and so there will be some new knowledge that we can generate, but also on the knowledge of knowledge, because we are looking at the history of knowledge by digitizing the library. So we can look at history of the book, history of the library, history of knowledge and representations, history of discourses and disciplines. And from the point of view of the user, we can also think about the cognitive and experiential dimension. So what impact will this have on the relationship between the digital space of algorithmic modeling and architectural space of bibliographical organization? On the one hand, some people argue that digitization implies the loss of aura, of the aura of the original. So paper books are replaced by their digital surrogates. But some people also argue that this creates a renewed interest in the original. So digital versions enables us to revisit the original with a fresh perspective. So to conclude, what does it mean to digitize a library of old books, such as the Joanina Library? The act of digitization offers opportunities for innovation at the level of the digital infrastructure to be developed, at the level of bibliographic description of the collection, and at the level of communication of readers and with society at large. The digitization of a book is a critical operation that allows us to see a book at a second degree, that is, to see it as a device for the production and organization of a worldview. If you move from the micro scale of a single book to the macro scale of a library, we can say that the digitization of an entire collection enables us to observe the library itself as an information system with its own history and particular structure. Joanina Digital will enable us to critically analyze the content of the books, their texts and their images, but also their self-organizing structures and the very process that over 3 centuries resulted in the constitution of the collection. Digitization makes it possible to look at the bibliographic heritage as an object of reading and rereading rather than an object of veneration and worship. Old books and the library become witnesses of themselves. They self-document representations and discourses about the world, beyond new possibilities for analysis of individual works, the aggregated digitization of a collection allows us to imagine countless new questions supported by computational methodologies. And I think this is what my colleagues will talk about, the ability to process the entire collection digitally. Thank you.
Kalimera Sassolus. Thank you very much for being here, Aristotle. And I would like to thank in particular to Leontius for having invited me, and congratulate you all as well for this, for the topic of this. I mean, globally, the event, it's a really great idea. I mean, to consider this principle of Aristotle meeting AI. Of course, Aristotle has a lot to do with the place where you are making the conference, and of course all this Macedonian and Greek history, but it's also a central topic, because to understand the future, and I think probably this makes sense for this audience and makes a lot of sense for me as a classical philologist as well, it is critical to understand and to revisit the past. And during the past few days, I was in Warsaw for a meeting dealing with open science and open scholarly communication, and one of the speakers, the keynote speakers, John Wilkinson, who is responsible for development of the open journal systems, which is widely used by scientists all over the world, and Open Monograph Press had approached the question on, talking about 4 pillars, and the 4 pillars, the essential of them was precisely to go to the past so that we can understand and prepare the future. So I will talk briefly, because Manuel has already presented, the questions that we'd like to address from, let's say, a technological and how the workflow is being implemented, the challenge we're facing. So my perspective would have more to do with my role as Vice Rector in Coimbra University for Open Science, Communication and Culture, and how this affects, how do we see a project like this, and how we in fact have to take care about it. And one of the important questions about this is, how can we and how should we justify the investment? Because we have to respect the investment that is being made in terms of time and resources. This project has the advantage of being fully funded by the Emirate of Sharjah, but is investing in fact 8 million euro, which is a lot of money. And so for us, it's of course important to have this kind of support, because otherwise it would not be possible to do the investment. But we also have a big responsibility towards the funders and in what will happen in the future. So this was something that we had to address at the institutional, or if you want, at the political level of the project. So it is fully justified in the sense that every single month we have meetings with our funders and we discuss every step that we are making, and we feel entirely accountable for what we are making, but also when it comes to consider long-term sustainability. So why should we invest this kind of resources in creating and generating a new digital library if we are not able to curate it properly in the future? So this kind of investment always demands from us to see what will happen in the future. And if we want to curate and keep having updated such an investment as such a digital library, we need to be able to attract new projects. That is why when Manuel said, to whom are we doing this? Who will be the new readers? Will we be able to attract new readers? It's not only to call attention to the Joannini library itself, but what kind of new knowledge we can make and produce based on what we have been developing. So this is a critical point for us to keep, to keep this as a pertinent and self-sustainable project in the future. One of the other challenges that we had to meet, or the decisions that we had to make, had to do with, should we simply buy and use something that is already done and offered by the market, or should we develop our own solutions? And of course, we had to discuss this for some time, because if we buy something, it's quicker in implementation, it's already there. But the question is that we fail to use those resources to develop our own knowledge and competencies. So we opted for developing our own solutions. This means that when we pick up the book from shelves and until we provided it to the new readers, all this corresponds to a workflow that was completely, discussed, analyzed, and developed by ourselves. Which means that in the end, we will have a solution, a very matured solution, that can be used not only in what we are doing, but can be displayed, can be used by others, not only in Portugal, but in other countries that are facing, in fact, the same challenges. And precisely within a couple of weeks, we'll have a meeting in Coimbra, an international meeting, where people from many countries that are dealing with those questions, of course, will help us to improve the project, and this is one of the advantages. We are always investing and improving what we are doing, but also to be able to provide this same solution to, especially to institutions that are facing somehow the same problems we are. So this technical challenge is, in a way, an answer that we also provided to justify the investment, also to grant that in the future it will attract new projects and can be kept alive. Another reason, and this was also a critical question for us, is that if we develop, it should be somehow harmonized, what we are doing, with the full digital ecosystem of the university, which means that it is cheaper, easier to have it updated if it is curated together with the full digital building or ecosystem of the university. So it's a way of granting long-term sustainability in the more concrete and easier way. Again, Manuel has already talked a lot about the usage of AI, so clearly this is something that people expected. When you get used to do LLMs, to use natural language, of course, you won't make a research in the same way we used to do it until now. So we had, of course, to put this into what we were developing. But it's also a fact that AI poses new challenges. And precisely 1 week ago, I was making the opening note for a meeting we had in which Manuel also participated regarding the celebration of the 25 years of Wikipedia. And while preparing my intervention, I read 2 papers which were published, with a time slab of 21 years. The first one in the year 2005, the second one in January of this year, 2026. And the first one dealt with, they were both published by Nature, and the first one presented a conclusion that was somehow surprising. It was almost a scandal, in fact, is that an encyclopedia like Wikipedia that is made, which is produced by the community itself, moderated by the community, the level of error is in fact comparable to traditional encyclopedias like the Encyclopedia Britannica, who has, of course, dedicated editors. This was a scandal, and in fact it was a real challenge for traditional publishers. And in fact, 7 years later, the Encyclopedia Britannica stopped publishing printed volumes, had to move into a different way of, let's say, being with the people. And but the work published a few months ago, in fact, said how Wikipedia was now facing new problems, because AI models were being trained by using hundreds of millions of pages that were developed and uploaded within the Wikipedia project. So they use them widely, but they stop sending people to the original sources. So one of the problems is that the LLMs use sources like Wikipedia to train themselves, to monetize also what they do, the kind of work they do, but in the end, they despise, we are no longer invited to go to the original sources. And this poses a difficult challenge for those sources to be kept alive, to survive, to grant sustainability. This is one of the questions that we have to face as well. While we decide to digitize and make available 20 million pages, or around 20 million pages, are we protecting our own library? Are we attracting people to read the sources, to visit, to interact with it, with them? Or are we creating conditions for people to forget that it exists? This is one of the challenges that we have to face. And with this, I will move into my last, let's say, short note, which has to do with open science, a topic with which I work a lot. And the questions that sometimes I address, and it is being increasingly addressed, is this: can we still talk about open science when the world is clearly closing, I mean increasingly closing within blocks? Because when we see it from an European perspective, we are clearly prone to open science. We think that we should, I mean, understand science and, I mean, heritage as a common good, and as a common good it should be, let's say, made available to everyone that want to use it. But now we see that when we consider, for example, the development of AI, that is a total oligopoly of 5 or 6 companies, private companies, so not even governments, that are developing and using all these massive sources of information. So it is not clear now that we should move in the same direction, and maybe in the future we can have to find ways of a balance between making things available, attract new readers, but also grant that we are not giving away, I mean, our ability to preserve it for the future. So this is one of the challenges that we have to face as well with this project, as we have with all of them. But in any case, it's it's a pleasure indeed to follow the way, follow up the way it is being developed, how it is stimulating new studies, how it is attracting new people to books that were somehow not entirely forgotten, but certainly understudied and at least not studied to their full potential. So thank you very much for being here.
Javier, you can start if you want. Just unmute yourself. Okay.
Okay, oh, there it is. I lost visual connection, so I was in the dog for some time. Let me just share my screen real quick. You can hear me fine, right? Let me see what happens if I do this. Okay. Let's move this then somewhere else. Okay. Thank you for inviting me to this forum. Unfortunately, I haven't been able to travel to Greece this time. I've been listening with attention the presentations of my 2 colleagues, and I think that my presentation is slightly different in the sense that in Norway, we are past the step of digitization, how to do it, why to do it. And we are moved to a different stage in which the government basically gave us a task to be responsible for the development of sovereign AI in Norway. So I will explain how we came to that situation and what steps we are taking to handle it. So The Norwegian National Library is a very young library. It was formally established in 1989 with the motto of preserving the past for the future. It was a spin-off of the University of Oslo University Library and then turned into the National Library. If we look at briefly at the timeline, it was around 2005, like roughly 15 years after the library was actually established, that the director at the time had a vision in which he thought that we should try to digitize everything. Together with other leaders at the library, they put together a manifesto in which they highlighted the importance of preserving everything in a digital format for the future. And in the same manifesto, they also made the statement that if it's not in the internet, it's almost like it doesn't exist. So it was not only about digitizing, but also about giving access to the Norwegian citizens to all the documents we were digitizing. That was the goal. Fast forward a few years in 2018, after we had digitized a massive amount of material published or printed in the country, we established what is called the AI lab. The idea of this lab was to try to analyze the collections using AI technologies and see how can we make the collection more searchable and relevant in this field. By then, we have almost every single book ever printed in the country digitized. That is about 95% of everything digitized or being legally deposited in the library. We keep copies not only of the physical, but also the digital PDFs that come from the printers. We have around 90% of all digitized newspapers, both historically and modern day newspapers. We have effectively fully digitized the entire public broadcast in the country. We also run continuous harvests of the Norwegian domains and websites that deal with Norwegian issues. And we have much more. We have photo, images, we have movies, we have maps, we have music score, we have manuscripts, everything that is relevant from a cultural standpoint. We try to digitize and get a physical and digital copy of it. This is the Mountain Vault in Mo i Rana. This is where we store mostly all the books that are for loan in the country. This is inside of a mountain. So a few years ago, the library decided to basically hollow a mountain and fill it with robotic shelves. So the whole process is now automatized. So whenever someone needs a book in the country, if it's not available in her local library, there is a robot looking for that book in one of the boxes in these massive robotic shelves that fill up an entire mountain, and then it gets shipped automatically. That's for the physical part, but also the digital part is important. We run massive data clusters. We have several petabytes of information, and our intention is to create the library for 1,000 years. So these servers need to be replaced every few years. We need to update the technology to maintain the throughput of digitization that we have. We establish digitization factories, and then we have to retrain personnel to be able to digitize everything. And after a few years of digitization, we have several petabytes of video, film, newspapers, our own web archive, but we also have 1 petabyte of books and around 1.5 petabytes of audio files. Fast forward to 2022, ChatGPT came into the scene, and then it was a revolution. It was probably the first time that people actually understood what AI can be. Almost the first time that people started to understand that AI in some very specific, narrowly defined tasks can be almost at the human level. Of course, we know that these frontier labs or these private companies use everything that is available in the internet. And we also know that sometimes what is available in the internet is not lawfully made available. So a lot of different lawsuits started to happen in the US at the beginning, demanding compensation for the use of their material. So we have different lawsuits for code from Authors Guild, from different writers individually and collective. And then at some point, that wave of lawsuits also came to Europe. We also saw an increase in the number of lawsuits against these companies. And in 2023, around November or December, the right holders organization in Norway wrote a letter to the government demanding for compensation where their material to be used in the development of AI technology that we were doing inside of the library, inside of this AI lab. This kickstarted what we call the Mimir project. That was an initiative that the government decided to do. So instead of blindly just accepting the terms of the right holders, they decided to run a study in which we were supposed to demonstrate whether the use of copyright protected material was beneficial for the performance of the large language models trained on that material. We ran the study for a year in 2024, and we found several interesting things. We actually had to run the study together with several universities and computing centers because we have to train models and ablate a lot of different options. So we ablate, including copyrighted books, including copyrighted newspapers, including both, splitting by fiction, nonfiction, factual information, and a lot of different cuts of the information. We found, for example, that the inclusion of newspapers seems to be helping the performance of the models, and then factual books that are like in nature containing facts about the world also might help benefit the performance of these models. But however, fiction seems to be detrimental for these models. The difference between including the copyrighted material or not including the copyrighted material actually decreases when you make these models behave like a chatbot, which is called in the field instruction tuning. After this study was done, the government decided that we needed to create a compensation scheme to compensate the authors. And in parallel to that, they established a new unit within the National Library to actually create, develop, and maintain large language models for the benefit of Norwegian society. That unit is called Sprog Modeller, and that's the unit I'm now basically directing. So we got some allocation, around 2 million euros to staff the unit, and then another 2 million euros approximately to have some compute to do our experiments and our trainings. Translated into people, that's around 10, 12 people that we were able to hire in Norway and other places in Europe, because it's hard to actually get all the knowledge and expertise that you need. And then we got around 1 point something million GPU hours a year. This allocation is supposed to be yearly for the duration of the agreement. Our ambition as a national library is to create a multimodal system that is aligned with the Norwegian values and vision of the world, but it is also able to understand speech using the many different dialects that are spoken in Norway, but also different languages like the Sami languages, but also is able to speak back to you using a natural human sounding voice. Of course, when using this system, this is again our ambition. The system should be able to actually cite the sources that it's using to compose the answer. As a high priority to build this, we decided to work first on a series of GPT-based textual models. These models are like the brain of the system. These are the kind of artifacts you usually talk to, you partner with, and then you get tasks done in the form of agents, but we also had to improve our automatic speech recognition and text-to-speech technology. And then as a lower priority, we decided to work on modernizing encoder-only models, which are the kind of models that you use to retrieve we created a fierce open data set only using things that were available on the internet and data sets that others have collected, including a lot of public documents from public administrations. And then we designed a pipeline in which the most important aspects was the cleaning of the data for copyright clearance. We design what we call the copyright index. We have around 700,000 books already in digital format. So we build an index to be able to check whether material commonly available in the internet was okay to train on. Like, does the material actually contain books that we're not supposed to train on? So we build a filter for that. Excuse me. And then we're using that to find that only around 1,000 of the books that we have in our collection were positive matches and found also in the internet. However, the domain filter we built to be able to filter out newspaper articles that belong to copyright protected newspaper publishers found around 20 million matches in data sets coming from the internet, most commonly from Common Crawl or other massive crawls like the High Performance Language Technology Project. We have to filter out all those 20 million in copyright newspapers, and then we had our open data set shrink from 90 million to 70 million documents. So when we actually started training models to see how these models were doing, we saw that the models we were training were not really performing as well as we wanted them to perform. So we have to basically turn around our whole plan for the pre-training of the models. We have some ideas like let's do this and then let's try to extend the context length, train on longer material and stuff like that, but that didn't work. We have to pivot. Again, the whole thing started in February 2025, so we have to pivot quickly. And then we decided to focus on the actual tasks that people use this model for. So we generated what is called a supervised fine-tuning instruction set. We translated a lot of different instructions. We generated a lot of different instructions, and then we started training pre-existing models like Gemma or Quen to see how they were performing in Norwegian tasks. After we did that, we discovered that this approach was very successful. Even though we were not able to actually continually pre-train the models, we were able to push the performance of the model for Norwegian contexts. That culminated in the release of the Borealis preview series of models, which the first one was released in Christmas of 2025, and then during January and February we finished the release of the whole family of different sizes, from 270 million parameters, which is very small, to something much bigger like 27 billion that you can basically that you need like a bigger GPU to run the model on. Meanwhile, we were in parallel working with the rights holders organization to actually be able to train on this copyright material that we were forced to exclude. We know that if we were able to train on this material from the Mimir project, we know that the performance might increase. So at some point, the National Library was mediating the conversation between the government and the right holders organization, and then the government proposed to allocate around 4 million euros for the National Library to enter into an agreement to use the text of the newspapers' articles for training Norwegian and Sami language models. The agreement that we reached was for 45 million kroner, around 4 million euros. We have like an embargo So we can use articles up to 1 year ago. The agreement was only reached for the newspapers, even though we are still working to reach a similar agreement to be able to use literature and books. Even though we can still do that for research purposes, we cannot release the models publicly, which is our main goal right now. So we also have to establish some opting out mechanism. So every 3 months, if you don't want to be part of the agreement anymore, you have to tell us, and then we withdraw you from the next version of the model. Whatever model has been released, it will stay open and released. So the opting out is not retroactive. But the most important thing is that we cannot publish this model as an open source initiative compliant definition of open source, because we have a couple of use-based restrictions. The first one, and the most important, is that you must not use models trained on this material to intentionally and willingly trying to recreate the material that the model has been trained on. This is to say that the right holders organization is giving us this material, and when we train the models, people are not allowed to try to extract the data out of the model. And the second is a statement that tries to protect their business in the way that you are not supposed to use the model or the outputs to create like end user services that might render their regular websites useless. This is a couple of very technical things, but also we are working, I think I still have a few more minutes. We're still working also on the European landscape, and the European landscape is slightly complicated. They have been creating what they call the European Union AI Act. They have been trying to push for this, and now we have to enter it into force in August of 2027. They have also published what they call the Omnibus Directive, by which the National Library of Norway will be considered a provider of general purpose AI models, which means that now we have to be very careful about how we release, what we release, and where we release the models. And I think that'll be my contribution for today. Thank you.
Thank you very much, Javier. We don't have time because we start with the next session now. Thank you very much, everybody. I think it's an opportunity to understand that we have a treasure there hidden in libraries that we saw in a mountain, and we saw also in Coimbra University. So the new generation that actually stays about 5 seconds in one page or even less have to consider how we translate this new way of thinking, acquiring the knowledge, using AI tools, perhaps agentic AI or some other ideas, in order to capture the essence, as Delphine said, not to lose the contact with the original source. So I think it's a good idea to understand how the digitization is the first step, but how the consumption of the knowledge and the knowledge of the knowledge is important. So I leave this as a question to think about. And thanks all the speakers and arrived from Portugal and also from Norway. And we move on. The next session starts in 2 minutes. And thank you very much again.
Thank you. Bye.
Communications. And what we try to say today is the different opinion with a very prestigious guest that we have here. We have Slim and George, we know from here, and Merwan connects from Abu Dhabi, from Khalifa University. And the title is AI Native Wireless Design Networks That Learn. I think George will continue with the presentation of the panel.
Thank you very much. Can you hear me? Okay. Thank you very much, Leontios, for the introduction. I think we'll have a fruitful discussion about the AA native wireless and how to design networks that we learn. Here, I'm very happy to have two pioneers, I could say pioneers and top researchers worldwide in communication theory and also in communication theory and AI. So I'm very happy to have here Mohammed Slim Alouini. Slim is a friend over 20 years, I could say 25 years. He is professor in KAUST, King Abdullah University of Science and Technology in Saudi Arabia. He is founder of the Electrical and Computer Engineering Department in KAUST, and he is one of the most cited researchers in telecoms and especially in communication theory. He is IEEE Fellow and Optical Fellow, has designed and optimized several innovative technologies for emerging wireless network, and his research on integrated space-air-ground network, spectrum sharing techniques, and optical wireless communication has a global impact. The second speaker, also I'm very happy to have Merwan Deba here, has founded multiple public and industrial research centers, startups, etc. He is now a professor in Khalifa University. I also was in Khalifa University for 3 years before Merwan.
Yeah.
A very good university in the Middle East. I think one of the top universities in the Middle East. And he is also founding senior director of the Khalifa University Digital Future Institute. Okay, Merwan is one of the researchers that bridges the communications and AI. He has received multiple prestigious distinctions, prizes, and awards. Thank you very much both for your presence here, and I believe we'll have a fruitful discussion. Okay, let's start. I will ask some questions, but the discussion is open, and you can stop each other, etc. So I would like first to ask Merwan,
Yeah.
what does AI native wireless really means? Many people uses this phrase AI native network, but it can mean very different things. For example, AI can assist optimization, AI can manage radio access network, autonomous control, etc. So, what does AI native wireless really means?
That's a very good question, and will depend on the people you ask. Of course, I have my own point of view of what you call native AI, and I've been working on it. Since several years now. So I think the approach of many people looking at telecom as a vertical where AI is applied is very narrow in terms of vision. Of course, AI is going to be applied in every vertical. It's applied in medicine, it's applied in telecom, it's applied in manufacturing, and you can go on HR and you can go on like that. But then I think this is just like scrubbing the surface, because you're just like applying a tool to do some kind of optimization, which basically, of course, will work. And we have a lot of cases where we can show that using AI tools in terms of energy efficiency, I would say, improvements, or basically broadband improvements, or reconsidering, I would say, the pipeline on an end-to-end problem. And the approach of all these people in general that they do, and this is not I just want to mention what's being done. And I think that's not what we call native AI. But that if we go on that trend, of course, it's very important. Why? Because we all know that a network is very complicated. And it's not because you have optimized one part of the network that you have an end-to-end optimization. An end-to-end optimization is very complicated. I'll give you a very good example. I worked many years on a problem in LTE called voice over LTE. And that was my first encounter of using basically AI tools to the vertical of telecom. And from 2014 to 2016, I was asked by my management at Huawei, I was at that time vice president of research in France, to basically find ways to improve the quality of voice over LTE. Okay, so this is a very good example. So for people who don't know, voice over LTE in 4G is not a technology but an application. It's like WhatsApp. And why? Because the people who built 4G basically have been building it with an idea of having a full IP stack. And so what it means, you hear me?
Yes, okay. Go ahead.
Oh, okay, sorry. And so by that, what I mean is that even if you improve the SNR, the quality of a voice call will not happen because voice is not a technology in 4G, it's an application, it's like WhatsApp. And if you start trying to use mathematical tools, in which I'm very comfortable with, in fact, it's not very easy to do because you can improve, you can write down the SINR, you can write whatever you want, but a call which is done on an IP network, there's a lot of different parts. There's the IPsec protocol, it goes through IP packets, you don't control the IP packets and you go on. And we spent 2 years basically trying to come up with, I would say, mathematical optimization techniques to improve. It never worked. It worked a day where we had a bunch of our engineers working in Turkey, working with an operator called Turkcell, and where there was a lot of measurements related to different configuration of the base stations and basically different quality of experience in LTE. And that's the first time that the people came up with all those data to us and told us, can you do something with that data? And so we started doing, of course, reinforcement learning and using all that data to see how we could improve some new configuration based on all the past data configuration. This was called AI-based voice over LTE, and it turned out to have basically up to 70% improvement to classical voice over LTE calls. And that was my first basically encounter around 2016, 2017 of seeing that there are some problems for which basically a black box approach, even though you don't understand everything, you still get improvements with respect to a mathematical approach where you can't model that kind of thing because it's an end-to-end performance. When I mean end-to-end, you can't define really the metric with numbers. You cannot define each part, and we spent many years trying to improve just the SINR, thinking that, or looking at the latency, and never worked. And what I mean by that is, for sure there is a big market in using AI tools for a lot of problems that cannot be conceptualized in a mathematical form and in which you can bring all the machinery on which we're used to. But I think this is just scratching the surface. That's what I mean, and this is not native AI for me. It's just all what verticals are doing. When we call about native AI, is re-looking at the network differently. First, our networks are basically not networks which are using text. They're not using images. They're not using videos. They're not using sound. They're using signals. And so, first of all, the first thing you need to do is look at how AI can treat signals. And this is, I think, the first part of what I call the native AI approach. In saying, what am I treating in a network? Well, I'm treating IoT. IoT are sensors. Can I build the LLM of IoT? That is the first part, I would say, that characterize basically a network. And so why I'm saying this, because this is the work that I've been doing the last 2 years, trying to build what we call large perceptive models, and in which we announced recently, a couple of months ago, the first RFGPT model, where you can chat with waves. And I think already this showcases that the telecommunication, I would say, domain has basically some particularities which are not at all taken by the classical AI trend, in the sense that we are talking to the world and we're talking to the invisible world, and we can build basically ways to tokenize signals and in which basically we can interact those signals. And that of course enables you to start saying, hey, I'm measuring this thing. Tell me, what is it? Is it a 5G signal? Is it a 4G signal? How can I improve now the signal occupancy based on what I'm measuring? And you go on like that, chatting and interacting, understanding and predicting the waves. That is, I think, a big part of already bringing the AI world to understand what we telecom are doing. Because the AI world is just like relooking at same thing, it's data, but our data is signals. And once you start looking at the LLM for IoT, you open the door for many things. But again, this is a second part, which I think is just about trying to adapt what people are doing to basically our own problems, and not just using that tools and hammering it to the telecom domain. Where I think we're talking about native AI, and this is my definition, is that we're trying to build a network where we are building the communication layer for connecting intelligence. What I mean by that, I think basically that people are not realizing that the future of telecom is not about me calling basically you, or calling a friend. It's my assistant calling another assistant. And so the question when you ask about native AI is, how is the actual telecommunication network capable of, let's say, managing hundreds of billions of AI agents which are communicating with them? And if you consider that the AI agent that communicates should still communicate in the classical way, then you're totally wrong. First, when two agents discuss, there is no reason that they use a language. This we know. And for a simple reason, why would they choose any language that is there? Second is, they don't need to transmit data. And so you build a network where data is not anymore transmitted, it's just the instruction to reconstruct the data. Let me give you just an example, and sorry to be so long, but imagine that you have ChatGPT or an agent built on ChatGPT talking with an agent built on Claude. If they want to, let's say, transfer and discuss an image, they will never transfer the image. They will just do image to text, then you send the text, and then you do text to image, which tells you that in a network that we're building in which agents are communicating, since models are able to reconstruct basically, and they're what we call super compressor, you don't need at all to send data, you just need to send basically the instruction to do it. However, in a native AI network, you'll never have the same basically image which is reconstructed. You've been using ChatGPT. If you chat once, the second time you don't get. Which means that native AI requires that our new definition, which is related to the semantic layer that everybody talks about. Because at the end, what you need is just a common understanding between two entities on how you build these things. So that's the real part of native AI, which I consider, with obviously also a new economic model behind. I think people, because the problem with telecom is that we are very tech oriented. We're never building the economic models behind. We're always basically losing the model, the economics behind. We know it, we've been building whatever networks which were outstanding in terms of transmitting videos, but it was YouTube which is making money and not the telecom operators. I strongly think that there will be a model on which many of us here will be having a sort of subscription where you'll have 2 hours of calls, 50 gigabits of data, and 2 million tokens. And what I'm saying is that what will be transiting in a native AI network, and the native AI network will be characterized by the transmissions of tokens, and by basically the interaction of tokens, and by the monetization of the network through tokens. And I think if we are able here together to support and build business models of these, then I think basically the native AI network will appear, and also telecom will be back. Because we've been losing a lot of money. All the telecoms since the last 20 years, after the GSM success, we were considered as dumb pipes. We have a big part to bring in, and the reason is that if intelligence basically is required in a network, it has to lie also in the communication layer of that network, and operators are much more better placed than AWS and Azure. And I'll finish by that. Sorry for being long, but I think it was a bit
Okay.
important to give the different parts of
Yes.
that history.
Thank you very much. If you want to comment.
Yes. Obviously, first of all, thank you, George. Thank you, organizer, for inviting us. It's a pleasure for me to be back to Thessaloniki. There is, as you know, a very interesting ongoing also IEEE ICT conference with a very interesting talk, and this panel also is a very nice complement to the activity this week. So obviously Marwan is deep into this, much more than me, in the sense that I think he gave a very good answer to the question. I would like to answer it from a different perspective, a little bit, I would say, historical perspective. So I think we went through 3 phases. And this is from my own recollection. 10 years ago, I will not give name, but there is a giant in our field giving keynote speech in a big conference, and he was asked the question, what do you think AI role in wireless communication? And the answer was, I don't think it's very useful. Maybe, I know, if we push a little bit, it can help in channel estimation. I do remember that answer, and it was 10 years ago. We are not talking like 3 decades ago. So we moved from that stage where there was denial that AI will be able to help in communication in any way or form, and I call that phase 1. We moved then to phase 2, which we can call AI-assisted communication, okay? Where basically you have few modules, like Marwan example is a great one, 2014, maybe 18, that the time frame where basically people thought, you know what, maybe I can optimize my beamforming, I can optimize traffic prediction using AI tool. At that time, even myself, I started believing, yes, maybe it's useful technology, but when students come to my lab or my group and ask me, I'm going to work on AI, I tell them this is not really our area. We are not experts. There is no point to try to do something where we are not good at. Let's forget about this, do our old stuff, communication theory. So I was still in denial mode. And that I call phase 2, which is AI assisted. And then now, like Marwan explained very well, we are in phase 3, which is AI native. And in this phase, if you are not part of AI, you should resign and don't do communication anymore, because you'll be put on the side and everyone else will be doing something interesting and you are still doing old-fashioned, to a certain extent, outdated research. Where basically we moved not from an assistant perspective, but a fully integrated part in the design of the network. I mean, Marwan gave a great example and a great illustration how this can be envisioned in the future, but we are not talking anymore about assistant. We are talking that AI is the center of the design. You assume that you have this super intelligent network that are having all kind of information about weather, about traffic. They are self-orchestrating themselves. They are able to redistribute load in an adaptive way, continuously learning. So it's not anymore assistant mode, and that's why it's called native, but it is fully integrated in the design to take into account a variety of parameters and optimize the network. And at the end of the day, why it's going to be useful, in my opinion, I will conclude with that, to confirm what Marwan said. This industry, when you talk to people, neither me nor maybe Marwan is a little bit more than me involved in the industry, and me and George maybe are more on the academic side. Basically, when we talk to our colleague from industry, we feel that there is a pain in the operator business, that they are losing margin, they are not making as much money as they used to do, and AI will be their opportunity to maybe regain momentum and optimize better their operation and be able to make more money, so that basically they go back to a more healthy, let's say, environment from an economic perspective.
Okay, thank you, Slim. I would like to continue your thoughts. You know, all we know that wireless communications has a long tradition on mathematical modeling, and we all work in the past and now on mathematical modeling, on information theory, on stochastic geometry, random matrix theory. Marwan did a great job on random matrix theory and performance analysis. So in future networks, do you believe that AI will replace this model? Or the real breakthrough come from hybrid systems that combine physical models and learning?
Yes, I will have my first answer, and I'm sure Marwan have a kind of something complementing what I'm saying and hopefully confirm what I'm saying. I think we should not look at it from the two extreme, the old-fashioned kind of way, purely theoretical, purely analytical, and just trying to go after a closed form or a purely mathematical equation, and that's like purely model-based type of approach. And then maybe the other extreme that people think that that's the only way that works now, which is fully data-driven. I think in between a hybrid like what George mentioned, where you still capitalize on good models, on models established as being the right way to kind of, let's say, model reality, but the parameter of the model can be optimized using AI. So there is still a room to use random matrix theory, to use stochastic geometry, to use all these kind of sophisticated mathematical tools, at least in my field, in terms of performance analysis. But the parameter you need to use to be able to optimize, to be able to get realistic performance evaluation can be data-driven and can be obtained via AI. So I think a hybrid model is a good way to go.
Okay, so Marwan, do you believe that we will move from model-driven design to data-driven design?
Yes, I think we can move from that point of view, but model-driven design has a couple of advantages. But certainly what will happen is because of the need and the speed at which things have to go, a lot of people will go on the data-driven design. And again, one of the issues that you have is a lot of the problems that need to be solved at a pace at the moment where there's a lot of pressure to solve a lot of problems in network because they're complicated. And so for sure, data-driven approaches will give you some solutions, whereas basically modeling will take years because, research takes time. What people do not see, however, there are two advantages with the model-driven approach. The first one is, of course, the capability of understanding what's happening. And we know that any kind of data-driven approach, well, when you look at critical applications, and telecom has a lot of issues related to critical applications that you're using for basically public safety and others, and these we cannot have guaranteed results. And we're a bit stuck today because we have some solutions, but we cannot guarantee basically the results because of the lack of understanding and going towards data-driven. And so it will pose some problems at one point, and in which people will come back to more, I would say, model-driven, or this what you call hybrid approach, meaning bringing a bit of modeling to be able to understand what's happening and going on then on the data-driven. So that's the first reason why I think model-driven will come back a bit because of that. Second is, data-driven has a cost, which is basically a cost in terms of energy. And of course, model-driven approaches are things that you not need to rerun, retrain every time that you change one new, I would say, kind of configuration of your problem. And so that is something that people have not basically taken into account. But in the last, I would say, 6 months, we are seeing a lot of pressure on companies on how much spending they're doing on cloud, all these things. You're hearing basically companies, they're having budgets which are going on the order of hundreds of millions of dollars basically to run the code and rerun basically every time there's a change, we run that. And this part is going to be more and more impressive in what we do. And let me even give you an example even worse, is basically using agents for what we call science discovery. Because a lot of AI people are talking about basically AI in terms of solving problems. However, we have seen the trends in the last 2 years where AI is being used for basically coming up with ideas, science discovery. And even in research now, basically people are writing papers which are totally generated by AI, but not on the solving part, but even on generating the ID, saying, okay, do me a paper for Globcom on the topic of ultra reliable latency, and then it does you do your paper. What's very interesting with that, and there's some now recent papers showcasing that there's a cost which is increasing for discovery. And that cost is a cost which is coming extremely important. Agents are able to find the low-hanging fruits, but at the moment they start looking at very new ideas, the run and the number of rerun and epochs that they have to run starts to be quite considerable, meaning that a paper that you would submit to Globcom, which obviously would cost you in MATLAB and all the simulation and the PhD salary roughly maybe $30,000, is now going on a figure of $100,000, and we may cost you even $1 million or $2 million to come up with a paper with a genuine ID. And so, even from a research point of view, maybe there's some PhD student here. It's quite interesting, maybe, to look at the problem for a PhD point of view is what is the cost of agent discovery? There's a recent paper done by Muriel Médard from MIT, which started to look from an information theoretic point of view and looks exactly at basically the amount which is required with that. And so, coming back to your question, hybrid for sure, and model will come back because of these two features on explainability and basically cost, which you translate into your energy bill.
Okay, thank you, Meran. Now, I would like to ask you a question that I received from one of my students, and it is related about the learning of wireless networks if we take into account the wireless reality, okay, the so-called wireless reality. What I mean that the wireless environment changes rapidly. We have mobility, outages, interference, spectrum dynamics, traffic bursts, energy constraints. So what kind of learning do you believe is realistic in wireless systems, in live wireless systems? Okay, Slim.
I mean, yeah, honestly...
I mean offline training, online learning, reinforcement learning.
Yes. So actually yesterday there was a very interesting keynote speech in ICT that was touching, there are two keynote speeches, and both they were touching on this issue and about learning in a wireless environment. And although I'm not really active exactly on this topic, but what I learned from the talk of yesterday is obviously there is a trade-off. If the environment is super dynamic, you know, obviously you don't have enough time to basically learn, to be able to kind of readapt. Like the example was given, you have a car going at full speed on the highway and suddenly it hits a tunnel. Obviously the environment being outside the tunnel, inside the tunnel, from a wireless propagation perspective is completely different. And unless you have done the training ahead of time for this particular route, there is no way you can immediately kind of recover and not disconnect if you are planning something based on the kind of the initial trajectory. So there is obviously a trade-off, but having said that, and if I kind of try to read between the line of your question, indeed when you look at the amount of information that we need to digest to be able to kind of run a network, it's a humongous amount of information. At the same time, if you have enough time to learn, it's impressive the kind of result you are able to get. Like yesterday, in the second keynote, like they were talking about an example of a calibration of a network in the sense that you have done, let's say, an offline or continuous training, and you know how your antenna are set up, and you have a particular response that is basically evolving during the day because traffic in the day changed because weather condition may change, etc. But then suddenly you may have an unusual event, like an earthquake. And then you should be able to detect that because it will be kind of anomaly that you know that there is no way on Earth that this has happened due to a regular type of behavior or change. So a network can be used to kind of detect that such kind of event happened and network is not calibrated anymore, meaning by that, for example, in this instance, they were talking about antenna being tilted in a certain way after a strong vibration, a strong storm, an earthquake. The antenna are not calibrated, are not tilted the same way, and they need to be recalibrated to be able to achieve the same kind of performance. So I think AI is powerful enough to be able, if you give it time to learn and to look at patterns, to be able to adapt to a variety of solutions, but you need a little bit of time to do that.
Okay, Meran, if you want to comment,
Yes, and so I was not aware of the question, and in fact, while Slim was speaking, I digged up some slides, which basically, and I'm very happy that your PhD student or the student you were mentioning explains that. And I think what is important is exactly what he mentioned. Uh, Actually, the way we're treating basically telecom is treating it as a vertical, which is classically basically the same as medicine or whatever. And the world we're living needs to take into account the wireless, the fact that there's mobility, that there's the fact there's Doppler, and the changes that the thing, which is here, what I wrote is the world is not text. When you consider a building speaks through sensors, that's the world. A city speaks through mobility patterns. A network speaks through telemetry and radio emissions, and a factory speaks through events, delay, and interference. So eventually, of course, the models we have built so far, which are either LLMs, which are mainly capturing meaning from text, or multimodal models, which are using image, video, and taking the meaning across media, are not basically tailored for our domain. And so there is a need, of course, to take that. And why I'm doing that is because, of course, we captured that a couple of years ago to start looking at how we could embed that. And I'm doing a bit the promotion, of course, of the work that we did, but I think it will open the door to many of the students here, is we start understanding that we need to build a sort of a GPT which is tailored to the RF domain, which treats signals, and that was released a couple of months ago. And this goes back to the, I mean, and of course you can read the paper if you want that we wrote, which explains exactly how we do it. But it goes to exactly what your student is saying. What do we need today? We need a system such as you prompt, describe this RF scene, and then the system tells you this captures or shows a 5G NR downlink in FR1 with 2 active user equipment, and it goes like that. And then you can ask, do you observe other wireless technologies? And it goes telling you no, only 5G NR signals are present based on the signal measured, and up to also asking anomalies. But this is just talking. What your student is saying is you need to capture more. You need to capture basically also the kind of activity which is running. And if you ask, for example, what are the users likely doing based on this RF signal, then RFGPT, or the equivalent that you could build, will tell you, well, I'm seeing these downlink, uplink signals, combining RF scheduling, buffer status report, and modulation patterns. The user equipment 1, which is the device number 1, is likely engaged in an interactive application, Zoom, Teams like, and UA2 is passively consuming high throughput media. But then again, up to your student, this is exactly what we need in a network. And this is what we need to build basically in the capability of these AIs to predict and analyze signals. What will happen to this RF scene in 10 seconds? And the kind of answer you would get by building the appropriate model is, this is a dense 5G NR FR1 deployment with moderate mobility based on the Doppler spread. So exactly what your student was saying in scheduling pattern, I predict UE1 will experience a 3-5 dB SNR drop due to incoming blockage, likely moving vehicle. The GNB scheduler will reallocate PRB toward UAE2, which shows more stable channel condition. A beam switch is expected within 6 milliseconds to maintain the reliability. And that's exactly when you capture. So going back to your student, we need to take into account all those signals which are coming from basically the wireless, embed them and tokenize them in models, and then basically be able to start predicting what's going to happen in the next couple of milliseconds in a network, and being able, of course, then to build agents on top of that. And so, yes, this is the right way to go.
Okay, thank you. Let's talk now about energy efficiency and sustainability. AI can optimize energy use, but the large AI models also consume energy, and this is a well-known problem of the, for example, the LLMs. So, will a native wireless reduce the energy footprint of networks, or will make networks more computationally expensive? Meran.
Good question. This is the place where I'm the less confident in terms of how computing has overthrown all the basically modeling approaches. There are, of course, ways to improve the energy efficiency by using AI techniques. But then when you take the whole end-to-end and the amount of GPUs that needs to be used, and also basically the kind of inference, once you did that to run, the equation is not good at this stage, to be honest. It's not a good equation. It's not a good equation because the amount of energy spent is much higher than the energy that is being used to reduce the energy consumption, whatever models we're building at the moment, to be honest. And so what it means that there are, of course, approaches. The first approach is relooking, of course, at how AI is being built and trained. We know today that you could build better models and better ways of training if you go in the analog domain. What I mean by analog domain is because basically, of course, you're very specific in what you want. And analog is very energy efficient. The problem with analog is it's not basically a general purpose technology, because once you change, it's like doing a Fourier transform. I can do you a very nice Fourier transform using optical techniques, meaning just doing some kind of propagation and reading basically the diffraction. But it's very tailored to that kind of operation. And so that's one approach, is to still continue AI techniques, but build them basically with optical processing units, using waves for doing that. A lot of people I'm seeing are using what we call stack intelligent metasurfaces. They're now in the market to be able to do much better training in terms of energy. And so that's one way of doing it. Second is, you don't need to use the best sophisticated model to solve the problems. You need them to be smart in using exactly what you want for exactly the kind of feature which could reduce. But coming back to your complete answer, I'm not very confident that the trend of this convergence of communication and computing is going towards a world where we're consuming less. It's going to be more.
Okay, thank you. Slim, do you want to
Yeah,
comment?
I think Marwan said it all, and that's a big challenge ahead of, I guess, humanity. Like if we continue going this way, I mean, people are talking also about having data center, underwater data center in the space to try to address some of these issues, but definitely solving the energy problem from a system perspective is going to be a big challenge in the future.
Now, you have a paper together, and together with other researchers, and where you suggest that RIS, reconfigurable intelligent surfaces, ISAC, integrated sensing and communications, and other smart radio environments techniques, you suggest that the network may not only adapt to the channel, but reshape it. Okay. The question is, if the environment itself becomes programmable, does AI become a network controller, a radio designer, or something closer to a real-time engineering of the wireless medium? Slim?
Yeah, I mean...
You remember that paper?
Yeah. Obviously, yes, we are moving towards, I mean, like when you look historically how we start by obviously just optimizing receivers, and then we went into optimizing transmitter and receiver in terms of adaptive transmission systems, and now with RIS being kind of the first, let's say, manifestation of this, is how you can control the end-to-end system, including the two ends, receiver and transmit, but also the channel via RIS, via other kind of mechanism. And yes, in a way, AI in this kind of context can help make sure that we come up with the best, let's say, programmed channel to achieve our objective, to serve the kind of user we are trying to serve, the different application that we are trying to, let's say, deploy. Because as you know, in communication, we are not serving kind of a single type of users. We can have also machines with different requirements, different expectations, different KPIs. So the system and the network and I would say even the channel can be programmed differently depending on the application. Some application will be kind of trying to go more towards ultra reliable, low latency communication, be very strict towards that. So the system has to be configured to meet this kind of requirement, whereas others may be more tolerant to these kind of things, but maybe expect some other kind of KPIs to be met. So yes, I think AI will be playing a bigger and bigger role to kind of meet the different KPI depending on the different application.
Okay, Meran, do you want to comment on this?
Yeah, I can comment, and I think, I mean, so what Slim said is totally right. I mean, for everybody, of course, around let's say 2008, 2010. I mean, it depends on the dates, but for sure, the big change was to say that, you know, communication was mostly about optimizing the TX or RX and taking the environment basically as an independent entity. And of course, what we realized quite rapidly is that, of course, the environment is part of the communication and it's a controllable environment. And so by that, of course, you could improve drastically since you can change environment, which is not surprising, by the way, because whenever your communication link is not good, what do? You move. So now instead of you moving, ask the chairs, the wall to move. But instead of really moving physically, they're just moving in a sort of a digital manner by basically some kind of programmable way of changing the texture of that environment. And so from that point of view, I think this is a big revolution. What is interesting here is not the point to point. And this is where I think we get a bit lost. So on the AI perspective, AI will be able to digitally control the environment from a one-to-one point. What we saw quite drastically is whenever we have a lot of users, a lot of these surfaces, a lot of these receivers, and how you combine all this together so that you can make things work. And this was reminiscent of the big problem because the network layer becomes complicated. And why I want to mention this is because from 2000 roughly, I would say 7 to 2012, there was a big push, especially by Bell Labs, of a technology called small cells. Maybe some of you have recalled that, which is basically a lot of, let's say, terminals with transmitting. And one of the issues we had is that this densification of a lot of features that you put it required to basically optimize this. And people came up with a concept called SUN, self-organized networks. Self-organized networks never worked. They spent many years, and the reason is all the issues that we have, which is exploration versus exploitation. The more you increase your dimension of a problem, the time you converge to a solution where all these nodes find the right parameters and in the least sense, the right basically parameters in terms of what are the controllable, it's too late before the communication goes in. And so people revisited that with something called AI-based SUN. So SUN was there, people used game theory, they used basically reinforcement learning, there was Q-learning, a lot of research was done, and then 2012, 2013, nobody spoke about it. And then it came back with AI, and people republished a lot of papers looking at the problem with AI-based SUN, and today also a resurgence of this problem. And what we see today is the problem of exploration versus exploitation is still there. If you need to distributely make a system totally basically working and converge to the optimal point where all the leads find exactly, some of your users are moving and it goes down. So what I'm mentioning is not that AI is not going to help, is that we still have the problem that the convergence rate of whatever we do compared to the environment mobility is still an issue, and this is called classically the exploration versus exploitation problem.
Okay, thank you very much. We have time for two brief questions. First, I would like to ask Slim. I know that in the last years he works on the connectivity issues, and I would like to ask him can AI help to close the connectivity gap, or we need first to collect data and then to try?
You mean in the context of connect the unconnected?
Connectivity. I know that you work, for example, on low altitude economy, which use is a connectivity alternative.
So obviously AI is going to be helpful in this context. When you talk about the, so I think what George is referring to, I have been active in this area of air, ground, space network, where basically network are not limited to kind of the terrestrial base station, but you assume it's a continuum of base station at different altitude, serving user not only on the ground but also user flying, like urban air mobility like eVTOLs and drone for delivery. So we are evolving towards this new paradigm where the user are in 3 dimension, meaning there are ground user and flying users, and the network also is 3 dimension or multiple layer, ground base station, aerial base station, stratospheric base station, and space base station at different altitude depending on low Earth orbit, medium Earth orbit, or geo orbit satellites. So obviously it's getting even more complex than what we have today, and AI definitely has a big role to orchestrate, to basically operate this kind of network. In other words, the vision I have, and I think not only me, but those of us who are active in this field, is a generalization of what we see today with our phones when you go from, let's say, your home to outside, to your university or your office. So when you are in your home, naturally the phone, without even asking you, should be connecting to Wi-Fi. And then when you go outside, it will connect to 5G. And when you go back to your university, it will again recognize the Wi-Fi network and reconnect to Wi-Fi. That's kind of usually what's happening today. Think about this paradigm extended in all dimensions. You are moving between air and ground, taking an eVTOL to go to your job, going to a maritime environment, and the same phone will be connecting sometime to Wi-Fi, sometime to a terrestrial base station, sometime to an aerial base station, and sometime you are in an airplane connecting to a satellite. So that should be orchestrated and managed by something quite powerful, and AI can help doing that. So now, on the other hand, you know, like there is always pros and cons. Obviously, there is this risk when we talk about, and this is a topic dear to my heart, because I have been active on this for the last 10 years of this connect the unconnected and trying to connect more people. We are still living in a world where about 1/3 of world population is unconnected, and I am afraid that AI may actually accentuate the problem. So we'll not talk anymore about people that are not connected, but they don't have access to AI tools. So basically, the divide is going to be even bigger. I'm talking at the user level, because not only they are not connected, but they are not going to be empowered the same way other people who have easier access to AI. So we are creating another divide, which may have an even more huge impact than the one we have now, where connectivity already is creating a big divide, where, as you know, internet makes a big difference in the life of people, even from a financial opportunity perspective. Imagine if that kind of just internet is becoming not only internet, but all kind of AI tools that make our life more efficient, being accessible and affordable only for a minority and another majority of population in the world. I'm looking globally here, not looking at, you know, like Europe or few countries that may be ahead of others or more resources than others. We may even accentuate the divide and not only talk about connect the unconnect, but it's a bigger dimension in terms of the difference of services and opportunities of population in different parts of the world.
Okay, last questions to Merwan. I know that you have developed several LLMs models for wireless networks, and my question is, what happens now with the standardization? Is there any progress?
Okay. Yeah, so that's a very good question. So, and that goes back to the problem of AI. So for everybody, you don't standardize AI. And so whatever model you build, and we've been building a series of model called Telecom GPT since 2 years. These are not standardized. What you can do is, of course, benchmark them. Benchmark them means basically that you need to work with entities to make sure that the kind of models that you're building are basically responding to the needs of the industry. And in general, you come up with some use cases. And so we spent basically more than a year working closely with GSMA. And I strongly encourage you to look at those white papers and also what GSMA has been doing on this open telecom benchmark, where we gathered basically more than 15 operators, basically looking at all the use cases they required. A lot of use cases in telecom are related to troubleshooting in a network, these kind of issues, and in which then this served to build a benchmark and then led the industry to build a couple of models. We were one of the first to build the Telecom GPT model. The recent model, which is for information rank 1, is the one of AT&T. So AT&T did a very good model today which ranks in the top benchmark. And the benchmark is related to a set of 15 use cases with questions which are related to its capability of answering mathematical questions, answering 3GPP and things like that. And so on that part, there's no standardization which can be done. However, and this is also when you build models. However, where the standardization kicks in is on the interfaces. Why? Because in a couple of years, Samsung will be running as an OS a model which may be called, I don't know what the choice they made, but let's suppose that they make the choice of Meta, and then basically Apple makes a choice of OpenAI and things like that. And so these models being trained differently, they need to be interacting, and you need to build a protocol basically so that they can discuss. This is what's being done. You have to know, and so this is what at the moment ETSI, which is basically the European version of the standardization of 3GPP and 3GPP, are moving, is trying to standardize basically the interfaces so that the models can discuss and agents can discuss. And so that's what people are standardizing, because you need to be sure that if my model needs to talk to a model of Huawei, then at least they need to interact, which is the same as you and me, by the way. I mean, you speak a different language, you're trained mentally from a different environment because your education is different. I'm also educated in a different environment. However, we can speak. Why? Because at one moment we have some references, and then at one moment everything equalizes. And so that kind of steps, which is at the heart of standardization, is being very active at the moment. In the 3GPP new release, they're discussing this intensively. ETSI started with a big kick by that. By the way, this is done within the 6G, let's say, approach of moving forward. You have to know that in telecom, there's already today in internet a protocol called MCP, for people who are interested, which is mostly pushed by Anthropic, which is being used, but it's not like tailored for the case of wireless that we need. And so this is why 3GPP is now intensively working on that.
Okay, thank you very much, and this is the end of this session. And don't forget that AI does not exist without networking, any kind of networking. Okay, thank you very much.
Thank you.
Thank you.
Thank you, Meran.
Great.
Ναι. Θα έχεις παρουσιάσει και εσύ ή θα έβαλες, έτσι. Α, οκ. Οκ. Θα μιλήσω εγώ πρώτα, πω εγώ. Ναι, όχι, έτσι το είχα. Μετά εσύ και μετά ο Βαγγέλης.
Εδώ,
Hello, good afternoon, everybody. Welcome to this session that that's going to actually show you how artificial intelligence and engineering can lead to actual results that make an impact in industry, in economy, in society. I'm Panos Ferlis, I'm from the School of Mechanical Engineering. I would like to welcome you all. I can see a lot of students from Aristotle University here, graduate students. We also have people working at the administration of Aristotle University, and we have people representing the board of the university, and we have also a very strong delegation from Western University, from London, Ontario, Canada, spending these days in Thessaloniki, and also have participated in the Aristotle Innovation Forum, working together in a joint master's program. But let me actually go into my presentation. AI is a game changer in climate crisis. Okay, let me introduce you to the team. Some of these people, you can identify them in the audience today, but this is a combined effort for the last at least 10 years working on the subject. Funded by European Union projects over the years, and collaboration with the Center for Research and Technology, HELAS, that's CERT. Okay. What's the motivation here? Okay, in Greece we have 71.5 million tons of CO2 equivalents emitted per year. And how these emissions come from? They come from power generation, from manufacturing, from transportation, from any other activity that involves the combustion of fossil fuels. What do we see? We don't pay much attention to all that because, okay, there's no counter that tells us that CO2 may actually is affecting our lives. But we see the effects in forest fires that are very common the last few years in Greece, flooding as the aftermath of the forest fires, and that's from my car recorded 45.5 couple of summers ago. Okay, so what do we do with that? Okay, we don't want to disrupt the economy, we don't want to stop fossil fuels and go back to the Bronze Age. Okay, we'd like to actually move forward, and we'd like to provide solutions that they ensure a smooth transition from the current status to a status that gives us a better perspective for a sustainable future. Okay. So the solution for that is solvent-based CO2 capture. So we have the point where we have the emissions, that's the exhaust gas down here, and the exhaust gas contains, is a mixture of gases containing carbon dioxide, nitrogen, oxygen, water in the form of vapor. And we would like to remove the carbon dioxide out of this stream. How we do that? We bring the exhaust gas in contact with a chemical solvent. This chemical solvent has a great desire to chemically bind, to chemically react with CO2. So they want to hold hands together. And after that, then it means that the CO2 goes from the gas phase to the liquid phase to the solvent. So what you have at the exit is a exhaust gas that doesn't contain CO2 or the CO2 concentration has been decreased enormously by almost 90 to 95%. So we have a clean exhaust gas. Now, CO2 is in the form of a liquid with the chemical compound, and of course we need to somehow release that CO2 by adding some heat, so the heat breaks the bond. So CO2 comes in pure form at the right-hand side over there. The solvent can be reused to continuously remove CO2 from the exhaust gas. So CO2 is in a pure form. We can store it for some years until we know what to do with it. We can utilize it in producing other products, but we cannot talk about everything today. And or store it geologically in some places. So the point here, the question here is, how can we actually make this process economically viable so we don't see our energy bills going skyrocketing, because this is very expensive to make the power generation cleaner, to make manufacturing cleaner, to make transportation cleaner. So we like to find out a way how to make this process economically viable, efficient, and feasible. So we have to start with the materials. Which is the best solvent that actually captures CO2 in the most efficient way? So there are millions of choices over here. What is the equipment to bring together, to bring into contact the gas and the liquid phase? In what kind of equipment? And then we like to operate under real conditions, and you know, in real plants, you don't have, let's say, the flue gas with a composition that stays constant. It varies all the time because the fuel composition may change. So we like now to work on all these different levels of designing our process. Okay, let's see now how AI would actually help us. Just to give you an idea of the extent of the problem, we need to work at the molecular level and identify the best working solvents for CO2 capture. Then we would like, after we identify those molecules, we would like to introduce them in a process equipment and the process flow sheet to do the capture. And then we would like to assimilate the real operating conditions. Also imagine and consider that you have a lot of impurities in your fuels that may affect the performance of the capture. So I would like all these to see it within a unified framework, to see them all together. So from the molecule to a big industrial plant. The different scale is enormous. So let's see now how we can use AI and mathematical models to help us do that. Consider each molecule like a big Lego synthesis, okay? And each molecule is considered by little Lego pieces. And each Lego pieces is one specific chemical group. Every time I add one specific Lego tile, okay, I also introduce some properties to my molecule. Now, I would like to I have all the Lego tiles available. These are all the chemical groups, and I would like to make combinations, of course, feasible combinations that chemistry allows, and I would like to target specific properties for my molecule. I don't have one single criterion to evaluate my molecules. I have multiple criteria. Imagine that you like to buy a car, okay, and so you want a fast car, but you want a car that doesn't consume too much gas. You like a car that looks beautiful to you, but on the other hand, you have a constraint on the money you have in your pocket. So you cannot actually, with your decision, satisfy everything. So over here, you can see that I have chemical properties and physical properties that I need to specify to do the work that I want the molecule to do. I also have sustainability metrics about the molecule. I don't want to have a very toxic molecule that if I have some leakages, then that would be disastrous. So I would like now to satisfy as much as possible all these performance criteria. And imagine I have millions and millions of combinations of chemical groups combined together. So cannot be done by just looking at the charts. You cannot actually, you need the mathematical models, you need the computational power to actually do that. You may have models for the properties, you may have data for the properties. So you have hybrid models that you want to use. How to actually do all that? You need also equipment, innovative equipment that can actually reduce the size of the equipment. So rotating packed beds as this one are innovative new equipment that can actually reduce how much space I need in order to do my capture. Consider that the flue gas comes in enormous volumes, so that would require, with conventional equipment, very tall towers. Sometimes if you drive by, let's say, a cement plant, you'll see those big kilns. Those columns would look exactly like those. So I would like now to have my molecule running through this process, and I would like to design my process. So I can achieve the capture rate I want, and in an economic way, in a way that can actually absorb all the disturbances I may have on my exhaust gas, on the performance of the solvent. So before going to the large unit, you can actually, it's better to test everything in the lab. So you can see here the schematic that we saw before and the optimized process at the laboratory scale pilot plant. Over here you can see the two in the middle, like with the, okay, I don't know if it's worked, but it doesn't show over here. Anyway, you can see the rotating packed beds, those with the aluminum foil, that's insulation for that. And you have a system that operates that, a control system that operates the unit, so you can actually handle any disturbances you may have in your system. And eventually you get up the performance. So we have used our knowledge, the mathematical models, the data-driven models, in order to identify the proper molecules for the capture, the suitable flow sheet for the capture, which actually the miniature of that, you see it over here. You have the control algorithms to work under real-time conditions to ensure that the performance of the unit is within the specification. So my point here is, if you do it correctly and you feed your artificial intelligence models with the correct information, not just any data, not just any model that looks good, but something that has been validated with experiments, with at the molecular level or at the process level, at the equipment level, you can actually see when you go to the design of such units, you achieve the result that you want. So my message here is that models, if you do it correctly, do actually work. So now it's not just let me do some AI on something, you have to do it correctly to come up with something that works. Okay, and that was at the lab scale level. Now you see that all this technology can actually go to industry. So this is a demonstration unit of as part of a European funded project called High Record. This is located in Volos, about 2 hours south of here, in a quicklime plant, aiming to capture 10 tons of CO2 per day. It's a demonstration plant. Of course, the actual capacity of that, the quicklime plant, is much larger, but this is the capture plant, the demonstration level with rotating packed beds, and a novel solvent provided by one of the partners in this project. So the operation commenced just 2 days ago. Okay, it was supposed to start up at least 2 months ago, but you know, in reality, a lot of things can go wrong. So we already have recorded 11 hours of operation and counting, out of 650 that we're going to use. That same plant, which is modular, will be dismantled, transported to another site in Greece at a gas-fired power plant in near Athens, operate there for a few months, and then dismantle and assemble again in a refinery here in Thessaloniki. So that would actually show us how, starting from a single molecule, okay, you can come actually to a real plant. So, conclusions: AI tools are powerful when the input information is accurate. We were able to identify highly performing CO2 capture solvents, design optimal, complex CO2 capture plants, and we were able to efficiently operate those under real-time conditions for a sustainable future. Of course, apart from the work in our group, the plant that you've seen is also the combined effort of the partners in this European funded project. High Record, you may want to visit the website, just type High Record and it will show up, and you can follow in real time the operations of the plant. So that would be the first presentation of this session, and I would like to also introduce our next speaker. That would be Professor Michalis Georgiadis from Chemical Engineering Department at Aristotle University of Thessaloniki, who will actually discuss a little bit more on the optimization that was embedded within all these design tasks that we had in this development, but also talk to us about energy system optimization in general. So, Michali. Όχι, όχι, όχι. Πού το ζω. Έτσι γίνεται κάθε φορά. Πού είναι το παλέτα. Έλα. Αυτό συμβαίνει και σε μένα. We need AI to help us here. Έλα. Πού είναι το δικό του. Από εδώ αλλάζω.
Okay, good morning everyone. Thank you, Pano, for the introduction. So what I'm going to present you today is part of the work that we have been doing in my group for the past few years, illustrating a different way of addressing climate changes through the optimization of energy management in the process industries. So what is the objective of our work is to explore the synergistic benefits between machine learning techniques with optimization techniques for the optimization of energy management in the process industries. In other words, energy-intensive industries like cement industries, metal processing industries, chemical industries, and other. So the approach is based on mathematical programming techniques, optimization techniques, in order to illustrate how renewable energy systems and how energy storage technologies can significantly contribute towards the decarbonization of the process industries. The same framework, while it will address mainly operational issues, what is happening every hour or every day, we will see how we can assess, using this framework, how we can assess different investment technologies, especially in the context of energy storage, battery energy storage. And then I will also present you how these techniques can be illustrated, can be applied in an industrial case studies. And of course, acknowledgements to members of my group. So the very basic idea here is how we use artificial intelligence. In the context of this work, and not only, AI is not taking optimal decision. AI is not optimization. AI is not suggesting anything, but AI is making predictions. And predictions are very important in our framework, because if the predictions are wrong, then the models will be wrong. If you feed garbage in our models, you will get garbage. So we use AI techniques to predict what? The load, to predict the energy prices, to predict the availability of renewable energy generation, and a number of things for which you have available data at hand. So the main idea, in other words, is let's use AI through machine learning techniques to make predictions in order to provide them as an input in our optimization framework. And this is the conceptual framework of our work, and it is based on the work that we did jointly with the chemical industry. Eftimis is here through a different role. All right, the main idea is how to consider for an industry, an energy-intensive industry, how we can integrate renewable energies like photovoltaic, like wind energy, and also alternative energy sources, like, for example, waste-to-energy technology. And what we want to do, we want to minimize the consumption of electricity. In other words, electricity cost. And we want to explore if this industry participates in the electricity pool market, how it can gain, how it can secure some benefits by its participation in the pool market, and I will show you in a moment what this participation is all about. So the methodology relies on a number of very basic steps. In step one, you need to spend a lot of time on preparing the data, collecting the data, assessing the data, and in step two, you formulate the optimization problem. I will not show you the details of the optimization problem, but in principle, we use mathematics to describe the industrial process at hand. We describe what is happening in the plant in terms of the daily operations, in terms of the manufacturing products, in terms of the operation of the machines, in terms of the involvement of personnel, in terms of the utilization of other resources. And finally, all this framework should be validated, should be implemented in an industrial case study to assess potential benefits. Here are some very basic results about forecasting. And what we can see here is we have used extensive data, and you will see that machine learning is performing relatively good, and some of the predictions regarding the load are quite close to the actual data. And here what I can see is some of the indicative results, assuming that we have a hot semester day during the summer. We see how the industry participates. We can see the various energy sources that we have here. We can see here with the yellow line how the photovoltaic will operate. Okay, we see with the blue line is what the industry will purchase from the grid. We'll see with the green line the load, and importantly, we will see with the red line that the industry can in principle sell energy back to the grid and make extra profit. This is very important. It is the so-called, let's say, load demand management. In nowadays, energy-intensive industries can get millions of euros by simply doing nothing. If the operator calls them and tells them, you need to shut down the production, they can simply, this is a participation in the energy market, they can simply gain money, create profit by simply producing nothing. But they offer, in this way, extra capacity of electricity in the network. In the right-hand side figures, what we see is important information, how the energy mixture is, what is the profile of the energy mixture in terms of the photovoltaic, the battery, and the grid over time, on an hourly basis or even more frequently for a hot semester day. And oops. Now, using this framework, it is also important to assess potential energy investments. Energy investments in terms of what? Mainly in terms of battery energy storage opportunities. And we see here that we have two energy investment options for two types of batteries with different power and capacity. And we consider two cases without any subsidy and with 30% subsidies. Subsidies in the European Union regarding energy storage exist, are important, and they play an important role towards the practical realization of this kind of investment. What we can see here is that by investing on a battery energy storage system, we have the company will generate profit, the return of investment is reasonably good, and if the company manages to secure a subsidy, we have significantly improvements in the profit and also in the return of investment. And this was done using the same mathematical framework, which was originally designed to take decisions, operational decisions, on an hourly basis, on a daily basis. So, in summary, what we managed to achieve is that the figures here are not actually in euros, are relative money units. We don't have we are not allowed to disclose any information about actual money. And what we saw is that the installation of a battery energy storage system with some design charge discharge characteristics can significantly contribute to the reduction of the electricity cost with the corresponding CO2 emissions and define a reasonably distributed energy mixture, including energy purchased from the network, from the grid, photovoltaic production, and battery energy system. And what you will see here, especially in the right-hand side figure below, is the real operation of the battery, how the charge and discharge profile are evolved over time. And here is information about the actual profile of the energy, a lot of significant information, a lot of details over the time. And some comparative, very interesting results, and as I said, all the amounts are in relative money units and not in actually euros. This is confidential information. We started in the first row with the current status in the company, and then we can see what kind of improvements can be achieved by participation in the energy market, by installing a battery energy storage system. And the last row is interesting, but it requires further investigation, is for the special case where the industry wants to investigate a waste-to-energy system. This is an alternative energy source. The study was very preliminary because by installing a waste-to-energy system, you need to place specific attention to the... I'm not expert in this area, but Panos better knows you're going to have CO2 and other gas emissions, which require extra treatment, and you need extra capital, of course. So it's not only decisions in terms of the energy that you're going to gain, it's also a matter of the investment that you will also make here. So, in summary, currently this work is, let's say, limited to the case where the production is fixed. What has it been fixed? The company produces the product according to the demand imposed by the customers. So you have this specific production over this week of time, and this defined immediately the energy requirement in the company. And of course, different achievements at different levels, and of course there are a lot of next steps that we may consider in the future. Now, what is going to happen, however, when the company takes the decision to modify its production, to modify its production plan, its production scheduling, considering the prices of the energy? In other words, if the energy is very expensive, shut down the production, reduce the production. If the energy is cheap, get the energy from the grid, store the energy, use it to produce as many products as possible. And then, in the case you have excess of energy, sell it later if the energy is more expensive. It is the well-known energy arbitrage. And this actually is based on an excellent diploma thesis from one of my outstanding students. And here is, the objective is to shift the load to off-peak hours, taking into account what is happening in the energy market. We are limited so far to the day-ahead market. In other words, we know the day before, we can predict what is happening the day before in terms of energy prices by using AI, and this is that we also did, and try to solve an integrated problem that takes into account the energy prices, the energy conditions, the multi-energy mixer, along with the production decisions. And of course, the ultimate objective is to enhance sustainability, reduce the carbon footprint, allow the company to keep full production flexibility, and at the same time, this flexibility should be achieved by minimizing energy cost. And so we have here the plan. As I said before, the important thing is to mention that we are limited to the day-ahead spot market, but keep in mind that this work we are now working on the extension of this work to the other type of markets. We have the balancing market, what is happening every second, every minute. We have the intraday market. This is also very important, what is happening in the day. We have the auxiliary service market, and this can be also extended in this kind of markets. And of course, now the idea is where energy is consumed. Energy is consumed. It is a function of the production plan that you have. And at the same time, you have the flexibility, the company have the flexibility. Of course, there are some regulatory decisions to be taken. It's not like you go and sell the energy in the grid, sell it back to the grid. And how much time I have, I don't know. This is the very basic idea. This is the overall energy balance of the system. We have the day-ahead spot market. You go, you purchase it, the company purchases energy from there. It may decide, according to using the optimization framework, to store part of this energy utilizing a battery energy system. At the same time, we have photovoltaic, we may have wind park, we may have an alternative energy generation system. And all this energy now goes where? To cover, on the one hand, the energy requirements of the industries, which are strictly defined by the production plan, and at the same time, whenever it is necessary, sell the energy back to the grid, potentially at higher prices. And now, we have considered I don't want to take much of your time. How much time do I have? Yeah? 2 minutes. We have considered different cases, all right? Cases where the energy demand is low, is high, for different energy prices formats, for different periods, for different profiles. You don't want to know much about the optimization models. the main idea is we use maths to describe what is happening in the plant very accurately, considering all the type of constraints that exist in the plant. Constraints in terms of the available resources, constraints in terms of the equipment, constraints in terms of the changeovers of the production, which results in cost, and several others. And we have two types of objective functions, two main targets that you may wish to consider. The changeover minimization. Changeover minimization in the production means you reduce operating cost at plant. You reduce the number of changes from the one production plant to the other, which imposes costs and time losses. This is the well-known changeover minimization problem. It's a problem that directly results into operating cost. And the second objective, of course, is energy is expensive, is to reduce the electricity cost. So for very, very different cases now, different case studies, here, what we can see is that for cases C and D, the company, again, this is our relative money unit. I mean, this, you may need to multiply this by a number, I don't remember the number, but for some cases, we can see that the company can generate profit by participating in the market and at the same time by modifying its production plan. And here is an indication of the production plan, the sequencing of the products, and what we can see here, for example, is the various products, how they are going to be, what is the sequencing of production over the time, and for different energy demands and product demands constraints. And now we have a lot of results for the two objectives. You can see here for the changeover minimization on the left-hand figure and for the electricity cost minimization leading to different cost reduction. And here we can see the profiles that we have of the energy mixture. And in principle, we can achieve a significant cost reduction by employing optimization. Here is another profile that it shows clearly that with the red line, the company can sell energy back to the grid in order to increase its profit. And there is a lot of information here that can be assessed by the decision-making of the companies. And finally, and I'm closing in a minute, is again, with the same way, using the same framework, the company is able to assess what are the benefits by investing on energy storage, in particular on battery energy storage. We have used some realistic cost figures here, and what we can see, okay, especially if you have a subsidy, again, the return of investment, the profit over a 20-year time horizon is important. And so, concluding my presentation is that by considering an integrated approach, energy management and production, significant benefits can be achieved for the energy-intensive industries. And these benefits are mainly realized by the arbitrage. Arbitrage means the difference between the price that the company purchases the electricity and the price that the company sells the electricity to the grid. A lot of open issues regarding the various investments. And we have mathematical models which can be used also to take production scheduling decisions. And finally, we have the broad impact that is according to Panos' introduction in the first slide. We have economic and financial impact, but not only. By reducing energy consumption from the grid, you achieve environmental, public health impact, and also broader social and public benefits. And finally, this framework can also provide the basis for the electrification of the process industries. Electrification means large investments by replacing some of the equipment, electric equipment, by replacing equipment that was relying on the use of natural gas or oil or whatever, and make it an electric equipment. So electrification is also an option that can be easily considered in this framework by applying some extension. Thank you very much.
Okay. Πείτε μου. Our third speaker is now coming from the regional government, the Department of the Environment, that is going to monitor that the emissions are kept within the limits, and the targets that they set are within the plan that they have filed with the government authorities. So Evangelos Malkakis is has a degree in environment engineering, and he's the head of the environment department for the prefecture of Drama. And the important thing here is also how to monitor emissions. You cannot actually have like an agent at every industrial site, but you can actually use the data of operation, the data that each industry has to do that effectively. It's not an agency that comes like to punish industry, but actually to help society as a whole, industry as well, because it's also the benefit of industry to also have clean manufacturing. So, Vangeli, the floor is yours.
Πάνω ευχαριστώ. I would like to welcome you to Greece, to Thessaloniki, to northern Greece and to Macedonia. Πάνω, σε ευχαριστώ πολύ. Ευχαριστώ πολύ για την τιμή που με καλέσατε για να δείξω αυτά που κάνουμε σαν δημόσιος τομέας. Εντάξει, είναι οκ. Στο κομμάτι και της αδειοδότησης και του ελέγχου, αλλά και της περιβαλλοντικής διαχείρισης, που φυσικά στο τέλος έχει να κάνει με τις εκπομπές του διοξιδίου του άνθρακα. Ερχόμενος εδώ, σκεφτόμουν τι με συνδέει με το Αριστοτέλειο, μια και δεν είμαι πτυχιούχος του Αριστοτελείου. Το πρώτο που με συνδέει πρόσφατα είναι η γνωριμία με τον Πάνο, όταν μιλήσαμε μαζί και είδα τι πάθος έχει για αυτό που κάνουν στην ομάδα τους. Βέβαια, μετά κατάλαβα ότι με συνδέουν και άλλα πράγματα. Με συνδέει ότι η μητέρα μου είναι πτυχιούχος του Αριστοτελείου, φιλόλογος στην εποχή του Κακριδί και του Ανδρώνικου, τους καθηγητές. Και επίσης πολλά μέλη της ομάδας μας είναι τέκνα του Αριστοτελείου, πτυχιούχοι, και οι γεωλόγοι, κυρία Μπαρούτη και κυρία Καϊκή, και η χημικός, μηχανικός της ομάδας, η κυρία Βασιλιάδου. Για να δούμε, θα δω να σας δείξω τι κάνουμε σαν ομάδα σε σχέση και με την κλιματική αλλαγή και με την διαχείριση την περιβαλλοντική. Θα φύγουμε από το μικρό κόσμο που είχαμε πιο πριν, θα φύγουμε από τη μακροοικονομία, από τη μικροοικονομία και θα πάμε στο μακρόκοσμο. Τι κάνει η περιφέρεια, ένας φορέας δημόσιας διοίκησης? Κάνει περιβαλλοντική αδειοδότηση, κάνει περιβαλλοντικούς ελέγχους και κάνει περιβαλλοντικές ρυθμίσεις, θέτει περιβαλλοντικές ρυθμίσεις, σχεδιάζει και λαμβάνει αποφάσεις. Τι χρειάζεται για να τα κάνει όλα αυτά κανονικά? Χρειάζεται δεδομένα και φυσικά αυτά που κάνει η δημόσια διοίκηση δημιουργούν δεδομένα. Όταν ξεκίνησα την παρουσίαση να τη συντάσσω, σκέφτηκα για να δω τι γινόταν 50 χρόνια πριν. Δεν θεωρείται κάπου ένα πολύ μεγάλο. Κάποιος μπορεί να το χαρακτηρίσει μεγάλο, μικρό διάστημα, κάποιος άλλος μεγάλο. Για να δούμε πώς ήταν τα δεδομένα μας 50 χρόνια πριν, το 1980, έτσι, αριστερά, και πώς είναι τα δεδομένα μας το 2030 ή πώς θα είναι. Έχουμε τεράστια έκρηξη δεδομένων. Εδώ βλέπουμε από το 80 μέχρι το 2030 πόσο μεγάλη αύξηση στα δεδομένα που έχουμε, και αυτό φυσικά έχει να κάνει με την εξέλιξη της τεχνολογίας, με την εξέλιξη των πομπών, με την εξέλιξη των ανιχνευτών, με την εξέλιξη των δορυφόρων. Άρα, έχουμε ένα τεράστιο ποσό δεδομένων, ένα τεράστιο μέγεθος δεδομένων. Για να δούμε η δημόσια διοίκηση πώς δημιουργεί δεδομένα. Αυτή είναι η εφαρμογή μας που έχουμε φτιάξει. Δεν βλέπουμε την εφαρμογή όμως.
αυτές εδώ.
Η δημόσια διοίκηση λοιπόν χρειάζεται δεδομένα υποβάθρου. Εδώ βλέπουμε τις προστατευόμενες περιοχές. Χρειάζεται άλλα δεδομένα σε σχέση με τα γεωφυσικά δεδομένα και τις ρυθμίσεις και παράγει δεδομένα. Εδώ βλέπουμε τις αδειοδοτήσεις τα τελευταία 40 χρόνια στην ΠΕ Δράμας, στην περιφερειακή ενότητα Δράμας, που δεν είναι απλά κάποιες κουκίδες, είναι και πληροφορία, και ποιοτική και αριθμητική. Φυσικά όλοι αυτοί εδώ που βλέπουμε είναι η δυνητική εκπομπή διοξιδίου του άνθρακα. Οπότε έχοντας όλα αυτά τα δεδομένα μπορούμε να τα χρησιμοποιήσουμε προκειμένου να δούμε τι γίνεται με τις εκπομπές του διοξιδίου του άνθρακα και να τις διαχειριστούμε και να προτείνουμε λύσεις. Έτσι απαιτούμε δεδομένα και δημιουργούμε δεδομένα. Με αυτά λοιπόν τα λειτουργικά συστήματα και με την ενσωμάτωση του AI σε αυτά, έχουμε τον αυτοματοποιημένο έλεγχο των μελετών περιβαλλοντικών επιπτώσεων. Έχουμε την πρόβλεψη περιβαλλοντικών επιπτώσεων και τη χωρική ανάλυση μέσω του GIS. Ταυτόχρονα, εκτός από την αδειοδότηση, ένα μεγάλο κομμάτι στη δημόσια διοίκηση και στην περιφέρεια είναι η πραγματοποίηση των ελέγχων, οι οποίοι είναι πάρα πολύ δύσκολοι στο κομμάτι των δεδομένων που πρέπει να έχουμε για να κάνουμε ένα σωστό περιβαλλοντικό έλεγχο και των εργαλείων. Στη δικιά μας υπηρεσία, χρησιμοποιώντας τεχνολογίες εχμής, τάμπλετ, ασύρματους printers και ειδικά λογισμικά όπως το Field Maps, στο πεδίο χρησιμοποιούμε όλη αυτή την τεχνολογία προκειμένου όλη την πληροφορία που έχουμε στο γραφείο να την έχουμε στο πεδίο για να κάνουμε σωστότερα τον έλεγχό μας και όχι μόνο online, αλλά και offline. Έτσι έχουμε την αυτόνομη συμπλήρωση του φύλου ελέγχου, έχουμε αυτόματη εφαρμογή των pages στο tablet προκειμένου να συμπληρώσουμε το φύλο ελέγχου, έχουμε πλήρη συμπλήρωση και σύνταξη του φύλου, ασύρματη σύνδεση για να δώσουμε στον ελεγχόμενο τα αποτελέσματα της αυτοψίας, έχουμε ασύρματη εκτύπωση και πάλι και σε αυτή την περίπτωση δημιουργούμε και παίρνουμε δεδομένα. Έτσι έχουμε αυτοματοποιημένο εντοπισμό των παραβάσεων, έχουμε παρακολούθηση σε πραγματικό χρόνο των διαπιστώσεών μας και με τη χρήση drone και εικόνων μέσω του AI ακόμα καλύτερη και ολοκλήρωση του ελέγχου. Πολύ σημαντικό όμως εδώ είναι ότι έχουμε στο πεδίο κατευθείαν διαθέσιμα τα ιστορικά δεδομένα από άλλους ελέγχους και έτσι υποστηρίζοντας το έργο των επιθεωρητών έχουμε αυτόματη επεξεργασία των αναφορών που παίρνουμε επί τόπου. Έτσι και με την αδειοδότηση και με τον έλεγχο παράγονται πάρα πολλά δεδομένα. Τα big data όπως ξέρουμε και αν προσθέσουμε και τα δεδομένα των δορυφορικά και των ανιχνευτών δημιουργούνται ένα μεγάλο μέγεθος δεδομένων που δημιουργεί όμως κάποιες προκλήσεις. Ποιες είναι αυτές οι προκλήσεις? Είναι η πρόκληση της πρόσβασης. Πρέπει να έχουμε πρόσβαση σε αυτά τα δεδομένα. Πρέπει να έχουμε φιλτράρισμα στα δεδομένα, επεξεργασία τους. Επίσης, πολύ σημαντικό, να καταφέρουμε ιστορικά δεδομένα που πολλές φορές είναι περιγραφικά, να τα βάλουμε μέσα στο σύστημα προκειμένου να μας υποστηρίξει στην υποστήριξη της λήψης απόφασης. Να κάνουμε εξατομικευμένα αποτελέσματα, να καταφέρουμε το deep learning και να έχουμε στο τέλος, το οποίο αυτό είναι το ζητούμενο, σωστές αποφάσεις. Εδώ λοιπόν τα τελευταία χρόνια εμφανίστηκαν μπροστά μας τα AI Assistants και τα AI Agents. τα γνωστά μας, τα οποία φαντάζομαι όλοι μας έχει τύχει να χρησιμοποιήσουμε κάποια από αυτά, τα οποία τι κάνουν αυτά τα AI assistants και agents, ανταλλάσσουν αιτήματα, ανταλλάσσουν απαντήσεις και ανταλλάσσουν δεδομένα. Άρα μας βοηθάνε να χρησιμοποιήσουμε όλη αυτή την ποσότητα των δεδομένων για να πάρουμε τις σωστές αποφάσεις. Έτσι έχουμε μια επανάσταση. Έχουμε μια επανάσταση των APIs, τα οποία τι είναι τα APIs, είναι τα Application Programming Interfaces. Είναι μικρά προγράμματα, τα οποία ουσιαστικά συζητούν μεταξύ τους, επιτρέπουν πολλά συστήματα να ανταλλάσσουν μεταξύ τους δεδομένα και λειτουργίες και συντάσσουν και συνθέτουν τα απαραίτητα για μας περιβαλλοντικά δεδομένα. Έτσι έχουμε αυτοματοποίηση των διαδικασιών στον μακρόκοσμο, ανταλλάσσουμε δεδομένα, δημιουργούμε dedicated, ειδικά applications, mobile apps και websites για να μας βοηθήσουν στη λήψη απόφασης, εξοικονομούμε τεράστια ποσότητα χρόνου, επιτρέπεται η συνεργασία μεταξύ διαφόρων συστημάτων και κάνουν τις εφαρμογές μας πιο ευέλικτες και πιο ισχυρές. Έτσι έχουμε μια δημοκρατία των APIs. Γιατί το λέω δημοκρατία των APIs? Γιατί μέχρι πριν από 2-3 χρόνια δεν θα ήταν αυτά προσβάσιμα σε πολλούς από τους μελετητές, σε πολλούς από τους ερευνητές, σε πολλούς από αυτούς που ασκούν δημόσια διοίκηση. Έχουμε τώρα τα AI assistants και agents προκειμένου να έχουμε έτοιμο κώδικα, τον οποίο θα το συνθέσουμε σαν το Lego που είπε ο Πάνος πριν, στο μακρόκοσμο απλά, για να διαμορφώσουμε και να προγραμματίσουμε πια πολύ εύκολα. Και φυσικά σε εμάς που ο χώρος έχει πολύ μεγάλη σημασία, δημιουργείται μια ιδιαίτερη κατηγορία που λέγεται Geo-AI, που έχει να κάνει με τη χρήση των AI στο χώρο, με τα γεωχωρικά δεδομένα, που χρησιμοποιεί δορυφορικές εικόνες, δεδομένα GIS και δεδομένα από αισθητήρες και drones και εφαρμόζει τεχνικές AI για μηχανική μάθηση, για την ανάλυση εικόνας, προκειμένου να κάνουμε σωστά και να εντοπίσουμε διάφορα ευρήματα στο πεδίο και να προβλέψουμε το πολύ σημαντικό και να έχουμε μοντελοποίηση. Πρόβλεψη. Πρόβλεψη. Τι είναι πρόβλεψη? Τι μας βοηθάει στην πρόβλεψη? Τα μοτίβα. Αν είχαμε τα δεδομένα μας σε ένα Excel, δεν μπορούμε εύκολα να εντοπίσουμε τα μοτίβα, ειδικά στο χώρο. Όταν έχουμε σε ένα dashboard όμως σαν αυτό που βλέπετε εδώ, το οποίο φτιάχτηκε για να δούμε κατά πόσο οι μετακινήσεις των μαθητών στα σχολεία της Ράμας συμβάλλουν στην εκπομπή του διοξιδίου του άνθρακα, ανάλογα με τον τρόπο μεταφοράς των μαθητών, βλέπουμε πια τα συγκεκριμένα μοτίβα. Στο χώρο βλέπουμε οι μαθητές κατά πόσο μετακινούνται με λεωφορείο, κατά πόσο μετακινούνται με γιοταχή ή μετακινούνται με τα πόδια, οπότε αντίστοιχα έχουμε την αντίστοιχη επίπτωση στην εκπομπή διοξιδίου του άνθρακα και στο τέλος μαθαίνουν οι μαθητές πώς μπορούν να συνεισφέρουν στις εκπομπές αυτές. Πόσα δέντρα μπορούν να φυτέψουν προκειμένου να εξοικονομήσουν το διοξίδιο του άνθρακα που εξέπεμψαν για να μετακινηθούν στο σχολείο τους. Μοτίβα όχι μόνο στο χώρο όμως, αλλά και στο χρόνο, που είναι πολύ σημαντικό. Εδώ θα το δούμε σε λίγο, το dashboard που αφορά τις στάθμες των γεωτρήσεων στην περιοχή, στη λεκάνη της Ράμας, με βάση όμως ιστορικά δεδομένα. Δυστυχώς, πολλές φορές έχουμε δεδομένα πολύτιμα τα οποία τα πετάμε. Χάνονται σε κάποια συρτάρια ή ακόμα και πετιούνται στα σκουπίδια. Στην υπηρεσία μας εμείς όμως καταφέραμε δεδομένα από το 60 και το 70 που αφορούν τις γεωτρήσεις της λεκάνης της Δράμας να τα χρησιμοποιήσουμε, να τα βάλουμε με AI μέσα σε αυτό το σύστημα και θα σας το δείξω. Να μας υποστηρίξουν στη λήψη απόφασης. Ουσιαστικά αυτό είναι ένα API, έτσι. Είναι ένα προγραμματιστικό εργαλείο με βάση την AI, την Artificial Intelligence, και βλέπουμε τις διάφορες γεωτρήσεις που έχουμε ιστορικά δεδομένα στη λεκάνη της Ράμας και αφού επιλέξουμε την ενδιαφερόμενη γεώτρηση, μπορούμε ταυτόχρονα να δούμε τις αλλαγές στη στάθμη της μέσα στα διάφορα χρόνια που έχουν περάσει. Καταλαβαίνετε πόσο σημαντικό είναι αυτό για την πρόβλεψη της κλιματικής ανθεκτικότητας για τη λεκάνη. Ειδικά όταν συνήθως τα δεδομένα είναι από το 2000, από το 1990 οργανωμένα. Όταν έχουμε και τα ιστορικά δεδομένα που πάνε ακόμα πιο πίσω, είναι τελείως διαφορετικό το παιχνίδι. Πραγματικά η artificial intelligence γίνεται game changer, όπως είναι το θέμα μας. Έτσι, με αυτά τα APIs προβλέπουμε κινδύνους, κάνουμε έγκαιρη προειδοποίηση, διαχείριση των φυσικών πόρων, καταφέρνουμε να βελτιώσουμε την ανθεκτικότητα της γεωργίας, κάνουμε συνεχή παρακολούθηση του περιβάλλοντος και φυσικά αυτός είναι ο κύριος σκοπός μας, είναι να υποστηρίξουμε τις στρατηγικές αποφάσεις της διοίκησης. Γιατί σχεδιάζουμε πολιτικές, αξιολογούμε σενάρια κινδύνου και επιλέγουμε τις καλύτερες λύσεις για πιο αποτελεσματικές πολιτικές και ανθεκτικότητα. Ένα τέτοιο παράδειγμα είναι στο επόμενο χρονικό διάστημα το περιβαλλοντικό παρατηρητήριο της Περιφέρειας Ανατολικής Μακεδονίας Θράκης. Στο πλαίσιο αυτού του παρατηρητηρίου θα εγκατασταθούν πάρα πολλοί ανιχνευτές δεδομένων περιβαλλοντικών, αλλά το πιο σημαντικό ποιο θα είναι, ότι μέσω APIs, μέσω της AI, θα καταφέρουμε όλα αυτά τα δεδομένα, τα καινούρια, τα παλιότερα και τα ιστορικά, να μιλήσουν μεταξύ τους και να μας υποστηρίξουν συνολικά στη σωστή λήψη απόφασης. Αλλά βέβαια, φεύγοντας από το τεχνοκρατικό πράγμα της AI, το πιο σημαντικό είναι ότι, ωραία, τα έχουμε όλα αυτά, θα τα χρησιμοποιήσουμε, μπορούμε μάλλον να τα χρησιμοποιήσουμε, θα πρέπει να δούμε κατά πόσο θα τα χρησιμοποιήσουμε και κατά πόσο αυτά πραγματικά θα έχουν αποτέλεσμα. Αυτό γίνεται μόνο όταν θα έχουμε διοικητική ωριμότητα και θεσμική ωριμότητα, δηλαδή θα συνειδητοποιήσουμε το πρόβλημα και το τι πρέπει να κάνουμε γι' αυτό. Θα πρέπει να έχουμε διαφάνεια και συμμετοχή της κοινωνίας. Χωρίς την κοινωνία δεν θα αποτύχει κάθε σύστημα πάνω σε αυτό το θέμα. Ξέρετε, ένα μεγάλο μέρος της κοινωνίας είμαι σε ακόμα πιο αρχικό στάδιο και πιστεύει ότι δεν υπάρχει η κλιματική αλλαγή και μάλιστα όταν πιστεύεις ότι δεν υπάρχει κλιματική αλλαγή δεν θεωρείς ότι πρέπει να γίνεις και κλιματικά ανθεκτικός, έτσι. Οπότε δεν κάνεις τίποτα. Άρα είναι πολύ σημαντικό να συμμετέχει η κοινωνία σε όλες αυτές τις αποφάσεις. Να έχουμε μοντέρνα εργαλεία. Δεν μπορεί να κάνουμε όλα αυτά με παλιά εργαλεία, με παλιές νοοτροπίες. Θα πρέπει αυτά τα μοντέρνα εργαλεία στα συστήματα λήψης απόφασης να έχουν εφαρμογή. Και να εξυγχρονίσουμε ουσιαστικά, να φύγουμε από τη δημοκρατία των APIs που είπαμε, να φτάσουμε στην δημοκρατία για την αντιμετώπιση της κλιματικής αλλαγής. Και σε αυτό το σημείο ευχαριστώ για την υπομονή σας και εκ μέρους της ομάδας της συνολικής, γιατί όλα αυτά γίνονται από ομάδες, θέλω να σας ευχαριστήσω.
I hope you had an overview of AI applications in mitigating the effects of the greenhouse gases emissions. You had an idea of how industry can actually utilize optimization and mathematical models to increase their revenue by working efficiently and investing on energy storage solutions, scheduling their production, their manufacturing in a way that can provide benefits for their balance sheet. And of course, at the end, industry should be aware that the environmental protection agencies are there collecting data, and they're building the framework so they can have an efficient monitoring of the situation, not just to punish industry, but also like to predict the areas where are susceptible to forest fires, to flooding, so they can actually, or another important thing, especially here in Greece, is lack of water, the underground water, the depletion of the groundwater reservoirs. So in that way, we can actually have a nice collaboration, okay, between all parties in order to ensure a sustainable future for everybody. So thank you very much for your attention, and I guess everybody will be available for questions after the session.
Outh Radio, η φωνή της γνώσης.
What is love anyway? But a fire that burns too close. I gave my heart to the flame, and it turned me into smoke. You said forever, I heard goodbye. The echo still lingers. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. You're the love that kills. Your words cut like a knife, and the scars still sing your name. I thought love was my savior, but it played a crueler game. You said forever, I heard goodbye. Your shadow's a dagger. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. You're the love that
Another midnight, another drink. Silence wraps around me. Can't escape this noise inside. Need the world to stop. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Crowds keep pressing, always wanting more than I can give you. Lost myself in all that needs time to dig.
Most problematic. The others were okay, more or less. Okay, I have to make a presentation on behalf of Professor George Giannopoulos. my professor as well, an advisor for many years, since the early 90s that I concluded my studies in civil engineering in the Auth University. Professor Giannopoulos, unfortunately, was not able to join us today, but I will give the presentation on his behalf. My name is Apostolos Bizakis. I'm a transport engineer and managing director of company Tredit, one of the very few transport companies in Thessaloniki, and I would say very few even in Greece nowadays. Okay, what is the context of this presentation and this scientific research? Is to take a closer look to the innovation model in transport, beginning from the traditional, the so-called linear, sequential innovation model in which we have an idea that is generated from an R&D department. We have a conceptualize and check the feasibility of the idea, and then check also the technical capability and the development through a proof of concept process. We ramp up the whole idea and we starting thinking about strategies and demo projects in order to go to the first step, which is the economic exploitation and the IPR licensing in case we are able to do something that is innovative. Of course, as we can see in this linear chain, we have two valleys of death. One is the technical. At the beginning, we don't know exactly how far we can go with our solution. And of course, even if our solution is a good one, the valley of death for the economic, the financial part is also very important. So, this traditional linear model, according to Professor Giannopoulos and his colleagues, has been replaced in our years from the so-called innovation ecosystem model that allows more complex circular type of interactions. The model itself comes, from this cross-fertilization from other sciences, in our case, the biological ecosystems. There is a book here that you can see that has been published by Elsevier in 2019. So what is an innovation ecosystem? It is a large-scale network of relations and interactions among organizations that self-adjust to the environment, maintaining a dynamic, sustainable, and balanced web of innovation activities. This actually comes from these biological ecosystems. This is a similar approach to the biological science, to science of biology. So, two key reasons for using this model, the one being the fact that innovations increasingly developed within integrated and geographically defined systems rather than by individual innovators or single companies. The second one is that the innovation systems are not linear, but rather circular and multidimensional, displaying futures of complex adaptive systems. Now, in the circle in the middle, you have the basin of attraction. We'll talk about this later on. The basin of attraction with which various other parts of the ecosystem interact with the basin of attraction in various ways. We have the supply chain and the original equipment manufacturers, the OEM. We have financing business, we have venture capitalists, angels, crowdsourcing, banks. we have the structure of market and the consumers, the retail and wholesale buyers. We have also research providers, including, of course, universities and corporate research centers. And, of course, the HR part of the work, together with the artificial intelligence experts. We have external perturbations. We have external, like financial. We have also socioeconomic, social acceptance, and so forth. And we have a boundary conditions that all this system works within. So, what are the categories? What is the basin of attractors? It's a set of cooperating entities committed to initiating innovation, producing activities in a specific area, either geographic or scientific. And the basin of attractors, they act as attractors of more entities to enter the system. So again, of course, the basis of the basin of attractors is the so-called triple helix: industry and business, universities, and so the academia, and the governmental entities. Of course, 1 and 2, industry and universities, are the most important in order to have a basin of attractors that works according to this model. This is another representation. This is a time-space representation of the ecosystem. You can see the boundaries of the innovation ecosystems, and actually what happens is that we can see an equilibrium position, which is the blue ball in there, and there are various ways in which an innovative solution can go, an ecosystem can interact with the other, either in a linear way or in non-linear way, or with no conditions in a random way as well, with 3 different types. So, another 2 steps in our in the analysis that we have here for our presentation. The first one is to see the innovation environment in Greece in general, and as a second step to see the innovation environment in transport in more specific. So, first of all, in Greece, for several decades, the creation of innovation through the cooperation of entities was hampered by the vicious circle of political doctrines against the private sector involvement. Private sector was not very welcomed in this business, in innovation, and there was, of course, at the same time, lack of appropriate funding and lack of sufficient legislative and organizational environment. Cooperation between research bodies, mainly between universities and the industrial sector, was not encouraged at all, and even not wanted in some cases by the political schemes. The economic crisis, the 10-year economic crisis between 2010 and 2019, that definitely changed and turned the page for Greece in terms of innovation. Things changed, to the right way, to the right direction, for the first time, I would say, in many, many decades, following the paradigm of Western world, of course. And the creation of several national research centers in this area, outside the universities, not only universities, but individual national national-wide research centers, increasing the research involvement and focusing on innovation producing activities. Now, the current legislative and financial regime for innovation has gradually been introduced since 2020. First of all, private financing of research and innovation creation, which has increased notably. I would say that from 50 million euros in 2018 we have got as many as 732 million in 2025, with only in the last year, between 2024 and 2025, an increase of 35%, which means that it's something that is definitely dynamic, and it goes better and better through the years. Facilitation of the cooperation between the research producers and industrial and private sector entities. We have venture capital, we have corporate funding and crowdsourcing as tools to fund innovation and research results. Opening of the higher education in the universities, there was also an announcement for a new ministry of tertiary education. I don't know if this is, has already in place or not. There's a new AI strategy since 2025 announced by the government, and we have infrastructures like AI Factory, Pharos, and also the supercomputer of Daedalus, and also planned AI Factory in Western Macedonia, which is a region that is under decarbonization the last decade. New tax reduction rules for research and innovation. We have taxation rates, lower taxation rates for persons working in startups. We have angel investors that can get even as high as 50% reduction in their taxed income. We have scientists, researchers who relocate back in Greece and can get a reduction of 50% on their tax sheets for a period of 7 years. Also, we have the platform called Elevate Greece that already has formed and operates more than 500 startup companies. In the field of transport, going now to the field of transport, the picture, of course, is different. Transport research and innovation has not benefited sufficiently from the opening and increased funding for R&D in Greece, at least not to the degree that other sectors have achieved. The number of patents in Greece owned by Greek entities is still low. There are only 30 to 50 Greek patents per year in the field of transport in all major innovation promotion organizations, being, the organization of industrial. I don't remember and the European Patent Organization, of course, EPO, and the World Intellectual Property Organization, WIPO. In total, there are a total number of only 500 Greek patents through the years, which is a small number, obviously. Some key steps for the development of innovation in the transport sector. Greater cooperation of research producers within industry to form the triple helix cooperation mentioned earlier. Cooperation can be formed through specific agreements between the research centers and the industry or governmental entities with a specific subsector of transport. Agreements must specify, of course, rules and details of cooperation as well as financial commitments on both sides. Such agreements have been formed only between research entities and governmental entities. There is one example here between the Hellenic Institute of Transport and the region of Central Macedonia. Stronger move and support towards the creation of spin-offs should be part of the research production. So far, the most announced are those that are related to sustainable mobility and transport of the Center of Research and Technology, ELAS. Some known spin-offs and startups in the transport environment: Deep Traffic, Harbor Lab, FlexCar, and Vessel Front. I can talk just a bit about Deep Traffic, which I know better. It's about dynamic traffic management. They do a lot of work already in predictive transport modeling and work for the city of Thessaloniki intensively, giving already some traffic information to the users the bypass road for now, and even even for the city itself. Just a few figures from the funding perspective. We have the National Strategic Fund for the research and innovation. In 7 years, the estimates come to 150 to 200 million euros, so it's something like 21 to 29 per year. Horizon to 2020 for Cluster 5, or the climate, energy and mobility, between 95 and 300 million. The Recovery Fund, which is about to end by the end of August, and we have to take a closer look what will be next and in which manner. We have, of course, the national funding that goes to 15 to 30 million euros per year. For the private domain, we do not have exact figures. We just estimate that it should be something like 10 to 20% of the total public funding. Some conclusions. The ecosystems theory of innovation is a credible tool for understanding and promoting innovation. The environment for promoting innovation in Greece has changed in recent years and now is more favorable and supportive to innovation creation than in the past. For the transport sector, there is still a long way to go, as shown by the small number of patents, the small number of startups in the sector, and the low funding available. A most notable imbalance exists in the funding of research and innovation in the transport field, with more than 80% of the funding coming from the public sector, with approximately 90% of all that originating, 90% of the 80% originating from EU programs. So the national funding is actually low. Private sector financing in both research and innovation creation in the transport sector must be incentivized and in order to be increased. We have to establish long-term relations and cooperative arrangements between research teams and industrial companies. This is pretty much it. Just one last word, that sometimes in transport, which is it's a domain that is highly related to innovation. Sometimes we don't need AI to produce something that is spectacular. I have to admit that one of the most important inventions in transport is the box, as we say, which is the container. The container box, only produced for the first time in 1950, less than 80 years ago, not only changed, it's just a box, you know, stacking boxes one after another, it's something pretty much obvious. I mean, but someone decided that it has to be standardized, it has to be stacked in a right way, and it has to be interoperable to all transport means. And just like this, they changed not only the transport industry, the transport modes, the freight transport around the world, but also changed the global economy. Because if it wasn't for the box, many things that we can see now with, you know, with all the production lines in China and, you know, all these movements of the ships, and it could be something impossible to execute. Thank you very much. The very few of you that were here. Thank you very much.
Outh Radio, η φωνή της γνώσης.
What is love anyway? But a fire that burns too close. I gave my heart to the flame, and it turned me into smoke. You said forever, I heard goodbye. The echo still lingers. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. Your words cut like a knife, and the scars still sing your name. I thought love was my savior, but it played a crueler game. You said forever, I heard goodbye. Your shadow's a dagger. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. You're the love that
Another midnight, another drink. Silence wraps around me. Can't escape this noise inside. Need the world to stop. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Crowds keep pressing, always wanting more than I can give you. Lost myself in all their needs. Time to disappear. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Don't come looking, don't come calling. I'll be where the silence falls, where loneliness feels like home, and I can finally be. Let me breathe empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Just me and quiet.
Αριστοτέλειο Πανεπιστήμιο. Youth Radio. Συντονιστείτε.
Sous le ciel d'un été passé, tes mots dansaient comme la rosée. Les jours s'effacent, mais je me souviens des marguerites dans nos mains. Tu disais, tu as eu laissé l'amour. Un par un, on comptait les jours. Même si le vent t'a pris loin, les fleurs parlent encore de demain. Je sème des marguerites dans le vent, espérant que tu les senses. Dans chaque pétale, ton nom résonne comme un secret que l'âme fredonne. Tu vis encore dans mes saisons d'or. Les chants ne mentent jamais vraiment, ils gardent les rêves tendrement. Même seul je parle à la nuit, ton écho me répond tout bas sans bruit. Et quand le monde semble trop froid, je cherche encore ton pas. Sous la lune ou dans le matin, tes fleurs me montrent le chemin. Je sème des marguerites dans le vent, espérant que tu les sens. Dans chaque pétale, ton nom résonne comme un secret que l'homme redonne. Tu vis encore dans mes saisons d'or. Un jour peut-être au bord de l'été, je te verrai parmi les plaies, et nos marguerites chanteront ce que nos cœurs n'ont jamais dit, mais savent au fond.
Γνώση, τέχνη, ζωή. Outh Radio. Για όλη την κοινωνία.
Αριστοτέλειο Πανεπιστήμιο. Youth Radio. Συντονιστείτε.
Beneath the surface where I stay, watching the ship sail through my bay, my voice carries across the deep. He'll never know the love I keep in my crystal palace down below. I paint his face and waters flow. Every morning when sun breaks through, I rise up hoping he sees me too. The distance grows with every tide. Two different worlds forced to divide. My heart beats faster when he's near. But will these feelings disappear? Can you hear my voice through the waves? Can you feel my heart as it breaks? Can you hear my voice through the waves? Or am I singing all in vain? From coral beds I watch him stand, his footprints marking distant sand. If only I could walk that shore instead of swimming evermore. The price of change weighs on my mind. Leave everything I know behind. My tale, my voice, my ocean song, just to feel where I belong.
Listen close as I break it down, the truth that keeps me wearing this crown of seashells in my flowing hair, while love floats like smoke in the air. They say that magic comes with cost. Transform my tale, but voice gets lost. No more singing, no more sound, just silence as I touch the ground. Is it worth it? That's the question. Trading music for connection. Every step will feel like knives, but I'll be where my heart resides. Some say I'm foolish, say I'm blind, but they don't see what's in my mind. The way he moves, the way he smiles, I cross 1,000 ocean miles.
I used to wake up with your name in my head. Now silence screams where your laughter once lived. These walls remember the things we both said, but memories fade and I've got none to give. Tried to hold on, but your shadow slipped. Now I'm chasing echoes and tightened lips. Now there's nothing in the air I breathe, nothing in the nights I see. No spark, no light, no gravity since you walked away from me. It's all gone, it's all still, like time forgot how to feel. You were my everything, nothing. I stare at the sky, but the stars don't shine. The songs we love just don't rhyme. I smile, but it's not really mine. Just painted truth with a fragile line. You were the fire, I was the flame. And now there's just smoke when I say your name. Now there's nothing in the air I breathe, nothing in the nights I see. No spark, no light, no gravity since you walked away from me. It's all gone, it's all still, like time forgot how to feel. You were my everything. Now I've got nothing. I reach for dreams, but they fall apart like glass on stone, like a worn-out heart. If love was real, then why'd it end? If I meant something, was it all pretend? Now there's nothing in the air I breathe, nothing left inside of me. No tears, no fight, no melody, just your ghost and memories. I'm hollow, I'm cold, a story never told. You were my everything. Now I've got nothing, nothing, just nothing.
Καλώς ήρθατε στο Outh Radio, το web radio του Αριστοτελείου Πανεπιστημίου, εκεί όπου η γνώση συναντά την ψυχαγωγία.
Shadows lengthen over the weary city. Invisible chains on every scarred heart. But the wind whispers what fear kept silent, that the seed of justice still beats beneath the suffering. Awaken, brother, awaken, sister, from your slumber. With burning fire, but
So, I welcome you to our panel discussion, Longevity by Design, the Science Behind Healthy Aging. And it's a real pleasure to welcome in this panel some outstanding scientists and experts of our country whose work is shaping the future of medicine, health policy, genetics, and this new and emerging scientific and social field now termed ethical and social dilemmas that inevitably accompany these developments. And at the same time, the longevity economy is expected to become one of the world's largest and fastest growing markets. This panel will also focus on the business and innovation opportunities emerging around healthy longevity, such as digital health, wearable technologies, AI-driven health prediction, smart nutrition, biohacking products, and entirely new models of healthcare and wellness. The longevity revolution, driven by scientific progress and changing lifestyles, is undoubtedly one of humanity's greatest achievements. Whether it ultimately becomes a burden or a major advantage for societies, however, will depend not only on biology, but also on political choices investment strategies and social frameworks we create in the years ahead. In any case, population aging is already becoming and will increasingly become one of the defining challenges for modern economies, with major implications for economic growth, labor markets, and of course the long-term sustainability of the welfare state as it was shaped in the post-era period. These important issues will be explored by Professor George Chrousos, Professor George Gorgoulis, Dimitrios Vasilios Gorgoulis, Dimitrios Vlakakis, and Mrs. Evi Katsiandreou. My name is Polydekis Papadopoulos and I'm a journalist. And before we begin, I would kindly ask each of our four speakers to keep their opening remarks to a maximum of 20 minutes the most, so that we can have a second round of discussion among panelists and, of course, to receive questions and short interventions from the audience that we have. Now, it's a great pleasure to give first the floor to Professor George Chrousos. We are truly honored to have him with us on this panel. Professor Chrousos is one of the world's most influential physician scientists, internationally known for pioneering research on how stress affects the human body and mind, from hormones to brain function, to immunity and overall health. His groundbreaking work has transformed our understanding of stress, adolescence, and human development. He serves as Professor Emeritus at the National and Kapodistrian University of Athens, leads the University Research Institute on Maternal and Child Health and Precision Medicine, and is president also of the Hellenic Pasteur Institute. He's a member of the Academy of Athens, but as a member of the US National Academy of Medicine and Academia Europaea, he's among the most highly cited medical scientists in the world, with more than 218,000, I think, Professor, citations and a truly global impact on modern medicine. His specific topic has the title Healthy Longevity, a Holistic Approach. So,
thank you very much. I'd like to show you a few slides as an introduction. I can go to the podium, yes. Here I'm showing you the life expectancy of several countries. Number one, Japan, 85 years. Switzerland, 84 years. Number three, Greece, 81, and later 82. So we're not doing bad in this country, despite the difficulties. Obviously, we have good DNA, good genes. However, from this life expectancy, which is called lifespan, we have the so-called healthy lifespan. You have to subtract 10 years. So in Japan, if you subtract 10 years out of 85, that's 75. From 75 to 85, people have a lot of problems with health, limitations in walking, in going upstairs. Life is not as pleasant as it should be. So ideally, we want to have health span. In other words, for as long as we live, we want to have good quality. Now, if I put down the Gaussian curve of Japan, that's the blue line. The mean is at 85 years, and they can go up to 120 years. However, many anthropologists, after a lot of calculations, have found that this should be 30 years later. In other words, the ideal curve is the red curve, mean life about 105, 110 years, and all the way to 132 years. So something's happening and takes out years of life. Now, what's happened in the world in the last 70 years? First, life expectancy has increased. However, this has happened in spite of the fact that there is psycho-socio-economic, ecologic, and environmental stress everywhere, which starts early in life. Second, overweight and obesity is ubiquitous and starts early in life. Comorbidities of obesity follow and also start late in life. We see now children 13 and 14 years old with diabetes mellitus type 2, the so-called diabetes of the mature, of the old. Also, we see comorbidities of obesity in lean adult subjects. Very common. This is called paradoxical obesity. The aging markers appear early in life, so we have acceleration of senescence. And to give you a number, a 50-year-old now, the average 50-year-old, has a biological age of 60 years old. And of course that means that cancers that depend on age come 10 years earlier. Everything comes 10 years earlier. However, despite this, we live longer. This is one of the main reasons we live less than we should. That's nutrition. And that's another reason that people don't think about. That's the environment, pollution. There are a lot of chemicals around. Very, very important. They affect us since we are embryos, fetuses. So Western lifestyle is associated with dominance of ultra-processed foods, high in sugar, salt, and saturated fats. We have sedentary lifestyle. We have high pace, work pressure, and insecurity. We have advanced technology. However, despite that, we have isolation, real-life isolation. Unfortunately, you cannot make friends through screens. You need to be next to each other, face to face. We also have sleep disruption. We sleep shorter by about 2 hours average than our previous generation. And our sleep is not good. The quality is not good. And finally, as I mentioned before, we have environmental pollution, which is chemical and digital. We don't think about 5G, but it does affect fetuses and babies, young children. And of course, the climate change is important. Every time we have a heat wave, there is stress in the environment, tremendous stress. So, Western lifestyle has led to a surge in non-communicable diseases, a mental health crisis, and a weakening of social bonds. All of this is bad. But we have very good medicines that allow us to live longer. Not a great quality of life, but they have extended our lives. And let me tell you, all of these drugs that have shown to extend life are either anti-stress or anti-inflammation. Because stress and inflammation are the qualities that make us age faster. Now, let me say a few words about the importance of homeostasis, of balance in our life. The first person to talk about complex systems was Pythagoras. He said that the world, which he called cosmos, is in balance. He called it harmony, harmonious balance. And on one side there are disturbing forces, but on the other side there are forces that re-establish homeostasis. His student Alcmaeon said human beings are also complex systems, and they are in a certain balance which he called isonomia. On one side you have stressors, physical or emotional. On the other side you have the adaptive response. Hippocrates called this balance eucrasia, good mixing of the humors. Epicurus called it eustathia, and he gave the best definition because he had eustathia is the balance, the harmonious balance of the flesh and the soul. He included holistically the whole human. And then it took 2,300 years for Walter Cannon to bring back the concept of balance and call it homeostasis, also a Greek word. So stress is a state of threatened or by us that have self-awareness perceived as threatened homeostasis. Now, the second major philosopher that worked in this area was Aristotle. Aristotle said that the good is between two evils, too much or too little. And here is the famous Aristotle curve. Stress follows this curve. In other words, we need stress, which is good in the middle, when you are in good balance. It's okay to have stress within that range. If it's too much, we have a problem. If we don't have stress, again we have a problem. That's why the quarantine, prison, going to prisons, it's extremely stressful. When I isolate somebody, you stress them a lot. So there is eustress, good stress, and bad stress. And as I said, eustress is in the middle. And there is a very important property described by an American psychologist about 50 years ago with a new word called effectance. Not effectiveness. Effectance means the internal tension of human beings to do things to control their environment. And once they control their environment well, they feel well. Pleasure. Even if you make a coffee, you feel pleasure. Okay? Anything you do during the day, you get pleasure out of it. If you learn something new, you get pleasure. So that's eustress, and it's important to live well every day. Carpe diem. It goes here. Learning belongs here. Now, the philosopher Spinoza had called conatus the constant tension of human beings to want to live. Okay? Once you lose that, you commit suicide. You don't live anymore. So there is something that keeps us alive. That's conatus. And in my opinion, we have the conatus that keeps us alive, and then we have the effectance that gives us pleasure. And it's the same system, it's the reward system. We have a constant dopamine activity, and then we have pulses of dopamine that gives us the pleasure. These are all the human stressors. I won't go over it. Anything that stresses you is a stressor. And that's a very important slide, and I stop here. This is, on the left, a physiologic response. All of us, whenever we're stressed, we have a program in our brain, which program will do one of three things. And we humans and some other superior animals have added a fourth thing. The three things are fight, flight, and freezing. In other words, you either fight, or you go away, or you pretend to be dead. But using our cortex in our brain, when we see an enemy, we can smile to them. That's called phoning, kalopiasma in Greek. Okay? So there is a fourth F. Generally, this kind of a response does not harm us. The only situation where you can be harmed by acute stress is when the stress is major, like the big accident we had at Tempe, right, or a war, where about 20% of people have a certain sensitivity. They develop the so-called post-traumatic stress disorder, PTSD. That's the only situations where acute stress can really cause chronic disease, because PTSD is a chronic disease. Nowadays, actually, we don't have a lot of stress. We have mild stress or moderate stress. The only problem is that it's constant. It's day and night, weekdays, weekends. It's there all the time. And that's the so-called chronic psychosocioeconomic stress and everything else I said. What does it mean? Chronically, we activate fight, which means anger and aggressiveness. Flight, which means fear, phobias, and anxiety. Freezing, which means despair. There's nothing I can do, right? Paralysis. And phoning, which means being subservient. Think of the state where somebody is abusing a woman, right? That woman sometimes behaves well, smiles, so that she won't get more abused. That's a terrible chronic stress for a person. Women, men also, children, okay? So these are all important stressors. So we think that we are in a good, healthy baseline homeostasis. Something happens, we're stressed, but usually we come back to where we were before, and nothing else happens to us. However, there are two other situations. We may go into chronic stress situation. In other words, we're not in a good homeostasis. That's dyshomeostasis or allostasis or kakostasis, which means that our balance allows us to survive, but we're not happy, and our body is getting gradually destroyed. And there is another situation where we live well, we know how to deal with stress, and in that case, we are in a superior state, hyperstasis. And here I'm going to show you this, and I'll stop. If we end up being in hyperstasis, we are very good, we're resilient to stressors. Okay, so that state is called psychosomatic resilience, which means every time we're stressed, we have a small disturbance and a quick recovery. And that's what we want. And psychology, the so-called positive psychology, a little bit, something happens and they die. A little bit, something happens and they die. They have a flu and they die during the flu. Okay? So ideally, we want to be up there. Live well, etc., etc. We will discuss that later. So resilience is the ability of any organism to resist to stressors and return rapidly to homeostasis. Now, my colleagues will discuss further. The two molecular biologists there will give you mechanisms and so forth. Let me just say one word. Chronic stress affects all the aging mechanisms, all the molecular aging mechanisms, one by one. Okay? That's why it's so important to be resilient. Thank you very much.
Now, joining now our discussion is Professor Vasilis Gourgoulis, a leading expert in cancer biology and molecular pathology. Professor Gourgoulis directs the Department of Histology and Embryology at the Medical School of the National and Kapodistrian University of Athens, and also holds senior academic positions in the United Kingdom, including the University of Dundee and the University of Manchester. His research has helped explain how cells respond to damage that can lead to cancer, opening new paths for diagnosis and treatment. His scientific work has received more than 51,000 citations worldwide, and he is internationally recognized for major discoveries related to aging cells, genomic instability, and cancer development. The title of his presentation will be Molecular Mechanisms of Aging, Senolytics. Please, Professor, explain us senolytics for us who are not specialists, in simpler words, yes.
First of all, I would like to thank the Aristotle Innovation Forum for the invitation. It's a great pleasure to be here with you, with such distinguished colleagues, especially Professor Chrousos, who also was my teacher. So to achieve longevity, we need to understand aging. And what is aging? According to WHO, to the World Health Organization, aging is a biological process of a... Oh, sorry. No. Yeah, yes. So aging is a biological process of accumulating molecular and cellular damage over time leading to gradual decrease of physical and mental capacity, and this condition leads to increased risk of disease. Aging is not a linear process, but it's actually a process that comes in clustered bursts. It has two peaks, around 40 years of age and 60 years of age. And each of these peaks is characterized by distinct molecular features. The key biochemical features that characterize the 40 years peak is mainly lipid metabolism deregulation, cardiovascular deregulation, and also the myoskeleton system starts to be weakened. The second peak, which is 60-year-olds, we have the regulation of carbohydrate metabolism, immune deregulation, and the basis, the molecular and cellular basis of this process is a phenomenon called senescence. And it's the pillar of aging, and it's involved in all age-related disorders. What is senescence? Senescence originates from the Latin word senex, which means old. And senescence is a stress response. And the senescent cell is characterized by all the features that embodies aging. The senescent cell is arrested, does not proliferate, it has a deregulated metabolism, it's characterized by macromolecular damage, aggregates, and also it's characterized by a secretory phenotype termed senescence-associated secretory phenotype. The senescent cell, commonly known as a zombie cell, secretes factor in its environment, shaping the surrounding microenvironment, and this triggers a paracrine phenomenon called paracrine senescence, and this is the basis of age-related disorders. These cells, these zombie cells, are resistant to apoptosis. Apoptosis is from the Greek word apoptosis. It's programmed cell death. They are resistant to cell death. This is why they're called zombie cells. And this question mark refers to evidence, including data from our lab, that under certain circumstances, these cells can re-enter the cell cycle, and this, particularly in cancer, has important repercussions because it can lead to relapse in cancer. So in brief, because a video will follow, which summarizes all these findings, in brief, senescence has a bright and a dark side. On a short-term basis, since it's a stress response, it has a beneficial effect for the organism. However, on a long-term basis, if not removed timely by the immune system, it has detrimental effects. Now, a video will follow which summarizes the features of senescence, but also a recent discovery of our lab, the first in-class specific senolytic that we developed, which is now in clinical trials. And I hope this brief presentation will form the basis for our discussion that follows. So the video, 4 minutes.
From the day we are born, we humans fear aging and eventually death. The most common human diseases, such as cancer, cardiovascular, neurodegenerative, and rheumatic disorders, appear later in time. This is the reason why we name them age-related diseases. However, the cellular and molecular basis of their development takes place much earlier in life. An important role in this process is driven by a phenomenon termed cellular senescence. Almost all stressogenic stimuli, such as environmental cues, bad habits, smoking, excess alcohol and calorie consumption, as well as therapeutic agents, drugs, lead to the occurrence of senescent cells. Senescent cells are dysfunctional and damaged cells that manage, though, to survive, and are therefore characterized as zombie cells. On a transient basis, these cells reflect a beneficial response against stress. However, over time, they accumulate in the body, toxifying and eventually generating a pathological microenvironment. Interestingly, in cancer, characterized by an abnormal, under stress, accelerated proliferation of cells, senescent cells can occur primarily within the tumor mass and in the adjacent tissue, or secondly, as an outcome of anti-cancer treatments that target proliferative cancer cells. The most profound and stable feature of senescent cells is the accumulation of lipofuscin, also called dark matter, within them. For many years, senescence detection in clinical material was a very challenging task. Now, with the development of pioneering senescence-detecting compounds, Centrigor GLF16, by the Gorgulis Lab from the University of Athens and the University of Dundee in collaboration with QR Labs and Thorax Institute that specifically bind to the dark matter, the presence of senescent cells can be verified even in live organisms. Therefore, exploiting the selectivity and specificity of these tools, they pave the way for targeted elimination of senescent cells. Most drugs that kill senescent cells, termed senolytics, are derived from a drug repurposing procedure. Thus, they harbor non-senescence-related actions and side effects. In order to overcome these obstacles, the Gorgulis Lab designed an innovative platform for selective and precise senolysis, termed GL392. This platform consists of three main parts: a lipofuscin binding domain, LBD, a linker, and a senolytic moiety. The first part, LBD, is vital for the selective binding of the compound inside senescent cells by anchoring to lipofuscin. The linker is the second component and has a dual role. It not only connects through a bond the active drug to the LBD, but it also allows its desirable intracellular cleavage by endogenous enzymes that are expressed in abundance, molecular scissors. The third region consists of the repurposed senolytic drug dasatinib. Subsequently, they encapsulated GL392 in a micelle nanocarrier, generating MGL392 that allows cellular internalization and selective release of GL392 within senescent cells, as it preferably disintegrates upon exposure to the low cytosolic pH, a feature exclusively characterizing senescent cells. The released GL392 accumulates inside senescent cells owing to its high affinity for lipofuscin, while its linker is subsequently cleaved by intracellular enzymes termed esterases, effectively releasing the senolytic drug and promoting senolysis. MGL392 is a first-in-class selective senolytic reagent that reinforces impressively our arsenal against age-related disorders and opens a new horizon for human rejuvenation.
So we are very happy that recently it was approved to enter clinical trials. It is widely recognized in the scientific community. These are some of the recognitions that we received. And closing my brief presentation, I would like to thank all members of my team for their hard work and commitment, and also all my collaborators, including Professor Chrousos and Dimitris Vlachakis, which are here, and Evi Hadjiandreou. I would like to thank you for your attention. I'm open for questions later. Thank you.
I'm now pleased to introduce also Mr. Dimitrios Vlachakis, Professor of Genetics at the Agricultural University of Athens and Honorary Professor at King's College London. Professor Vlachakis specializes in genetics, artificial intelligence in medicine, precision medicine, and drug design. He also serves as Research Director at the Medical School of Athens and Vice President at the National Health Technology Assessment Committee at the Greek Ministry of Health, with more than 200 scientific publications and extensive international research activity. He is helping bridge cutting-edge biomedical science and real-world healthcare innovation and next-generation therapies. The title of his presentation is How Old Are We Biologically? Decoding the Hidden Clock of Aging. Mr. Vlachakis.
Thank you very much. Super nice to be here. It's always a pleasure to communicate what we have been doing in the lab for the last few years, and always happy to co-present with Professor Chroustos and Professor Gorgoulis all the hard work that we do in the lab. This is the case. The case is that if you see every year the lifespan goes up, and it's expected that soon we will reach 100 years old for sure. It is not a problem, it's a blessing. We are very happy that it's happening. So we shouldn't be worried about it. We should be very happy and very thankful to science that has managed to help us achieve this. But now we need to be prepared on what the new requirements and what the new demands from society will be to the medical sciences. We are very much involved in using big data and genetic and medical information, but also epigenetic, environmental information, societal information, all the information that we can get, we can get our hands on, and see how that can be used in order to understand the biological mechanisms and understand how aging works. So, as you can see, the data growth is exponential, but the important thing is that regardless of its rate, that, as I said, it's accumulating really, really fast. The important thing here is that a lot of this information is unstructured. It doesn't, it's not coherent, it's not standardized, and it's not harmonized. So it means that sometimes we talk about comparing genomic profile or the medical profile or magnetic resonance images together, but we are actually comparing apples to oranges because the information has not been harmonized in such a way that can be analyzed and exploited for the project that we want to take on. So this is a new approach about the multiomics and how we use genomics, transcriptomics, metabolomics, proteomics, the analysis of human molecules in order to understand the phenotype of, if I can get the pointer to work. No. Anyway, so what we see here is that it's quite a complex scenery, and nowadays artificial intelligence can help us analyze and find some routes, some pathways to understand the biological mechanism behind aging. So AI brings together the biological networks that drive, can help us understand the biological networks that drive healthy aging. And we know that we now move from risk genes to risk architectures. In the older days, we were hunting genes. We were looking for things in our DNA. We were looking for some special genes that the people who live longer have compared to those who don't. But now we understand that it's a complex architecture that we need to understand. It's not just a gene. It's not just a molecule. And this is why we use this multimodal integration. We actually we used advanced mathematics in order to analyze the data that we have and get a biological explanation. We started a few decades ago to look at genome-wide association studies. So instead of taking just a few genes, take the whole genome of somebody, compare them to the rest of the people in this trial, and try to find some associations within the whole genome. But now we understand that we need to go to actionable targets. We need to find what is not something specific that is hidden in the genome of the healthy person, but something that has some signature of aging. And this is the hallmarks of aging. So we know, and my colleagues already explained, that it's not just the genetic profiling of an individual, it's the diet, the stressors, as Professor Chrousos and Professor Gorgoulis already mentioned. And this is where we come, and I'm going to talk about, I'm going to take you through two stories. One that has been developed in our lab for the last maybe 10 years, where we started to look for molecules that play with inflammation. How inflammation can be maintained, can be controlled, and if not, if inflammation goes crazy, it's not controlled by our immune system, a lot of bad things will happen. And we discovered a very specific molecule, which is called STING, a protein. STING stands for stimulator of interferon response. And those molecules play a pivotal role in kickstarting inflammation and controlling inflammation. So we were real quick to understand that those are very, very old genes, very, very old enzymes, and it goes like this. Our race, Homo sapiens, has been walking on the surface of the planet for about 300,000 years. And life, we believe, it's 4 billion years. It started about 4 billion years ago. And those genes were of the first genes, the first proteins that appeared 4 billion years ago, because bacteria used those proteins to defend against viruses. And nowadays, of course, we have evolved more complex organisms, and now those proteins have been the core, and actually they are the core of our immune system. And I must say here something that is very, very important, that because now we age and we are getting older and older, and the society is getting older and older, and as I said, this is a blessing, it's not a problem. We want to live longer. Of course, we want to live healthier, but it's important that you are alive, and then we take care of your health. And but about when our race started to appear about 300,000 years ago, it was not. It was very rare that you reach the adult age because of infant and child mortality. A lot of children never made it to adulthood. And we know that back then that easily 70 or 75 years old were manageable if you made it through all the hardship of surviving in nature. But now the societies are more protected, and now we can live longer, and now we need geriatrics. Back then, it was those who were taking care of their children that were actually helping people to live longer. It's expected that the average life, it's estimated that the average life expectancy of the early Homo sapiens was 20 to 25 years old, on average. And now we reach 100. So what we did in the lab is that we tried to look deeply into the function of those enzymes and see how these enzymes use the substrates, little molecules that control inflammation. We went to the lab, we investigated all the different interactions and the profiling between those molecules, and now we got a paper published in Science Advances where we understood that there are some specific triggers that will start inflammation in our cells, and those triggers have been around for many, many years before Homo sapiens, before humans appeared in evolution. And then the lipid metabolism. As Professor Gorgoulis said, mentioned in his presentation, the polyunsaturated fatty acids and what is their role in kickstarting in maintaining controlled levels of inflammation. And recently, we understood that provided that we know which are the modulators, which are the triggers of those enzymes, if we go back and do the reverse engineering thing, like which means if we go back and see those molecules that we identified, can they interact with different set of proteins? We realized that there are other proteins that could play the role of inflammatory triggers and switches, and one of those proteins is a DNA protein kinase that we recently managed to get published in a very important journal in the field. So we used AI, we used observation, of course, because the reason, the path that led us here has to do, of course, with analyzing big data, but also has to do with knowing our staff, being good at what we do. And I'm going to take you back a few years, and this is a paper that we published in 2009, long before I met Professor Chrousos and Professor Gorgoulis, and long before I even thought of doing something with aging and senescence. I was interested in RNA trimming and how RNA gets involved in cell signaling and epigenetics. So what we did is we analyzed a protein which is called PARN, polyadenylated ribonuclease, and that protein, back then, about 15 years ago, we knew that there is a set of amino acids, the monomers of a protein, the molecules that build up the protein. So there was a histidine, an aspartic acid, and an arginine that catalyze the backbone of the RNA. And we knew that back then. And when we went back and looked at the proteins that we now think are switches of aging, we realized that they have the exact same architecture in their catalytic sites. So those proteins, they also share that catalytic triad that the ribonuclease shares, and that gave birth to the main part of the discovery that we had managed to do in the lab, where we understood that the protein that we thought was phosphorylating stuff, was a epigenetic modulator, now is doing the hydrolysis of nucleotides and is actually controlling how much of the substrate is out there for the inflammatory proteins to detect, and in an indirect way controlling inflammation. So now we know exactly how that mechanism works, and we know that for sure that it's not just specific proteins, but it's an architecture of proteins collaborating, working together. And sometimes we, in biology or in medicine, we like to give names to things to help us understand what we do out there. But sometimes that creates noise it's making a blurry image of what is actually happening out there. There is a lot of synergy between those proteins, and sometimes those proteins work together, or one of the proteins, if for whatever reason stops its normal function, the other one will come and counteract and compensate the loss. So we know the mechanism, we went back to the lab, and we understood that those cyclic dinucleotides, now they are not specific substrates to the inflammation proteins, but protein kinases, DNA handling proteins, also hydrolyze the substrates and also indirectly control inflammation. So we got this paper now submitted, and we're expecting for the results to come out. We hope it goes well. In the meantime, so this is one of the main projects that I have been working with Professor Chrousos, and in the meantime, thankfully, it was one of the best things that happened in my academic life in Greece. I met Professor Gorgoulis recently, and we started working on another project which has to do with senescence. And I'm very happy that our paths crossed, because a lot of the things that we have been doing on inflammation, it's a perfect fit for senescence. And what we did is we developed a 100 gene signature. We called it Senevic, Vicky. And it's a breakthrough, because we are talking about 100 genes that have been involved in cell cycle, damage regulation, chromatin instability, inflammation, and metabolic genes. And we know that this signature outperforms all the other senescence signatures out there, and outperforms, it actually means that if you take that as a metric, if you quantify, if you do an analysis in the lab of those 100 genes, you can have a very, very good image, the best image right now that science can produce of how senescent your cells may be. And we know that the immune cell senescence right now is a discriminator between responders and non-responders in immunotherapy. And we have a lot of things going on and clinical implications. And as Professor Gorgoulis mentioned a few minutes ago, his team is now moving into clinical trials, which is a fantastic breakthrough for our country, for sure. We're super proud that his lab is moving so fast, and but also for the whole world, because this everybody will benefit from that. The important thing that we discovered when we were looking at the 100 gene signature is that we have 23 chromosomes in our cells, and that signature picked up collected genes from all chromosomes but 3. We didn't find genes in that signature from chromosome 13, chromosome 18, and chromosome 21. And when we realized that, we were curious to find an explanation. And of course, the explanation is that those are the 3 chromosomes that can do trisomies in, as a pathological genetic syndrome. And we know that in trisomies, the aging process runs fast. So those chromosomes, we believe, are already senescent, and that is why they don't produce genes that can be used as biomarkers, as thermometers of senescence. So this project is still ongoing, and we soon hope to come back with more exciting information. Thank you very much for your attention.
Thank you, Professor Vlachakis. And now I'm happy to introduce to our panel Mrs. Evi Handjiandreou, an internationally experienced expert in public health, healthcare system, and healthy longevity. Dr. Handjiandreou is a graduate of Harvard University, where she completed advanced studies in public health and health policy. Her career spans leadership roles in Greece, the United Kingdom, and the United States, including positions at RAND Europe, the Greek Ministry of Health, and the US Congress. Her work focuses on prevention, healthcare innovation, and strategies that can improve both quality of life and healthy aging in modern societies. She is also scientific director at Now Longevity Hub and Blue Hotels and Resorts. Her presentation has a challenging question: is there a longevity dividend? Mrs. Handjiandreou, I assume that behind this question lie many critical economic and social issues, huh?
Indeed,
Probably.
indeed. Thank you so much, and it's really a great pleasure to be here and be with my very esteemed colleagues and friends. Now, trying to wrap up and make the connection with what we've heard so much until now. We've heard from scientists who are really trying to decode the aging process. All of this information comes to become knowledge. This knowledge tries to become practice. So what I will show you first, I will show you with my last slide, and then I'll go at the beginning, talking about the dividend of healthy longevity, because all of that we heard translates mainly to practices, and lo and behold, to good behaviors, lifestyle behaviors that we have in our hands. There are 5 pillars that really address all the hallmarks of aging and attenuate them, and these are sleep, movement, nutrition, stress, which is really the underlying factor of everything, and the 5th one is actually, it's the 14th pillar, was added last year. It's social connections and purpose in life. For something to become a pillar in healthy longevity, it needs to pass certain criteria. That means to show that increases the biomarkers of inflammation and longevity. And then if we do an intervention, that we can reverse it or bring it back or slow it down. So that was the 14th pillar. I will show you first the very optimistic approach, which we all share. This study came out at Lancet just two months ago. And I love it because it's very practical. It really shows, as I said, I was going to end my talk with this, but I will start because I want you to show that everything we do has an impact in the healthy life years that we're adding to our life. And that is based, it's in Greek, but of course we can understand, is based on sleep, on movement, and in appropriate nutrition and diet. What's fascinating they did was that they tried to do the statistical analysis to find out what can we do to minimum to add a life year. And that is 5 more minutes of sleep a day, 2 more minutes of movement, and half a portion of veggies a day. See, this is for 1 year, but there is a dose response. So you see in the graph that the more we add on these really foundational lifestyle behaviors, we add healthy life years. This is what we now know, but more is coming, and the more has to do with the tremendous work that we heard before that will translate even now to medications and moving beyond lifestyle measures. So once we're able now to combine lifestyle and all the new knowledge and medications and interventions they come, then we are talking about, trying now to start it, then we're talking about realizing adding healthy life years. We already know that if we adapt these behaviors that I've showed you earlier, we add a multitude of studies, US, Europe, Asia, we can add up at least 14 years of healthy life years to our life expectancy, even more. So, no, that's not the first one, guys. Let's see. Στο πρώτο πάμε. Ωραία. Great. Και από εδώ. So, I'm using a word that is mostly connected to economics, but it's a very powerful word and a real word. What happens if indeed we live more years? We live either in healthy years, or as Professor Crusoe showed us, we have this gap of, on the average, 11 years between being healthy, getting sick, and the end of life. All I'm arguing is that we need to change perspective, the view that we see things, because we hear that, yeah, it's not good to live longer, you know, the systems will not be able to tolerate it. Well, tough luck. It's great to live longer and be healthy. And there are added benefits to this. I will again start from the end, and the situation in our country is not so great. If things continue as is, by 2050, our GDP will be reduced, to 2,100, will be reduced by 1/3. 1/3, we lost about close to 20% during the crisis. So more than that, just because of aging and also reduced population. We spend approximately 18 billion on health, and there is a multitude of studies from all IMF, World Bank, think tanks, government organizations, academics, that they all show the same thing, that if we do things right and we have policies promoting healthy longevity, then actually there will be a gain rather than a deficit in the country's GDP. So it is absolutely crucial to improve things, because if things continue as is, the systems indeed will not be sustainable. It's so simple. So let me start. This is just a graph to show you the change in population in Europe between now and 2050. Different colors represent different age groups. So you see that the more persistent one and higher up is those over 65 years. Aging of the European population is inevitable, and we need to find ways to improve how we live in these later years. Why? These are the publications that have to do with longevity. It's amazing how much knowledge we get every year. And you could see that there were 3 Nobels the last 12 years that were devoted to researchers who investigated aging processes. A lot of new knowledge. And the question is, it's not whether we can afford healthy longevity. The alternative is worse. What happens if we don't consider it and if we ignore it? This I'd like to show you. I mean, there are a lot of other animals that live beyond 100 years, and I recently learned that there is a jellyfish that rejuvenates itself. It gets older and then gets back and rejuvenates. So great. We're trying to learn a lot from sharks and tortoise, but we are living beings, we're living in societies, we're living in countries. What is going to happen? We have some real challenges. And again, you see how after the age of 50, all of the chronic diseases start getting increased. However, the damage does build earlier. And this is a message for the younger ones, because the earlier you start doing the right things, the more you will delay or even prevent totally the diseases. Some graphs just to show you it's a universal problem. Always those age 65 or 85 are the fastest growing component in many societies. The gap between life expectancy and healthy life expectancy is increasing because, yes, we have great medications, but they extend our life, but not always our healthy life. And a great issue for societies, and in Greece in particular, is long-term care. It's increasing in many countries as we speak, and Greece is the second to last because we don't measure it. And we know we have families and black workers that take care of our elders, but long-term care is one of the ticking bone in the Greek healthcare system. And actually, it is the fastest growing cost within healthcare in every country. So, there are challenges because of the aging, shrinking workforce, rising care demand, lower public revenues, and of course, personal and family burden. And a lot could be addressed by doing the right things. Just see the population of Greece by 250, it's going to be less than 9 million. So you can imagine, and of course the proportion of those 65 plus increases. So how are we going to make it also with 30% less GDP? All of the big and organizations have made studies. Just to show you, OECD works a lot with the issue. And one issue, important social issue, is yes, if we know how to do to increase our healthy life years, but prevention seems to be, since it's a human right, so it seems to be spread equally rather than unequally. And indeed, there are benefits in promoting prevention and healthy aging, in reducing and attenuating the cost. Now, this, for me, is the most worried slide for the Greeks. Make a note of it. It's a study by Ove, which is absolutely important for our policy making. So, reducing AEP by 31%, the GDP, employment by almost 50%, tax revenues 20%, GDP 10% per capita. So unsustainable levels. The way of life we have now, how are we going to keep it? We're going to keep it if we do the right things and get the longevity dividend. And what I mean by dividend, there are many suggestions, components. It's the economic, it's the social, it's developmental, and personal. So these are gains that society and the state could have from the longevity dividend, which is growing older in good functional health. That's what it is. These are some publications from economists who try to estimate what that is. Indeed, it is the greatest challenge we face as a country. This one is a study by Andrew Scott that have estimated that the GDP could actually increase if we have older and healthy individuals, and they've estimated 4 to 5%. This is again from OECD. Look at the red line, if the blue line, if we do nothing, at least, and this is conservative estimates, if we do prolonged healthy longevity policies, at least we will attenuate the impact on GDP. And these are the measures of increase for long-term care. If we do nothing, 8 percentage points. If we try to contain it, 3. So yes, it's not totally attenuating, but there is a 5% difference in increasing. Even the Davos, the annual meeting, had to develop the longevity economy principles, because healthy longevity, we're all doctors here, but healthy longevity is not only a medical issue, it's a societal issue. And this is a publication from the World Bank, says the same thing. I like this one because it shows, it's from the UK, you see the percentage increase in annual GDP due to 20% reduction in disease incidence in all these chronic diseases that have stress as underlying factor, the non-communicable diseases. So you see that if we manage to reduce even 20% the incidence, we have gains, because they cost a lot to treat them. It's so simple. And another nice study from the UK that showed that if we move 20% of those who say, I'm not feeling, I'm old, but I'm not doing great, to, yes, I'm fine, functional, just a proportion, it adds to the UK economy close to 300 million. Just a small percentage of people that will become more functional and healthier and living in their societies and in their communities. So, again, all the studies looked consistently. This is a nice study from the US that shows what we can gain if we slow, for example, brain aging by 1 year, what is the gain to the GDP and the net present value and the life saved. It's behind the chairs, but look at the organ supply, or look at slow biological aging by 1 year. So about 400 billion annual gain to the GDP. These are US numbers. They do great stuff. They have the numbers, they have the data to work on. So fantastic benefits, even by slowing aging by a year. So this is a silver tsunami, and communities who care, and this is a study from the US again, they developed the Longevity Preparedness Index with MIT, trying to see whether communities are ready to accept the silver tsunami. In other words, aging. And this, you see, it's not only a health issue. It is a home, finance, community, daily activities, life transition, social connections. There's a variety of things that are impacted by living longer and whether we're healthy or sick in those years. So this is, you could always go back and see it. Stanford Center of Longevity, they do the same. Let me just go. This is some good practices that other countries have adopted. And basically, these are the principles. And this is what we need to do. life cycle thinking, early investment pays decades later. We know that. Strong community-oriented primary care, integrated system for older adults, structural prevention, systematic, not ad hoc, enabling older adults to contribute and also increase experiences and create the enabling environment. Other countries have started doing that and see results. Here you see a list. Interestingly enough, there are two countries in Asia, Brazil and Chile, that started implementing, and some of these policies also. Of course, Singapore, we heard before. So health is not just health policy. Policies that pay off exist. Aging, we have to see it as an opportunity and not as a burden. And we need to get a little bit more serious here in Greece. The longevity economy, we've heard, can go all the way up to 6.4 trillion. And the most active group in the States, and I think in Europe, are those over 60, because they have, if they have good pensions of course, but this is a very active group that marketeers should target, and we don't see that yet. So the longevity revolution is one, indeed, of humanity's greatest achievements. If it becomes a burden or an opportunity, it is not determined by biology, because biology will get us there, and the work of people we heard will get us there. It is determined really by policy issues, investment decisions, and the norms that apply to a society that respect, and there is no aging discrimination. So really the question is, can we afford to ignore healthy longevity? This is what we need to ask. And I will end up with two examples in terms of the pharmaceutical intervention that came up just last month. Very exciting advances. One is in Japan, where they approved the first stem cell therapy for Parkinson's. It got a conditional approval that they inject stem cells that were created in a lab from a healthy donor to the brain of people suffering from Parkinson's. And because of the very positive results, this procedure got conditional approval, and of course they will follow further. But it's the first ever. And the other, this is in Japan, now we go to the States. This month started clinical trials with the Life Biosciences. It's a company that uses the Yamanaka factor, uses a cocktail of 3 factors to rejuvenate aging cells in the optic nerve and reverse blindness. All the experiments up to non-human primates were positive, worked. And now it's happening in human subjects in the US. So we have lots of things to look forward, but until we get all of this, I'm coming back to this. It's up to us. How we walk, what we eat, what we think, whether we're stressed or not. This is up to us to gain up to more than 14 years and add in our healthy life. And it's never too late to start and add things. So, thank you very much.
Thank you, Dr. Hadjiandreou. And now, before we have some kind of discussion in the panel, I would like to take some questions or brief remarks from the audience. If you would like to phrase your question, also you can use Greek words, Greek language, because not everybody is expert. Yes, present if you want yourself, please.
Okay, thank you so much for your wonderful talk. My name is Atava. I'm a fifth-year medical student from the English program at Aristotle University. My question is, especially for Kyria Evi, but for all of you. As we know with longevity medicine, it looks a lot at people who are already in decline, people who are in their 40s, their 50s and 60s. But would you say there's a huge window being missed from the age of 18 to 30, which actually dictates the biological trajectories of when you are 40 and when you are 60? And would you say that we can do something in this space to optimize the health of the youths, to crack down on their habits, which in turn would lead to increased health span when they are 40 and 60? Thank you.
You address this question to whom?
Your question is extremely important. To the point, yes, we need to intervene in younger life. I can tell you that the way our university systems work in this country is very harmful to our people. When people go, young men or women become 16 years old, they start being stressed about the exams at 18. And it's not only the students, but their parents as well, and their siblings, the entire family. They stop exercising, they stop eating well, and they stop sleeping well. In my case, I've seen people, because I follow them very closely, there is a tremendous change, negative change from 16 to 19. So already the damage starts early. We need to instill healthy habits throughout life. And I don't know if you saw the 2 suicides last week, 2 weeks ago. They jumped. It's because of these exams. The parents expect a lot of their children. The children maybe overestimate the expectations of the parents. They feel that they cannot deal with that, they cannot fulfill those expectations, and that creates a lot of pathology. What you saw is the tip of the iceberg. There is a lot of stress and pathology underneath, and we need to do something to intervene. And since you mentioned that, I'd like to ask Dr. Hadjiandreou to tell us, if you calculate how healthy life, longevity medicine, would be applied next year in Greece, will that save us from this decline in the GDP and the decline in the population?
It will definitely attenuate and shorten the angle of decline. The earlier we start, of course, the better it is. But there is no, because you all know, it's never too late to start. So even if we start at 60 and 70, there are benefits. Even doing small resistance exercises at Eurocomia, and they show benefit in building muscle, therefore preventing the falls, that will show. So everything counts. Τίποτα δεν πάει χαμένο. But it needs a very systematic approach from the state, which we don't have yet. Hopefully, as our institute, will be able to work on that.
Yes. Regarding your question, I fully concur with the professor. And your question was very important because I mentioned in my introductory remarks about 2 cluster bursts, 40 years and 60. Actually, recent studies show that we have 4 between the age of 30 to 40 and after 80. So indeed, we need to take measures early. And one of the first biological settings, molecules that are affected are the blood proteins. So indeed, you are right. We need to take measures earlier. Can I ask a question regarding, yes. So Evie, you mentioned that by taking measures, our GDP will be increased. There are progressively, right? There is a mathematical model that says that if we, because every scientific advantage has its pros and its cons, it's very clear that by expanding our life, and longevity means adding life in years, we need healthy longevity. There's a model, and this puzzled me, that if we extend it, we will have labor shortage because the birth rate will decrease. Is this valid? Does this make sense? Because I'm a bit puzzled with this shortage of labor. This is a bad scenario.
Shortage of labor would happen because of aging, to start with. So one of the policies that they recommend is to allow those over 60 or 65 to work. We have now one measure here in Greece. So the shortage really comes from the aging. However, what increases, and we have seen that, is, and this is how we're going to use it, is technology, increases productivity. And therefore, that will also increase the GDP. So it's a matter of balance, which one will prevail and which one will be harder, how they both of them count for the GDP. The study that Oxford did, and that's highly cited, is that 1 year of healthy life year adds about 400 trillion to the US economy. 1 year of healthy life expended, yes. Then it's all the other, the UK study, the non-economic, but still, it's volunteerism, is social connection, is doing things that don't have a hard economic value, but they do have value and they add up. No, but we'll write an article. We'll go and see them.
Yes, please.
My name is Varvara, and I live in Australia. I really enjoyed the presentation and the science behind it. I'm a practitioner. I had the good fortune of managing a health and well-being program in a large corporate. It was the best career that I had for 8 years. What I'm interested in, and it's following up from your last comment around productivity, we were able to sell the idea to the organization that if we had healthy employees, absenteeism would reduce. And we were able to show that with all the programs that we did. So my question is, are there similar organizations in Greece that implement what the research says? Thank you.
Great point. First, let me say that indeed programs, even worksite programs, they show and they measure actually in economic terms not only absenteeism but also presenteeism, which is even worse because you can go to work and not being productive. Yeah. So yes, these things work. In Greece, we see an increase through the social responsibility component, the CSR, for big companies, but it's really very big companies and multinationals that deal with it. It's not so prevalent yet.
Ακούγομαι. Ναι, καλησπέρα. Καλησπέρα και από μένα. Ευχαριστούμε πάρα πολύ για την ενδιαφέρουσα παρουσίαση. Έχω 3 ερωτήσεις. Πρώτον, για τον κύριο Χρούσο. Είμαι η Φένια Τσανάκα, είμαι αρχιτέκτον και ασχολούμαι με τη φιλοσοφία. Θέλω να ρωτήσω, το στρες, όταν είναι για θετικό πράγμα, δηλαδή χαλάει η ισορροπία, αλλά για ευχάριστο, είναι στρες, είναι κακό στρες?
Γενικά, ό,τι είναι ευχάριστο δεν είναι κακό. Γενικά.
Γενικά,
Βέβαια
δηλαδή...
υπάρχουν αυτοί που τρέχουν πολύ, που το ευχαριστούνται το τρέξιμο. Εάν υπερβούν, το έχουμε μετρήσει αυτό, 45 μίλια τη βδομάδα, έκαναν πολύ κακό στον εαυτό τους, μόλον ότι τους άρεσε και δεν το σταματούσαν. Δηλαδή, γενικά, το F-stress είναι καλό για τον οργανισμό, όχι κακό, καλό. Αλλά και εκεί υπάρχει το μέτρον άριστον.
Γιατί ακόμη και στη δημιουργία χαλάει αυτή που λέμε ισορροπία. Άρα λέτε
Δηλαδή
ότι...
και εκεί χρειάζεται μέτρο.
Άρα στους μηχανικούς που μου είπατε ότι έχουν στρες, δεν μας πειράζει τόσο πολύ.
Όχι αν το ευχαριστιέστε.
Ωραία. Εντάξει. Άρα αισθάνομαι ήσυχη. Δεύτερη ερώτηση είναι αυτό που με εντυπωσιάσατε, είναι που δώσατε την αρχιτεκτονική ονομασία στη δομή, γιατί πράγματι οι αρχιτέκτονες μπορεί να συνδυάσουν διαφορετικά υλικά με διαφορετικούς τρόπους και να βγάλουν ένα τελείως διαφορετικό αποτέλεσμα. Άρα μ' άρεσε πολύ η ιδέα. Και θέλω να φτάσω γιατί τα άλλα ήταν λιγάκι πιο ιατρικά. Έχετε σκεφτεί ότι αν αλλάξουμε συνήθειες και κάνουμε καλές συνήθειες, μπορεί από μόνο του να πέσει το ΑΕΠ, με την έννοια, αν εγώ γυμνάζομαι, που χρειάζεται να γυμνάζομαι και περπατάω 1 ώρα την ημέρα και κάνω και κάποιες ασκήσεις γυμναστικής και πρέπει μισή ώρα πριν να ξεκουραστώ για να το κάνω αυτό και μισή ώρα μετά και πρέπει να μαγειρέψω κιόλας για να τρώω υγιεινά. Όλες αυτές οι καλές συνήθειες αφαιρούν από το ΑΕΠ, διότι εγώ δεν δουλεύω εκείνη την ώρα. Χτίζω... Αυτό το έχετε υπολογίσει? Το λέω διότι πολλές φορές όταν λέω στους φίλους ότι εγώ ακολουθώ ένα υγιεινό τρόπο ζωής, η απάντηση είναι δεν έχεις οικονομικό πρόβλημα, γι' αυτό το κάνεις. Εμείς που πρέπει να βγάλουμε το προστοζήν, δηλαδή θέλω να πω ότι το καπιταλιστικό σύστημα είναι στημένο να κάνεις πράγματα για να ενισχύεις το ΑΕΠ, που βέβαια το πληρώνεις αργότερα. Εάν σταματήσουμε και κάνουμε τα σωστά πράγματα, θα πέσει το ΑΕΠ. Όχι, δεν είναι, αλλά λέω αν έχει μετρηθεί.
Λίγο το μικρόφωνο καλύτερα. Ανοίξτε το λίγο. Πάνω και το αφήνετε 2 δευτερόλεπτα για να λειτουργήσει.
Δεν είναι τόσο δραματικό, γιατί πάλι την ώρα που θα δουλέψετε θα είσαστε πιο παραγωγικοί. Πάντα μπορεί να εξισορροπηθεί αυτό. Δεν είναι αυτό που είπα, δραματικό το ότι θα προσέξεις τι θα φας ή αν θα κοιμηθείς λίγο παραπάνω για να επηρεάσει πια την όλη αποδοτικότητά σου και την προσφορά σου εργασιακά. Όχι, δεν έχει μετρηθεί. Σας δεν δίνω λίγο την πρώτη αντίδραση σκεπτόμενη, γιατί το ΑΕΠ έχει να κάνει και με την παραγωγικότητα. Και εμείς εδώ στην Ελλάδα έχουμε ακόμα αρκετό δρόμο για να ανεβούμε κι άλλο στο κομμάτι αυτό.
Ναι, το λέω σαν σύστημα.
Ναι. Όχι, θα βρείτε... Κοιτάξτε, θα κάνετε αυτά που πρέπει, άρα θα αυξηθεί ίσως τα ρούχα τα πιο καλά που θα πάρετε για τη γυμναστική ή αυτό που θα μαγειρέψετε πιο ευγιεινό. Δεν είναι μόνο η δικιά σας εισφορά στο ΑΕΠ, είναι και όλος ο κύκλος των δραστηριοτήτων σας, που έμεσα συμβάλλουν και αυτά. Οπότε δεν είναι τόσο ξεκάθαρο ότι θα υπάρξει αρνητικό αποτέλεσμα. Αν δεν μετρήσεις, δεν μπορείς να ξέρεις.
Ναι.
Θέλατε εσείς, ναι.
Ευχαριστώ.
Γεια σας. Και εγώ είμαι φοιτητρία ιατρικής στο 5ο έτος στο Αγγλόφωνο, από τη Μελβούρνη της Αυστραλίας.
Θα σηκωθώ καλύτερα, να με βλέπετε. And I was wondering, you stated that there's a lot of money to be saved from people in older ages being healthier and not falling and less admissions to hospital. In Australia, we take that very seriously, and generally we have a pretty good system of health in terms of remaining healthy, and even people in the elderly homes that we're talking about, they do exercises, they talk with each other for social health, for mental health, for spiritual health, as well as physical health. But I've noticed that people of older ages here in Greece don't tend to believe in longevity often. Like they tend to have that attitude of, oh, αυτά είναι ψέματα, δεν πιστεύω σε αυτά, δεν πιστεύω ότι θα μεγαλώσουμε, θα μεγαλώσουμε. Δηλαδή τώρα γεράσαμε και καλά. Δηλαδή και να είναι σε μια ηλικία που μπορεί να μην είναι απαραίτητα τόσο μεγάλη. Πάλι θα θεωρήσουν ότι δεν μπορούν να κάνουν κάτι για να αντιστρέψουν την υγεία τους, άσχετα αν είναι physical ή mental ή emotional. What's your opinion? How can we improve the attitudes of older people in Greece in regards to their attention and beliefs on longevity?
Good question. It's, you're true, your observation is true. Αυτό το, είναι γεράματα, I mean, for God's sake, πολλά of what we say είναι γεράματα, είναι chronic inflammation in your body that if you improve it, all of a sudden you'll get back and start running. So, yes, it's an attitude, and actually this was one of the reasons that we're all founding members here created the Institute for Healthy Longevity, because we intend to be very active in pushing the state to do things. And this is not only state or government. I mean, just imagine even a series in TVs with in the States, I remember the Golden Girls that, they were all over 70, 80, right? So there are ways to start shifting the mentality. And hopefully, at least we will do our part.
At the Children's Hospital in Athens, we start a program now to have retired people come and play with the children, spend time and do activities with them and so forth. And this is something that's been used in the States and very, very well. So there are things to do, and we try, we teach, we write articles, we talk to municipalities. I've been around the country many times discussing these things, and hopefully the message will come across.
Amazing, thank you. Yes?
It's not a problem of the older society. It's a mentality problem of the Greek society, from the younger. It's not only for the old. We need to implement this philosophy in all levels of the society.
Is that something the older Greeks are going to listen to?
It's a mistake to retire. People should not retire. They should do things after the retirement age.
We need to have a vision.
Good outlook. Thank you.
Are there any more questions from... Yes?
So I just wanted to touch upon the point of mentality. I also think that it's not just with old people, it's with the younger generation too. When I talk about longevity medicine with my colleagues and with younger people, a lot of people think it's pseudoscience and just very expensive and just for rich people. However, there is science behind it. So my question is, how can we educate younger people? We're not taught this in our medical school curriculum. The modern model of medicine is reactive, and that's what we're taught in medical school. We're not taught about prevention or longevity. So how can we basically transition towards this point of view, and how can we educate younger students?
We need to change the curricula, and it hasn't been easy. For example, in Athens, we started a graduate course after medical school, master's course, and PhD in stress medicine, which is about the same thing. You know, lifestyle and so forth. I think it's going to take a while, but lifestyle medicine must eventually prevail because that's the way to go.
Λοιπόν, πριν τελειώσουμε, γιατί πλησιάζουμε, θέλω να προλάβω και σαν επίλογο όλου αυτού να σας θέσω ένα ερώτημα προς όλους, κυρίως στους καθαρούς γιατρούς, γιατί η κυρία Χατζηανδρέου είπε, ενώ γιατρός είστε, αλλά ενώ αυτά που είπατε ήταν περισσότερο κοινωνικο-οικονομικά, ακριβώς αυτά τα ερωτήματα. Σαν δημοσιογράφος παρακολουθώ χρόνια και το δημογραφικό ζήτημα, το συνταξιοδοτικό της χώρας, το οποίο είναι άλυτο, ακόμα και με τους όρους των ηλικιών που ξέραμε. Πραγματικά είναι ένα μεγάλο ερώτημα. Εσείς τρέχετε, έχετε κάνει πάρα πολλές, από ό,τι φαίνεται ακόμη πιο γρήγορες ανακαλύψεις από ό,τι ξέρει η κοινή γνώμη και θα βγουν φάρμακα, θεραπείες και σύντομα. Δεν συζητώ για αυτές τις προβολές που είδαμε ως το 2100. Ας πάμε τουλάχιστον στον ορίζοντα το 2050. Είναι συνταρακτικές οι αλλαγές. Και πραγματικά είναι ένα μεγάλο ερώτημα εάν το πολιτικό σύστημα της χώρας, το κράτος, οι κοινωνικές υπηρεσίες, εσείς βεβαίως και στον ιατρικό κλάδο, αλλά και η πολιτισμική πλευρά του ζητήματος, δηλαδή πόσο σαν πολιτισμός είμαστε έτοιμοι για αυτή την αλλαγή. Και φυσικά εδώ και μόνο το ασφαλιστικό σύστημα να δούμε, υστερεί, δεν μπορεί να προσαρμοστεί. Νομίζουμε ότι το λύσαμε, δεν είναι αλήθεια αυτό το πράγμα. Επομένως, τι μπορείτε να πείτε έτσι, εν κατακλείδη, όλοι θα ήθελα μια γνώμη και κυρίως εσείς, ας πούμε, που το βλέπατε από τη μεριά την καθαρός ιατρική τόση ώρα.
In my opinion, it's παιδεία, education for everybody, not just at school, but throughout society. All ages must be educated properly. So that's what we need to do. Unless we change this attitude, because it's like cognitive behavioral therapy. We need to do cognitive therapy first, trying to change behavior second. So the entire society, the whole country needs CBT.
Και εσείς, κύριε Βλαχ. Είστε και ο πιο νέος εδώ. Έχετε χρόνο να τα δείτε όλα μπροστά σας.
Λοιπόν, εγώ πιστεύω το εξής, ότι σίγουρα ό,τι είπαμε πριν και φυσικά όλα ξεκινάνε από την παιδεία και τα λοιπά και το στρες πολλούς ανθρώπους τους οδηγεί σε αδιέξοδο, αλλά το στρες έχει και μια θετική νότα. Αλλαγές δεν γίνονται χωρίς στρες. Αν δεν πιεστούμε, δεν θα καταλάβουμε καλά τις σπουδές μας, δεν θα πιεστούμε, αν δεν στρεσαριστούμε στα εργαστήριά μας, στην έρευνά μας, δεν θα κάνουμε ένα χρήσιμο αποτέλεσμα. Αυτό θέλω να πω. Το χρόνιο στρες, λοιπόν, δηλαδή ένα οξύ περιστατικό, το αντιμετωπίζουμε. Το χρόνιο στρες, το οποίο το αφήνουμε να μας ροκανίζει, να μας καταπονεί, είναι το πρόβλημα. Και η ιδέα είναι η εξής, από τη δική μου την πλευρά. Ξέρουμε αυτά που λέμε, προσπαθούμε να βγάλουμε κάποια συμπεράσματα και να βρούμε ένα αιτιατό και να ανακαλύψουμε ένα μηχανισμό και να τον προσφέρουμε στην επιστήμη. Αλλά όλα αυτά δεν θα μπορούσαν να είχαν γίνει αν δεν υπήρχαν και άλλες δομές στην κοινωνία. Η ιατρική στηρίζεται και σε άλλες επιστήμες εκεί έξω, οι οποίες πρέπει επίσης να εξελίσσονται. Οπότε εγώ πιστεύω γενικότερα ότι αυτό είναι ένα... όπως είπα και πριν, γι' αυτό μίλησα για αρχιτεκτονική και στα βιολογικά μονοπάτια, αλλά δεν θα έρθει ένας γιατρός μια μέρα και θα ανακαλύψει ένα φάρμακο, θα το φάμε όλοι και θα γίνουμε ονόβοι. Το να περνάμε καλά στην κοινωνία έχει να κάνει και με άλλες επιστήμες. Έχει να κάνει και με τέχνες, έχει να κάνει και με φιλοσοφία, έχει να κάνει και με την αλληλεπίδραση που έχουμε μεταξύ μας. Και οι γιατροί, επειδή στρεσαριζόμαστε πολύ στα εργαστήρια, χρειαζόμαστε αυτές τις άλλες επιστήμες για να ξεστρεσαριζόμαστε και να μην πάθουμε από chronic stress κάτι κακό και δεν καταφέρουμε ποτέ να βγάλουμε τα φάρμακα. Οπότε πιστεύω ότι δεν είναι... Εμείς δείξαμε αυτά που δείξαμε, γιατί αυτά ξέρουμε να δείξουμε, αλλά νομίζω ότι είναι ένα καθαρά, τελείως ομαδικό πράγμα που πρέπει να συμβεί Και πιστεύω σε αυτή την παιδεία που είπε και ο κύριος Χρούσος πριν, αλλά σε διαφορετικά χρώματα και μορφές, έτσι ώστε να στηρίξει όλη η κοινωνία αυτή την προσπάθεια και όλη η κοινωνία να είναι μέσα ανακατεμένη στο πώς τελικά θα πετύχουμε την υγιή μακροζωία. Κάτι τελευταίο είναι ότι η παθολογία, η εξατομικευμένη ιατρική που λέμε, αυτό κάνει. Prevention κάνει. Δηλαδή, όταν προσπαθούμε να μάθουμε ένα μηχανισμό, στην πραγματικότητα δεν είναι τόσο σημαντικό να μάθουμε το μηχανισμό, γιατί όταν χαλάσει ο μηχανισμός να πάμε να τον θεραπεύσουμε, να τον αποκαταστήσουμε. Προσπαθούμε να μάθουμε το μηχανισμό, έτσι ώστε ξέροντας το μηχανισμό να μην συμβεί το παθολογικό, έτσι, η παθολογία, να μην τη φέρουμε ποτέ στην επιφάνεια. Άρα πιστεύω ότι αυτές οι επιστήμες πλέον δεν είναι ότι, και για το curriculum που είπατε πριν, εντάξει, σίγουρα, αλλά ένας νέος γιατρός πρέπει να ξέρει πολύ καλά πλέον ότι το lifestyle medicine είναι εδώ και ότι όλοι τα νοσοκομεία δεν είναι για τους αρρώστους και ότι τα ερευνητικά μας κέντρα και τα εργαστήριά μας δεν φτιάχνουν θεραπείες, φτιάχνουν χάρτες, οδικούς χάρτες, χαρτογραφούν το άγνωστο για να μπορούμε σιγά-σιγά να κάνουμε επεμβάσεις και να κάνουμε αλλαγές στη ζωή μας χωρίς να χρειάζεται το νηστέρι του γιατρού, του χειρουργού ή το ψυχοφάρμακο του ψυχιάτρου, έτσι όπως πάμε. Αυτά.
Κύριε Γοργούλη.
Ναι. Ο καθηγητής είπε τη μαγική λέξη παιδεία. Κάθε καινούριο προκαλεί πάντα μία κοινωνική αναταραχή. Όσο πιο καλλιεργημένος είσαι, τόσο πιο εύκολα το αντιμετωπίζεις. Οπότε, εγώ πάντα απαντάω στους φοιτητές μου, nature will find its way. Μέσα από τη διαδικασία του error and trial and error, θα βρούμε τη ισορροπία μας. Οπότε αυτή είναι η απάντηση, ότι η κοινωνία θα βρει τους ρυθμούς στο τέλος, θα βρει το optimum. Όσο μεγαλύτερη παιδεία έχεις, τόσο πιο σύντομη είναι η περίοδος της αναταραχής. Και της προσαρμογής.
Ωραία. Κύριε Χατζηανδρέου, από τα τόσα στοιχεία μας δώσατε σε 5 bullets, πώς θα απαντούσατε πώς θα αντιμετωπίσουμε αυτό το σοκ της αλλαγής, ας πούμε, της ηλικιακής και της μακροβιότητας.
Η παιδεία παίρνει λίγο χρόνο μέχρι να βγάλει καρπούς. Κοιτάξτε, ένα πολύ σημαντικό πρόβλημα στην Ελλάδα είναι ακόμα και μετά τα μνημόνια η early συνταξιοδότηση. Ναι, το early retirement, γιατί το να θες να φύγεις στα 50 ή στα 55 και στα 60, δεν ξέρω, μου φαίνεται αυτό που δεν ξέρουν αυτοί που θέλουν να φύγουν και ίσως εκεί μπορούμε πολύ να τους χτυπήσουμε στο κεφάλι, είναι πόσο αυξάνεται η κατάθλιψη και η θνησιμότητα άμεσα, σαν cause and effect, μόλις πάρει σύνταξη. Κάπου να αρχίσει ο κόσμος λίγο να το συνειδητοποιεί αυτό το πράγμα.
Η αλήθεια είναι ότι εξαρτάται και από το τι δουλειά κάνεις.
Εννοείται.
Αλλά και αυτοί που έχουν δουλειές δύσκολες και πρέπει να σταματήσουν γιατί είναι χειρονακτικές. Και αυτοί πρέπει να έχουν βρει κάτι να κάνουν μετά. Και εκεί μπορεί πράγματι η πολιτεία που τους δίνει νόημα.
Να τους δίνει νόημα. Και είτε να συνεχίσουν πιο ελαφρά σε αυτό που κάνουν, είτε επιτέλους να αυξηθεί κι άλλος ο εθελοντισμός. Γιατί και ο εθελοντισμός έχει δείξει ότι μειώνει τη βιολογική σου ηλικία. Όπως και η τέχνη. Βγήκε μια μελέτη πριν από λίγες μέρες σε μουσείο. Μέτρησαν αυτούς που πάνε και κάθονται και βλέπουν έργα τέχνης στο μουσείο. Μειωμένη βιολογική ηλικία. Δηλαδή, η τέχνη. Είναι η ενσυνειδητότητα, είναι η ηρεμία όταν βλέπεις ένα έργο τέχνης. Όχι, μειώνεται. Είχαν μειωμένη και δείκτες inflammatory και μειωμένη. Άρα, είναι μερικά πράγματα που πρέπει άμεσα να γίνουν και η κοινωνία δεν έχει εκπαιδευτεί πάνω σε αυτό. Και βέβαια εδώ είναι καθαρά θέμα πολιτικών και λαϊκισμού, έτσι. Όταν κανείς, και των media, όταν κανείς δεν λέει πού θα βρεθούν τα χρήματα για να πάρουν όλοι σύνταξη νωρίς. Το να δουλεύουμε και η εθελοντική δουλειά έχει χαρά. Έχει φανεί ότι αυτός που προσφέρει ωφελείται περισσότερο από αυτόν που λαμβάνει την προσφορά. Αυτά πρέπει να τα πούμε. Μπας και όσοι αλλάξουν είναι κέρδος.
Λοιπόν, να ευχαριστήσουμε πάρα πολύ. We thank you all for your patience and it was not an easy time of the day. Thank you all in the panel.
τεχνητή νοημοσύνη στις ανθρωπιστικές επιστήμες. Στις επιστήμες που μαζί με τις κοινωνικές επιστήμες αντιμετωπίζουν ίσως και τις σημαντικότερες προκλήσεις και κινδύνους από την χρήση της τεχνητής νοημοσύνης. Πολλά λοιπόν από τα πάνελ της σημερινής ημέρας, τόσο εδώ στο κεντρικό stage του περιπτέρου 15 της Διεθνούς Έκθεσης Θεσσαλονίκης, όσο και διάφορα satellite events, σαν αυτά στο συνέδριο που γίνεται παράλληλα στο χώρο της Παιδαγωγικής Σχολής του Αριστοτελείου Πανεπιστημίου, είναι αφιερωμένα στις ανθρωπιστικές επιστήμες και στην τεχνητή νοημοσύνη. Σε αυτήν την ώρα που θα ακολουθήσει έχουμε την χαρά και την τιμή να φιλοξενούμε τρεις σπουδαίους ανθρώπους που ασχολούνται με τα υπολογιστικά μοντέλα και το ρόλο που παίζουν στις ανθρωπιστικές επιστήμες. Ο επικεφαλής αυτού του session, ο καθηγητής ο Δήμηταρ Στεριόνοφ, στο Πανεπιστήμιο του Τίλμπουργκ, είναι ένας δικός μας άνθρωπος, είναι απόφοιτος του Αριστοτελείου Πανεπιστημίου, του Τμήματος Πληροφορικής, και είναι ένας άνθρωπος για τον οποίο τον γνωρίζω από την νεαρή του ηλικία. Είμαστε περήφανοι που είναι απόφοιτός μας και είμαστε περήφανοι για το ήθος του, αλλά κυρίως για την επιστημονική διαδρομή την οποία ακολούθησε μετά το Αριστοτέλειο Πανεπιστήμιο. Μετά το Αριστοτέλειο Πανεπιστήμιο βρέθηκε στο Βέλγιο, στη συνέχεια στην Ιρλανδία, και από τότε συμμετέχει και κατευθύνει μερικά από τα πιο πρωτοποριακά ερευνητικά προγράμματα που σχετίζονται με την πληροφορική, την τεχνητή νοημοσύνη και τη χρήση τους στις ανθρωπιστικές σπουδές. Ο Ντίμηταρ έχει φτιάξει το δικό του πάνελ από ανθρώπους που είναι κατεξοχήν ειδικοί σε παγκόσμιο επίπεδο στον τομέα αυτό, και είναι χαρά μας που τους έχουμε σήμερα μαζί μας. Dear colleagues, thank you for coming to the Aristotle Innovation Forum and to our university, Aristotle University of Thessaloniki. This panel and today's session are focused especially, mainly, most of them, on the relationship between artificial intelligence and humanities, which is actually a little bit controversial till now, and we are in a position to hear you now, and I'm sure that your contributions should be very valuable to the open discussion on the future of the humanities and the fourth industrial revolution while living in. Please, Dimitar, the floor is yours.
Καλησπέρα σας όλοι. Hello everyone. I'm very happy to be here. As Professor Michailidis said, I did finish my bachelor here in Thessaloniki, and I went away to do the rest. Today I'm here with my colleagues, Professor Lieve Maka and Dr. Valerio Lorini. They come from different, or they're working on different backgrounds. We all work on different fields, subfields of artificial intelligence. And we're going to talk about the impacts of large language models, and I assume that you all are familiar with large language models and ChatGPT and so forth systems, and the impact on education, the impact on applications, the impact on translation, the impact on, data, humans, and nature. Okay? And we're going to start with the presentation by Dr. Lorini. Would you like to join the floor?
Hello everyone, my name is Valerio Lorini and today I'm going to actually talk about how we are trying to implement at the European Parliament a framework for actually studying and to understand how can be the impact of this large language model on the legislative text, on the legislation that is affecting actually 450 million people in Europe. And so I will tell you about what we do at the Parliament and what is the challenge and how we are thinking of actually improving it. Who are we? I work for the European Parliament. I'm based in Luxembourg, and I work for the DG Trad, Director General for Translation and Clear Language, where we have 1,100 more or less colleagues, staff, and among them 650 are translators. We have one unit per language. We have 24 languages, as all of you know, and each different language is equally important in Europe. We don't have main languages or other languages. And we can also rely on 30 years of stored, previously translated text that are actually our base where we build our work upon. And the baseline that we want to, and as you can see down, maybe it's behind the armchair, but what we are trying to do is to establish a framework for testing, for doing some analysis of large language model when it comes to legislative text, because it's very important to us. The official language of Europe, to give you a bit of context, you know the origin of Europe, of the European Union, was centered on creating peace, and so far it worked. And we started after World War II, and the idea defied borders, cultural differences, and it seemed impossible in the beginning, but actually now here we are collaborating, 27 member states, and multilingualism was always at the heart of Europe. So each country could rely on their own language and understand at the same time each other. And the first regulation, actually in 1958, was in 4 official languages, was Italian, German, French, and Dutch. And we came a long way since then, and now we have 24 languages. As you can see, the latest have been added. And so today we have 24 languages. We translate a lot of documents. We translate for the members of the Parliament, of the European Parliament, because we have representatives for 27 countries, and actually they have the right to speak their own language, to present law and amendments in their own language, and they have the right to understand each other. So we always translate what they are presenting at the Parliament. So, for instance, a Lithuanian member of Parliament can actually write a piece of legislation or a proposal in their own language, and at the same time, various member states, they can try to change the law, but using their own language. So for them it must be transparent. They have to see everything in their own language, but then when it is presented to us, it is edited, it is put together in English most of the time, and then translated for all the languages. So as you can see, is a kind of more of a production work than a creative work. But we don't translate only for members of parliaments and politicians. We translate also for citizens, because you have the right to read the European legislation in your own language, and also to address also citizens can present their own petition to the parliament, so they can present the changes, amendments to the law. They can ask questions to the parliament, and so we are actually also translating the original text in all the different languages because it has to be then adopted in the national law. So that is why terminology is also very, very important. What do we translate? One of the most, let's say, translated document, piece of legislation are amendments. Amendments are actually the changes that a member of parliament tries to apply to a proposal that comes from the European Commission or from the Parliament or from the Council, and they actually all this has to be done in this week of the session of the plenary session when they vote, and so we have. You can imagine that you have a main proposal that maybe is coming in English, and then you have different members of parliament trying to apply changes to the text, and they have to actually to agree on these changes, and these changes have to be translated like in a few hours into all the languages. So a change that is proposed by a Spanish member of parliament can be actually read in Italian by an Italian member of parliament and discussed and then approved. And what we produce, actually what the translation is producing is translated in 24 languages, but it is translated for citizens as well. So again, the impact, you can imagine the impact on automated translation when it goes wrong. How we work and the amount of work that I was telling you earlier. You can see a few numbers. In 2024, it was not a common year because it was election year. So we had relatively fewer documents to translate because we stopped the legislative term and then we started a new one. And most of the texts to translate were communication reports about what has been done and the communication to actually to encourage people to go voting for the European election. While in 2025, it was more of a normal year, let's say, and we had 2.2 million pages translated. So you can imagine the amount of work that has been done in the Digitrad directory. And 28% of these documents are outsourced. So we engage freelancer to help us in translating because the amount of work is too much. So we set up a kind of workflow that is, as I was mentioning you, is more of a chain of production rather than you can, maybe you have an idea of a translator that is sitting on the desk and trying to figure out how to translate the text. In our case, it's more of a kind of structured job, and it has several stages. We have the various DG proposing the text, what we call a client request. Then we have planning a pre-processing unit. I'm not going to describe now in the details. If you are curious, you can ask me later. And so we prepare translation using what has been already translated mainly. Then we have to give a context to the translator, we have to give references, we have to give terminology because they cannot screw terms because this then goes into laws. And then once it is everything is translated after the book out, we have also the quality control. We use specific translation tools for that. Everything is not left to the choice of the translator. So what we rely upon is a set of translation memories. Translation memories are piece of text that have been already translated, and we collected 30 years of translation in the Euramis database. I don't know if you ever heard about it. And this is accessible to all the European institutions, but also to citizens. These translation memories are translated and validated by professionals, and they are what we actually use, because if you think about a legislative text, most of the time it starts in the same way. So what's the point of retranslating something that has been already translated probably in a lot of documents? So we are using that. But also we use specifically designed cut tools. One example that I give you is, think about, I'm Italian, my prime minister now is Meloni, that if you translate the name in melons, or we had Draghi in the past that can be translated in dragons, but so you have to pick the name of the member of parliament in order not to translate them. I lived in Greece, I worked in Greece 18 years ago, and I had a colleague of mine that whose surname was Kopidaki. So imagine translating Kopidaki in English. So we have all these special tools that are helping us avoid these such problems or misspelling or the references to laws that may be wrong. And of course, we rely on machine translation more and more. We used so far neural machine translation. So let's put it this way. It is the old school way of using artificial intelligence. It's based on rules and different grammar rules. Like now it's more of based on, the LLMs are more based on actually a connection between words and piece of text. And so we do all this because, of course, we need, as I told you, everything has to be done in very quickly, and it has to be done with a good quality, and of course, it's also a matter of money. The more productive we are, the less money is spent. I've shown you before that like it was 30% of the document, 20% were actually outsourced to freelancers. And guess what? With the advent of large language models, our politicians, our member of parliaments are also producing, or they feel more confident in producing more legislation and more text to translate. Therefore, actually, we have more work to do and more pages to translate. So what's the challenge? Actually, the smart guys came to us and started telling us, oh, we can use LLM. Why don't you use LLM to translate? LLM is good quality. It can be compared to professional, to the work of professional translators. And we said, okay, let's check though, please. And because we cannot only based our evaluation on some random check, and most importantly, we want to know exactly how these LLM are performing against all the different languages, not just the usual English, Spanish, Italian, German, French, the most spoken one. We also need Maltese, we also need Irish, and we also need Greek or Bulgarian. And another important topic, seen actually the current geopolitical situation, is also the data sovereignty. A lot of commercial models are based in the United States or in China. What happens if tomorrow the United States are saying, now, okay, we close all our data storage center, or we force the companies that are working with American software to get the data, to give us the data. Until a few years ago, this was not, if I was telling you this was a joke, now actually we start thinking that it could be possible. So it's very important that we have some sort of sovereignty on data, so that the data are in Europe, and that the data are encrypted and actually that belongs to us. Also the reliability. What happens when a model is hallucinating, so making up word or facts, which is even worse, and there's no people checking it? What is the legal obligation that doesn't exist, for instance, what is reference to something that doesn't exist. Then this is put into the all national laws in Europe. Or again, the accountability. Who is responsible when an artificial intelligence translated text end up in a regulation? We don't know. So all these actually discussion are missing from the vendors when they come and tell us to use LLM. That's why we want to compare the performances, but we also want to assess the scalability of these models. We want to see if they are good in all the languages and also how much they cost, because they don't come for free. You have to pay when you use their services in the cloud, and of course, we are working with people money in Europe, and we don't want to spend money or to throw money out of the window. So we would like to build AI that is under our control and with the possibility to check and to study it. That's why we set up this AI for Trad project, where we are running several experiments with use cases specific to our DigiTrad, where we want to have clear numbers about how a model is good, how much the model is good to translate a sentence. We want to have a baseline, a number. Then if there is a vendor that is coming to us and telling, oh, my large language model is beautiful, is very good, we can say, okay, good, but let's the fact talk. So here are our data, here is our framework, so we can test what you offer. But also, if universities want to do research and improve the quality of these models, we can give them the data, we can give them the tools, so we have at least we have a baseline that we can compare in each one of the 24 languages. This, when we think about giant tech companies in the United States, they don't do that. They don't care usually about our low resources languages. So we have to step in at some point. And the first experiment that we have done is to actually test the translation of legislative text, but also non-legislative text, so reports of communication in all the languages using previous translation from this Euramis database. We wanted to check because these large language models are trained on books, on the data they found on internet, on social media. So these data are actually skewed on some type of text. So the terminology is picked by from this type of conversation, and most of the time is skewed on American society, and most specifically on white American society. So when we use ChatGPT, when we use or alike, sometimes we are exposed to some sentences or words that are actually maybe not even related to Europe, but they are somehow injected into our discussion. And we fine-tune, therefore, we want to study commercial models, but also open source model, open source, open weight model, that we can study, we can look inside, they are not only black box. And we started exposing a European model, EuroLLM, 22 billion parameters. Then I think Dimitar will tell about the parameters. We fine-tune this model with our data in 23 pairs. So English to source language and the 23 other languages as a target language. And fine-tuning is like, if you think about the translators, fine-tuning is taking a translator out of the university and exposing it to our jargon inside the parliament. So they learn the terminology to use, they learn the style of writing that we use within the legislative cycle. So we did that. And we also checked the terminology quality, and we are building, since the first results were promising, we are also building a pipeline for our production where we can then use this type of models. The first experiment was promising, as I told you, while using a fine-tuned smaller model exposed to our data, was giving better results in terms of standard metrics than, let's say, at the time the frontier model from Claude was the 4.6, now it's 4.7, but it's like 2 months ago. And we had a better score of 9.27 in blue score, which is a lot, actually. We are talking about legislative text and not generic text. And that is where we exposed the model to more than 700,000 segments already translated in 23 languages. We tested 10 variants of this model. We didn't train the model at first, then we trained the model with the on the legislative text, and then we trained the model with this combination. We first exposed the model to the generic translation and then to the legislative translation. And that's what actually gave the best results. I was as well surprised at the beginning, but then we understood that most probably the first fine-tuning with the generic test enlarged the number of languages. So it helped the model to understand more languages. And then we went vertically with the legislative text, with the fine-tuning, and there where we obtained the highest actually score value. Better than the Claude Sonnet 4.6, which is the commercial model that was the best at the time. So we are going to put our project in the workflow. The results of our projects are going into the workflow. We are not just replacing our colleagues' translator. And we want to keep in mind the sovereignty of our data. So with this small model, we can actually use the model in our servers or in the Parliament server. So the data are not leaving our location. That would be very, very good for us. And we use our data, our institutional data, and we want to evaluate the open source model and commercial. But of course, with caveats that we can not transfer data to abroad. And all the data sets are released for the public to use, for the university, because indeed it's public money, and so we want the data to go back to the public. We want also to have always human in control. That's why we are putting AI in between workflow. We will suggest the AI translation to the translators, but they will be the one deciding if use it or not, the sentence. This is because the translation is AI translation is a tool for a translator. We don't want to replace them because they are actually the guarantors of quality. They are still the guarantors of quality because actually in Europe, our strength is the diversity that we bring together. And also we risk to lose this diversity if we all use the same English-based, let's say, model for generating text. And also we want to keep the evaluation of our quality experts in the loop. Because indeed, it's too important, legislative text is too important to just risk to have it wrong. And that is actually my takeaway message is that multilingualism is not a cost to optimize away just because it's actually fast if we use LLMs. As you have seen, there are many different issues and questions to be asked, and we want to investigate that. And it is a democracy infrastructure. And I mean, what a best place than Greece to talk about democracy, since it was born here, the democracies as we know it in our Europe. And AI must strengthen the democracy infrastructure, not actually replace it or damages with mistakes. And then that's it. If you want to ask me questions, I think we will have at the end of the panels. Thanks a lot.
Okay, as a follow-up, I'm Lieve Makke. I come from Ghent University. I'm assistant professor in translation technology and at the Department of Translation, Interpreting and Communication. So I teach there and I also do research there. So I'm positioned to present another perspective on the impact of large language models, especially on translation and language education. Yeah. To give a bit of context, this is a very brief overview of what we do at our department. So we train the next generation of language professionals. We have a bachelor degree, 3-year bachelor degree in applied linguistics, where all students offer or follow Dutch in combination with 1 or 2 foreign languages. And since 2 years ago, they can combine 1 foreign language and opt for language technology as well. So we're also moving forward in our curriculum. And then the students normally follow a specialized specialized master, so a degree in translation or in interpreting and in multilingual communication, or they opt to become a teacher, a language teacher. And then we have 2 postgraduate programs which are more sophisticated, one on conference interpreting and one on technology for language professionals. And in total we have among 500 students for all our programs together. To fully understand, I think, the impact of LLMs in our field, we need to look at a bit broader context or the landscape we're working in. And in fact, it's very difficult for us at this moment. I'm not familiar with the figures in Greece, but across Europe and especially in the UK, you see a systematic decline in number of students that choose to study languages. We have seen lots of petitions lately on the internet protesting budget costs and department closures even. And these are really prominent institutions like the University of Essex, University of Leicester, Harriet Watt University, University of Leiden. So I think this is a kind of alarming situation. At our department, the figures, it's not that dramatic, but although 2 years ago we had to close our Turkish department. So we had Turkish as a foreign language, we had to discontinue it because we didn't have enough students. But overall, you see the same trend. I think over the last 2 years, we lost 100 students out of the 500. We are now at 500, we had 600, so it's quite a lot. And this is, if you think about it, it's a kind of structural crisis maybe in our education system. It's what we can call the secondary education ripple effect. So if you have fewer students that opt to study languages at university level, there will be fewer university graduates, but that also means that we will have fewer trained teachers for secondary education. And this is where the story then takes a kind of paradoxal turn. So when the language departments are struggling to have enough students, there was a study of Cambridge University that said that even under very conservative assumptions. If you would invest in students learning, for instance, Arabic, Mandarin, French, or Spanish, that the return could double if you just look at economy. And the study really warns that the ongoing decline in language learning is undermining the country's ability to compete internationally. This was a study specifically for the UK. Of course, apart, and I think we should also stress this, apart from the economic value, because if you talk about LLMs, we often just only think about economic value of language. Language has much more value than just economic value. You have cognitive benefits. Language learning is, I think, an ideal form of brain training. There's lots of research that demonstrates that if you learn a second language or third language, it even has some impact on the structure of your brain. It also builds intercultural competences, meaning that you can interpret beyond the words, you can read between the lines, things that are very important, I think, if you want to do business together. And finally, language learning is also an ideal tool, especially in our very polarized world we're living right now, to reduce prejudice and to foster empathy. And then Gen AI comes in. So this is the context we're living in, and then AI enters our universities everywhere, the curricula. And I think, if you think about it, I've been in the field for a long time. Large language models really revolutionized our traditional assumptions on what machines could do with texts. I think we could have never ever imagined what's now possible 10 years ago. But I think we have to make a good evaluation. We have to look at the opportunities that are certainly there, but we also have to look at the consequences and the risks that are there. On the positive side, you have increased productivity. I think it was mentioned before, there is increased productivity. We can do things much faster than before. There are opportunities for individualized learning. Suppose you're learning languages and you can talk to an AI agent 24/7. It certainly is a benefit. In some communicative situations, it's a benefit that you have access to a tool with which you can translate. But there are also serious drawbacks. There's a perception crisis towards language professionals, the profession of translators, for instance. There are quality concerns. There's this whole productivity framing, and there's linguistic erosion. I will come back on these in more detail. So there's an increasingly negative perception of the translation profession nowadays. When we talk to prospective students, or especially to the parents of the prospective students, it's okay, but can I still have a job when I study for translation? And a colleague of mine phrased it very neatly, I think. He said, translators aren't competing with AI, they're competing with the perception that AI can take over that job. But it's just not a negative sentiment, it's really reflected also in the figures. And this is a graph that I've taken from the European Language Service, European Language Industry Survey of 2026, where they just asked independent translators, do you make enough money for your living? And it's alarming, I think, if you look at the figures. In 2023, it was still 66% that said, okay, I earn enough. Now it's only 53%, so it's really a decline. A second concern is quality. What you see below is 4 different groups. It's from the same survey, 4 different groups of participants. The first one are the language service companies, so the big companies that offer the language services. Second ones are the individual or independent professionals, the language departments then, and then the teachers. And what you see is that none of these consistently say, okay, LLMs output or automated machine translation output very high quality. I think the overwhelming color is average, it's blue, and it's also interesting to see that there is a difference in perception between the language service companies, which say, okay, the quality is much better than what the real trained professionals tell. Related to this, despite this quality or quality concerns, we are now witnessing an industry-wide race, I think, to the bottom. Very low prices, very high turnaround times. And this comes from, you can't see the reference there, but this comes from the NIMSD 100 report, which is a yearly report from the Global Language Services. And they say, okay, client behavior and expectations have changed, and especially over the last year. And buyers are demanding faster turnaround times, lower costs, and sometimes to attempt even bypassing human oversight by using raw machine translation output, even for contexts that we or everyone thought of, okay, this is not useful for MT. But they do it now anyways. But of course, an AI approach, if the quality is not good, it sometimes leads to failures. So most clients now use what they call an expert in the loop validation. And this is a graph that I've took also from this NIMSI report, and it resembles a bit what you've seen before. You have all these different kind of agents, so you first go to a neural machine translation or an LLM to translate, then you go to a terminology check, then you ensure that the style guide is okay, you have some guardrail agent, and then at the end you even have an automatic quality control that then says, okay, it's a pass or it's a fail, and you do some automatic post-editing. But I think if you look at this and you see where the human is placed, it's really put at the periphery. So it just has to intervene and audit at certain processes, but it's not at the heart of the translation process anymore. Apart from these drawbacks, there's another drawback which researchers call linguistic erosion. Large language models operate on mathematical probabilities, so they over-generate high probability words and forget low probability words, which means that in the end it reduces linguistic richness of our languages and it amplifies bias. So the bias that was mentioned before, it's in the data, and by the pure mechanisms of how LLMs works, it's amplified. So if you think of this and you take this further, this can eventually lead to model collapse. So if LLMs are trained on data that are increasingly consist of their own, then at the end, the quality will, of course, diminish. I want to come back of this picture that I used before. So we are in a situation where we have fewer language students, we have fewer university graduates, we have fewer people that then become a teacher, but it also means that we have lesser really nice linguistic expertise for oversight of these LLMs or these AI translations. And this is in fact a paradox. We need these people, but by having these LLMs and by having this whole negative perception of the translation profession, we are not training them anymore. So who will be the future people that will guard the quality? In the NIMSI report, it was already stated that human language talent is already scarce and limited for highly specialized jobs. So without high-level quality translators and language, AI models will train on lower quality data or maybe on data they have generated themselves. So I think, what do we need? I think we definitely need to counter the narrative that AI has already solved translation and really reframe the value of human language and human expertise. Another thing that definitely has to change is the way we value the expert work. So I think lots of translators are still based on a word basis, while it doesn't fit anymore the way we work now with the auditing. We definitely have to protect language departments and resist the purely economic enrollment logic. And of course, we have to focus on, as institutions, we have to focus on AI literacy and equip our students with good knowledge that they understand what they are competing with. So I think we need a more human-centric future, not only look at the pure economic value, but a future where technology serves humanity and not the other way around. And this was my perspective on LLMs.
Hi everyone. So I'll wrap up this discussion with a bit of a presentation about what is under the hood, because we all heard about the impact of LLMs in education. There was a talk yesterday as well that touched upon this. We talked about the use of LLMs in professional translation pipelines that are being used in the parliament or for the parliament use cases to translate legislative text that we all actually use as citizens of the European Union. Now let me just open a bit the box. Because you don't have a lot of time, I'm not going to stop on the details, you can ask later. So large language models are large. When I say large, you can imagine massive amounts of data that have been thrown in these models, massive amounts of neurons that are being trained and weights in between these neurons. Of course, you have smaller versions of those over there on top. These small models, they're usable for certain things, not for everything, right? You cannot just generalize, but typically the bigger, the better, right? That's one of the laws with large language models. That's one of the laws that governs ChatGPT, that governs Claude, that governs Anthropic, to actually make money and provide services. And so here on this graph, what you can see is this increase of the size of models. Here down there behind this chair is in 2018 GPT-1 with something like 100 million parameters. These parameters are actually the weights between single neurons that are connected in this massive neural net, artificial neural networks, right? And up there is the Llama 4 model, Behemoth, which was trained in 2026, I think, 2025, which has 2 trillion parameters, and that's massive. Now, if you imagine we have a lot of cells, we are also massive, and large language models are also massive in different ways. But what is also important to note is this curve, this straight line going up, with which indicates that with the increase of the size of the model, we increase also the quality. Similar curve here. These are different metrics, different comparisons, different industries that do this assessment. Now, people, when they work on large language models, have to identify laws that govern this quality so that we can actually train these models in a better way to make it better. And we have to train them on certain computers, hardware, software that we have, data centers, right? And in 2020, people from OpenAI came up with this law where they said that if you have X amount of data in terms of text, then you need 7 times more parameters or weights in the model that you're training to actually train a good model. Now, as the curve over there shows, that assumption, and despite of the empirical evidence, was kind of diminished later on. And people identify that you need much more. You need 20 times more data than parameters in the models. And nowadays we're even talking about 200 times more data than your parameters. I'll come back to this in a bit. Just to remember this number, 200 to 1. right? Because actually there is a correlation, a direct correlation between the computational power that we are using, the data that we are using to train these models, and the size of the model that we are training. And this equation actually will give us kind of the capacity of the model, the quality of the model, given certain computational resource that we have. And of course, once we put all this together, then we can see what is the impact. We can kind of estimate what's the impact on the environment, on the infrastructure that people are building, that people are investing in, on the industry and institutions, and that's kind of one part of the impact. Of course, we have also on education and other institutions. Now, there are certain complexities. At the end, what it all boils down is about size, efficiency, and reliability. Valerio mentioned about reliance and reliability earlier in the presentation, and that's important to know that all these things are quite important to take into account before we start developing models, before we start even using models. Sorry. Second. The scalability comes in terms of how much compute we have, how much hardware that is dedicated for the training and the operation of these models. Now, I'm not going to talk a lot about this, but what I want to tell you is that nowadays, what we do is we have this hardware. We have a lot of tools, we have a lot of massive data centers, but these data centers are not efficient enough. Llama 3 over there, as indicated, was trained on 16,000 specialized hardwares, specialized GPUs for training these models with an efficiency of 38 to 41%. So the rest of around 60% was not used simply because the parallelization of this training process was hard enough to actually parallelize, distribute over all the 16,000 GPUs. And with that comes also the risk of failures, right? The more you have parallel things happening, of course, the more risk of failing some things. And with this size that these models have, one small issue can have detrimental impact on the model itself, which then propagates, of course, to, hey, we have to start again, invest a lot of time, money, and so on, right? And so what is the impact when we talk about scale, when we talk about hardware, on the infrastructure that we have currently and that we have to build in the future? We need specialized compute hardware, we need specialized networking hardware, and we need specialized storage, because we're talking about massive amounts of data, we need massive amounts of computation, and we need all this information to go smoothly. And we need somebody to build this. We, in the university, we cannot do that, right? We have some desktop computers, some data centers that are enough for our research, but not to do these things. So we have big companies that do that, right? And that's another thing. And of course, with that, we have also power consumption. How much power do we need to feed all these massive language models? How much cooling do we need to cool down all these systems? Do we have the support, do we have the monitoring systems that actually tell us whether something is reliable, whether something scales properly, whether something is going to succeed, or we'll have to restart it in training after 2 months, for example. And that's one of the big impacts that we have. The other one, as Professor Martin mentioned, is related to data as well. Well, what happens is that nowadays all this AI that we talk about is based on data. We no longer feed it with rules, like if this is true, then that is true, derive that, and so on. Now we feed it with data, and we ask AI models, neural models, to actually extract all this information and infer all this knowledge. We have massive amounts of data. Over there is a scale of, again, in tera, how to say, trillion of tokens. Tokens are words or sub-word units that are used to feed as input to these models. Yes, we have 20 trillion there, I think, or 18 trillion tokens that have been used for Qwen 2.5. 20 trillion have been used for Llama, right? 20 trillion words, you can imagine. That's a massive amount of data. There are not so many stars in our universe. well, sorry, not stars. For stars, we do have galaxies. But what happens with the data? Data comes in all kind of flavors, right? It's good data, bad data, because you have all this slop on the internet, and that messes up a lot of things. Leads to bad quality if we throw in everything into the models. So people try to optimize this thing. But when we optimize and when we use models and when we reuse models and when we feed data and when we take data, we run into a risk that in 2028 to 2030, we run out of clean data that we can use to train new, better models. Okay? So what do we do then? Well, that's a question that we have to research, we have to answer later on. And basically, that's another impact, the impact on the data itself that we have used to actually train these models. And the final point that I want to make is that these models, the training and the inference of these models consumes an immense amount of power, of energy, which we need to produce, we need to generate in order to feed these models, to sustain these models. And that, well, it can be detrimental to environment, detrimental to indigenous societies as well, because we place the center somewhere where, well, we have certain resources, right? And of course, all this leads to money, right? How much money does it cost to train these models, to sustain these models? Over there, Gemini Ultra and Llama 3.1, it's in millions, not in only in millions, in hundreds of millions of dollars. So you can imagine it's a big industry. And that has an impact on us, the universities. We don't have this money, right? And we don't have the resources to do that. So we have to do something else to actually work. Anyway, so these are the impacts that I wanted to address, and the takeaways are the following. Scale is progressing, so we still keep on training bigger models. We, the people that can do that. Data stocks will be exhausted, so we need to think about inventive ways to do that, to train new, better models. And we are putting a lot of power and a lot of energy and a lot of resources in training AI models. For better or for worse, that's the situation, that's what we have at the moment, and we have to think about the future towards a sustainable future. So that was it in a nutshell. Thank you very much. That's it? Okay. Should I? No question. Okay.
No questions at the session. They're going to room after that. Let's have a picture.
Outh Radio, η φωνή της γνώσης.
What is love anyway? But a fire that burns too close. I gave my heart to the flame, and it turned me into smoke. You said forever. I heard good.
Συνέντευξης τύπου έχει να κάνει με το φοιτητικό βαρόμετρο. Όπως ανέφερα σε ένα φόρουμ καινοτομίας, το οποίο είναι μια υπόσχεση για το μέλλον και το οποίο έχει ως επίκεντρο τη νέα γενιά, δεν θα μπορούσε παρά να είναι ενταγμένη και μια ανακοίνωση των αποτελεσμάτων του κυλιόμενου φοιτητικού βαρόμετρου, το οποίο καθιερώσαμε αυτή την ακαδημαϊκή χρονιά, όσον αφορά κυρίως τα αποτελέσματα της γενιάς των φοιτητών μας, της Gen Z. Πολύ νέος είχα διαβάσει μια φράση η οποία με εντυπωσίασε και τα τελευταία χρόνια μάλιστα την ακούω σε διάφορες παραλλαγές και γίνεται όλο και πιο δημοφιλής. Είναι ένας επιχειρηματίας, ο Μπαρούχ, ο οποίος είπε ότι κάθε άνθρωπος έχει δικαίωμα στην άποψή του, αλλά κανένας δεν δικαιούται να κάνει λάθος στα γεγονότα και να παρουσιάζει τα δικά του λανθασμένα δεδομένα. Αυτό λοιπόν που ξεκινήσαμε ως AU Student Barometer, που στην ουσία είναι κάτι που από ιδρύσεως των ελληνικών πανεπιστημίων δεν είχε γίνει, δεν είχε σκεφτεί κανένας να διαγνώσει τις απόψεις, τις σκέψεις, τις επιθυμίες και τις τάσεις του φοιτητικού κόσμου, μας δίνει πραγματικά δεδομένα για τις γενιές με στοιχεία. Θεωρούμε λοιπόν ότι τόσο το Αριστοτέλειο όσο και το σύνολο των πανεπιστημίων μας δεν μπορεί να έχει μια στρατηγική χωρίς να είναι πραγματιστική και τελικά πετυχημένη, στηριζόμενη στις αντιλήψεις, στις ανάγκες των φοιτητών και των φοιτητριών μας. Και όπως ξέρετε, αυτοί οι φοιτητές οι οποίες εκφράζουν την άποψή τους με το φοιτητικό βαρόμετρο, μας δίνουν στοιχεία. Τα τελευταία θα τα παρουσιάσουμε αυτής της εβδομάδας. Αυτής της εβδομάδας είναι το Gallup, θα τα παρουσιάσουμε σήμερα. Αυτή τη φορά προσθέσαμε σε αυτά τα οποία έχετε μέχρι τώρα ακούσει και νέα ερωτήματα. Οπότε έχουμε και νέες απαντήσεις και θα στοιχειοθετήσω ένα-δυο πολύ ενδιαφέροντα. Μόλις το 1/3 των φοιτητών μας χρησιμοποιεί συστηματικά εργαλεία AI, 27%. Ομολογώ ότι και εγώ θα περίμενα μεγαλύτερα νούμερα για την Gen Z, η οποία στην ουσία είναι ο κόσμος μας αυτή τη στιγμή. Στην ερώτηση τι θα ήθελες να σου παρέχει το Πανεπιστήμιο σχετικά με την τεχνητή νοημοσύνη, η εικόνα αλλάζει. Το 40% των νέων ζητάει εργαλεία AI στην εκπαιδευτική διαδικασία. Το 1/3 θέλει μαθήματα και workshops για τη χρήση AI εργαλείων και το εντυπωσιακό 54% ζητά καθοδήγηση και την υπεύθυνη χρήση της. Από τα διεθνή δεδομένα φαίνεται ότι η Gen Z βλέπει την τεχνητή νοημοσύνη ως βοηθό, ενώ η Gen Α που έρχεται την αντιλαμβάνεται ως το ίδιο το περιβάλλον της. Για να το κάνω πιο απλό, οι σημερινοί νέοι σε όλο τον κόσμο δεν θα πούν ότι χρησιμοποιούν AI, αλλά τη σκέφτονται ως βασική λειτουργία των υπολογιστών. Γίνεται δηλαδή σταδιακά η φυσική του συνθήκη. Πώς στεκόμαστε εμείς απέναντι σε αυτές τις τάσεις? Σίγουρα πάντως όχι όπως βλέπετε με σταυρωμένα χέρια. Και δεν εννοούμε ότι βάζουμε τον πύχη έτσι στο ύψος της Νότιας Κορέας, όπου η χρήση AI μεταξύ των φοιτητών ξεπερνάει το 90%, αλλά στις βορειοδυτικές χώρες, όπου τα αντίστοιχα ποσοστά μεταξύ χρηστών ξεπερνούν το 60%. Φυσικά δεν είμαι εγώ αυτός ο οποίος θα μιλήσει για την ανάλυση της έρευνας για την τεχνητή νοημοσύνη. Επειδή όμως έχουμε πάρα πολλά ενδιαφέροντα αποτελέσματα και ήδη έχουμε ξεπεράσει τον χρόνο, παρότι ήθελα να πω κάποια περισσότερα, ο κύριος Πασχάλης Τεμεκενίδης από την Παλμός Ανάλυσης ας μας παρουσιάσει πρώτα τα αποτελέσματα και ίσως έχουμε λίγο χρόνο να τα σχολιάσουμε. Κύριε Τεμεκενίδη.
Κύριε Πρέδρε, σας ευχαριστώ πάρα πολύ. Να πούμε επιγραμματικά ότι αυτό είναι το δεύτερο κύμα του φοιτητικού βαρόμετρου του Αριστοτελείου Πανεπιστημίου Θεσσαλονίκης. Το πρώτο θυμίζω ότι έτρεξε το Δεκέμβριο, άρα αυτό είναι ένα εξάμηνο μετά, είναι το δεύτερο κύμα. Θα πω εδώ ότι εδώ θα δείτε ένα εξαιρετικά μικρό μέρος από τα αποτελέσματα που έχουμε και από τα ευρήματα που έχουμε, γιατί προφανώς είναι αδύνατο να τα παρουσιάσουμε όλα σε μια τέτοια συνέντευξη τύπου, άρα θα δώσουμε ουσιαστικά βάρος στα νέα ερωτήματα, σε αυτά που προσθέθηκαν εν ώψη αυτού του κύματος, προφανώς έχοντας και κατά νου ότι εδώ είναι ένα φόρουμ καινοτομίας, άρα λοιπόν θα θέλαμε να δούμε και τέτοια ζητήματα. Να πω δύο λόγια για την ταυτότητα της έρευνας. Σε αυτό το κύμα έχουν συμμετάσχει 1686 φοιτητές και φοιτήτριες. Θέλω να πω ότι είναι κάτι το οποίο τελείωσε χθες, είναι δηλαδή εξαιρετικά πρόσφατα αυτά τα αποτελέσματα. Χθες τελείωσε η δειγματοληψία. Να ευχαριστήσουμε όλους αυτούς τους φοιτητές που συμμετέχουν και μας δίνουν κάθε φορά τη γνώμη τους, απαντώντας σε ένα πολύ εκτενές ερωτηματολόγιο, είναι η αλήθεια, ξοδεύοντας δηλαδή και επενδύοντας χρόνο. Και πάμε να δούμε μερικά ενδεικτικά αποτελέσματα για να μην σας τρώω χρόνο. Καταρχάς, να πούμε ότι το Πανεπιστήμιο φιλοξενεί στους κόλπους του, στον φοιτητικό του πληθυσμό, φιλοξενεί στην πραγματικότητα 3 γενιές. Φιλοξενεί το αυτό που λέμε Generation Z, αυτούς δηλαδή οι οποίοι γεννήθηκαν από το 1997 και μετά, και είναι ο κύριος όγκος, όπως βλέπετε εκεί στο πληθυσμός έρευνας, είναι το 72% ουσιαστικά του φοιτητικού πληθυσμού, είναι περίπου 3 στους 4, είναι σε αυτή τη γενιά, είναι ο κύριος όγκος, αλλά υπάρχουν millennials, υπάρχουν άνθρωποι δηλαδή οι οποίοι έχουν γεννηθεί μεταξύ 81 και 96 και υπάρχουν και εκπρόσωποι της προηγούμενης γενιάς, αυτήν στην οποία έχω και τη χαρά να ανήκω, από το 65 στο 80 γεννημένοι, είναι περίπου ένα 11%. Είναι προφανώς άνθρωποι οι οποίοι κάθε γενιά κάνει διαφορετικά πράγματα μέσα στο πανεπιστήμιο. Πολλοί κάνουν μεταπτυχιακά προγράμματα για επαγγελματικούς λόγους, μεγαλύτερης ηλικίας, διδακτορικά. Άρα λοιπόν έχει ενδιαφέρον και αυτό που ουσιαστικά κάναμε εδώ, σαν μια πρώτη ανάλυση. Θυμίζω ότι χθες έκλεισε η έρευνα, άρα έχουμε μπροστά μας πολλή επεξεργασία ακόμα. Κάναμε μια πρώτη ανάλυση στο αν υπάρχουν διαγενειακές διαφορές. Και θα δούμε ότι υπάρχουν πολύ σημαντικές διαγενειακές διαφορές και φανταστείτε ότι εδώ δεν είναι το Generation A. Το Generation A είναι οι άνθρωποι οι οποίοι αυτή τη στιγμή βρίσκονται στα σχολεία ακόμα και εκεί πολύ σωστά είπε ο κ. Πρίτανης ότι η σχέση τους με την τεχνητή νοημοσύνη είναι μια σχέση μιας απόλυτης ένταξης μέσα στην καθημερινότητά τους. Στην πραγματικότητα δεν θεωρούν ότι είναι κάτι διαφορετικό από την τεχνολογία. Τεχνολογία, πληροφορική, η τεχνητή νοημοσύνη είναι κάτι ενιαίο σε εκείνη τη γενιά. Οι διαφοροποιήσεις έρχονται στους μεγαλύτερους. Να ξεκινήσουμε λοιπόν μερικά ενδεικτικά αποτελέσματα. Θέλησαμε να ρωτήσουμε ποιοι τρόποι μάθησης βοηθούν περισσότερο, σας βοηθούν περισσότερο. Και βλέπουμε ότι στην πραγματικότητα οι δύο δημοφιλέστερες απαντήσεις, εδώ είχαν τη δυνατότητα να δώσουν μέχρι 2 επιλογές από αυτές, είναι η κλασική προσέγγιση διδασκαλίας. Δηλαδή, κλασική διδασκαλία με παραδόσεις μαθημάτων και εργαστήρια και οπτικό υλικό, βίντεο, παρουσιάσεις, infographics, κάτι που έχει υιοθετηθεί εδώ και χρόνια, δεν είναι κάτι καινούριο αυτό. Βλέπουμε λοιπόν ότι αυτές οι πολύ κλασικές μέθοδοι είναι αυτή τη στιγμή πιο δημοφιλείς. Αυτό ενδεχομένως δείχνει και μια μικρή, αν θέλετε, εξοικείωση με τις πιο καινούριες τάσεις που αναπτύσσονται, όπως για παράδειγμα οι εφαρμογές, οι προσομοιώσεις, το gamified learning, αυτό βλέπετε είναι στο 28%, διαδραστικά ψηφιακά εργαλεία στο 26%. Άρα λοιπόν εδώ βλέπουμε μια υστέρηση ακόμα, δεν έχουν μπει ακόμα οι φοιτητές σε αυτή τη διαδικασία να θεωρούν ότι αυτά είναι πολύ δημοφιλή. Μια πρώτη εικόνα για τη διαφορά των γενεών, για τις διαγενειακές διαφορές. Βλέπετε ότι, για παράδειγμα, το gamified learning, οι εφαρμογές προσομοιώσεις, πολύ πιο δημοφιλείς στη νέα γενιά, στους Gen Z, σε σχέση όσο πηγαίνουμε στην πιο πίσω γενιά, στις παλιότερες γενιές αυτό το ποσοστό πέφτει. Αντιθέτως, τα διαδραστικά ψηφιακά εργαλεία είναι πιο δημοφιλή όσο πηγαίνουμε πίσω στις γενιές, το οποίο είναι αρκετά αξιοσημείωτο. Είναι δηλαδή εργαλεία στα οποία οι μεγαλύτερες ηλικία έχουν ήδη εξοικειωθεί. Ενώ βλέπετε ότι οι γενιές που έρχονται προτιμούν κάτι ακόμα πιο αιχμής σε σχέση με αυτήν την επιλογή. Πόσο σημαντικό είναι για σένα καθένα από τα παρακάτω. Θέλω να κρατήσουμε αυτά που έχω βάλει σε κόκκινο πλαίσιο. Σαφής και απλή πρόσβαση στην πληροφορία, 67%, πολύ σημαντικό. Σύνδεση θεωρίας με πράξη, 74%, πολύ σημαντικό. Και ουσιαστικά πάλι μιλάμε για την κλασική προσέγγιση στην εκπαιδευτική διαδικασία. Αυτά πάλι επιβεβαιώνονται και εδώ, αναδεικνύονται πολύ πιο ψηλά σε σχέση με πιο καινοτόμα πράγματα, όπως οι διαδραστικά μαθήματα, όπου εκεί βλέπετε ότι το πολύ πέφτει στο 46% ή το ψηφιακά εργαλεία που εξοικονομούν χρόνο 49%. Και μάλιστα, αν θέλετε να δείτε εκεί κάτω, μου επιτρέπετε να πλησιάσω, όσο πηγαίνουμε στις παλιότερες γενιές, πηγαίνουμε στους millennials και στις Gen X, μεγαλύτερης ηλικίας, εκεί προφανώς κάνει κλικ το που εξοικονομούν χρόνο. Γιατί ακριβώς είναι άνθρωποι οι οποίοι κάνουν σπουδές παράλληλα με οικογένεια, παράλληλα με δουλειά, παράλληλα με άλλα πράγματα. Άρα λοιπόν το να έχουν εργαλεία που εξοικονομούν χρόνο, βλέπετε πόσο ανεβαίνει εκεί, φτάνει στο 58% στην Generation X. Ποια από τις παρακάτω φράσεις θα έλεγες ότι σε εκφράζει περισσότερο και νομίζω ότι αυτή είναι η πιο σημαντική κάρτα όλων των αποτελεσμάτων που βλέπουμε σήμερα. Χρησιμοποιώ εργαλεία AI περιστασιακά, το 43%. Χρησιμοποιώ εργαλεία AI συστηματικά, το 27%. Αθροιστικά λοιπόν, 7 στους 10 χρησιμοποιούν. Αλλά έχει σημασία και η ένταση με την οποία χρησιμοποιούν. Και η ένταση είναι χαμηλή. Μόνο το 27% χρησιμοποιεί συστηματικά στην καθημερινότητά του, στην εκπαιδευτική διαδικασία, στην εργασία του, χρησιμοποιεί συστηματικά εργαλεία τεχνητής νοημοσύνης, ένα σεμνό ποσοστό σε σχέση με αυτά που αναφέρθηκε ο κ. Πίτανης πριν σε άλλες χώρες. Προσέξτε επίσης ότι αν αθροίσουμε, το με προβληματίζει η τεχνητή νοημοσύνη, δεν την εμπιστεύομαι. Με ενδιαφέρουν τα εργαλεία, αλλά δεν γνωρίζω πώς να τα χρησιμοποιώ σωστά. Και δεν χρησιμοποιώ εργαλεία τελείως. Αν αθροίσουμε αυτά τα ποσοστά, βλέπουμε ότι περίπου 1 στους 4, περισσότερο από 1 στους 4, είναι το 27%. Στην πραγματικότητα έχουν μία είτε αποστασιοποίηση από την τεχνητή νοημοσύνη, είτε και ένα φόβο χρήσης. Άρα λοιπόν και μιλάμε για ένα κομμάτι του πληθυσμού. Αυτό δεν είναι γενικός πληθυσμός. Αυτός είναι ο φοιτητικός πληθυσμός του μεγαλύτερου πανεπιστημίου της χώρας. Άρα λοιπόν εδώ μιλάμε για έναν πληθυσμό ψηλής μορφωτικής στάθμης. Το ότι ο 1 στους 4 έχει τέτοιου είδους θέματα με την τεχνητή νοημοσύνη είναι κάτι νομίζω που θα πρέπει να το δούμε και θα πρέπει να το αξιολογήσουμε. Τι ζητάμε από το Πανεπιστήμιο λοιπόν? Φτάνουμε στο ερώτημα τι θα θέλατε λοιπόν να σας παρέχει το Πανεπιστήμιο σε σχέση με την τεχνητή νοημοσύνη. Καθοδήγηση για υπεύθυνη χρήση της τεχνητής νοημοσύνης, δημοφιλέστερη απάντηση με 54% και εδώ έχουμε 2 επιλογές από τις 4. Είχαν δυνατότητα λένε, να διαλέξουν τα 2 πιο κρίσιμα κατά τη γνώμη τους και τα 2 πιο κρίσιμα είναι η υπεύθυνη χρήση, η καθοδήγηση για το πώς να το χρησιμοποιώ σωστά και εργαλεία τεχνητής νοημοσύνης για μάθηση. Αυτές είναι οι πιο δημοφιλείς απαντήσεις. Από εκεί πέρα έχουμε μαθήματα και workshop για τεχνητή νοημοσύνη, σαφείς κανόνες χρήσης τεχνητής νοημοσύνης. Δείτε το τελευταίο, το σαφείς κανόνες χρήσης τεχνητής νοημοσύνης, ανεβαίνει ως επιλογή όσο πηγαίνουμε στις παλιότερες γενιές. Στην πραγματικότητα, όσο πηγαίνουμε στους νεότερους και είμαι σίγουρος ότι όταν αυτή η έρευνα θα πάει στο Gen A, όταν θα μπορούμε να τους μετρήσουμε και αυτούς θα δούμε εκεί θα είναι ακόμα χαμηλότερο, γιατί ακριβώς όταν κάτι είναι ενσωματωμένο στην καθημερινότητά σου, το χρησιμοποιείς συχνά, δεν έχει στην πραγματικότητα τόσους προβληματισμούς για το δεοντολογικό και ηθικό της υπόθεσης. Γιατί θεωρείται ότι είναι μέρος της ζωής σου, άρα λοιπόν δεν έχεις κάτι τέτοιο. Και πλέον, το λέγαμε και πριν, δεν έχεις δει ενδεχομένως Terminator όταν είσαι τόσο νέος, οπότε δεν έχεις τέτοιους φόβους και δεν έχεις τέτοιες ανησυχίες. Διάφορες προτάσεις εδώ. Εδώ υπάρχουν και ανησυχητικά πράγματα, αν θέλετε τη γνώμη μου, αλλά αυτή είναι μια προσωπική γνώμη, ο καθένας μπορεί να κάνει τη δική του ανάγνωση. Νιώθω συνεχώς συνδεδεμένη, νιώθω ότι είμαι συνεχώς online. Το αθροιστικό ποσοστό, οι μπλε μπάρες, είναι 68%. 7 στους 10 λένε ότι νιώθω ότι είμαι συνεχώς συνδεδεμένος, είμαι συνεχώς διαθέσιμος διαδικτυακά. Δυσκολεύομαι να αποσπαστώ από οθόνες. Νόμιζα ότι αυτό το πρόβλημα το έχουμε μόνο εμείς που έχουμε ανήλικα παιδιά στο δημοτικό, αλλά από ό,τι βλέπω το έχουν και άνθρωποι οι οποίοι είναι σε πολύ μεγαλύτερη ηλικία και σε άλλο εκπαιδευτικό επίπεδο. Αν αθροίσουμε τις μπλε μπάρες εδώ, το 47%, η μισή δηλαδή, έτσι, για να είμαστε πιο απλοί, λένε ότι δυσκολεύονται να πάρουν τα μάτια τους πάνω από μια οθόνη. Είναι συνεχώς μπροστά σε μια οθόνη, έχουν το νου τους συνεχώς σε μια οθόνη. Η ψηφιακή καθημερινότητα επηρεάζει τη συγκέντρωσή μου, 72%. Χρειάζομαι καλύτερη ισορροπία online και offline ζωής και χρόνου. Πόσο? 58%. Μεγάλα ποσοστά. Δηλαδή μια γενικότερη παραδοχή ότι πλέον η επαφή με τον ψηφιακό κόσμο έχει και παρενέργειες. Ουσιαστικά αυτή είναι η εικόνα που προκύπτει από εδώ. Και βέβαια, ακριβώς επειδή συμβαίνουν αυτά, ένα ψηλό ποσοστό, 44%, μας δηλώνει ότι συμφωνεί ότι το Πανεπιστήμιο μπορεί να βοηθήσει τη διαχείριση χρόνου και προσοχή συγκέντρωση. Να λοιπόν άλλο ένα πεδίο που το Πανεπιστήμιο μπορεί να συνδράμει στους φοιτητές του, στους ανθρώπους του, στον πληθυσμό. Ουσιαστικά είναι ένα αίτημα βοήθειας εδώ, προκειμένου να διαχειριστούν καλύτερα όλα αυτά τα προβλήματα τα οποία μας αναφέρουν ακριβώς από πάνω. Υπάρχουν διαφορές. Ναι, υπάρχουν πολύ μεγάλες διαφορές και κοιτάξτε εδώ την αντίφαση, γιατί είναι μια αντίφαση, ενώ οι νεότεροι, το Generation Z, αναφέρουν σε πολύ ψηλότερα ποσοστά απόλυτη συμφωνία με τους προβληματισμούς, δηλαδή με το αν είναι συνεχώς συνδεδεμένοι, με το αν δυσκολεύονται να αποσπαστούν από οθόνες, αν η καθημερινότητά τους η ψηφιακή έχει επηρεάσει τη συγκέντρωσή τους, ακόμα αν χρειάζονται καλύτερη ισορροπία online και offline χρόνου και της ζωής. Όταν έρχεται η ώρα να αξιολογήσουν αν το Πανεπιστήμιο μπορεί να τους βοηθήσει κτλ. Και βλέπετε ότι το ζητάνε σε μικρότερο βαθμό, γιατί ακριβώς θεωρούν ότι αυτή είναι ενδεχομένως ένας φυσιολογικός πλέον τρόπος ζωής. Ναι, αναγνωρίζουν περισσότερο αυτές τις καταστάσεις. Έχω την αίσθηση όμως, αν το διαβάσουμε συνδυαστικά, ότι δεν το βλέπουν τόσο πολύ ως πρόβλημα στο οποίο να χρειάζονται βοήθεια, γιατί ακριβώς έχει ενσωματωθεί όλο και περισσότερο και θα το δούμε αυτό στις επόμενες γενιές που έρχονται από πίσω. Πάμε σε λίγο πιο γενικά ερωτήματα για τη σχέση τους με το πανεπιστήμιο. Καινούργια ερωτήματα, αυτά τα θέσαμε για πρώτη φορά σε αυτό το κύμα. Τι θα σε βοηθούσε να νιώσεις περισσότερο μέρος της κοινότητας και του πανεπιστημίου? Φοιτητικές ομάδες και κοινότητες, κοινωνικοποίηση 52%, πολιτιστικές δραστηριότητες 44%. Ουσιαστικά βλέπετε ότι δεν υπάρχουν μεγάλες διαφορές. Θεωρούν ότι είναι μια βεντάλια δράσεων που θα τους βοηθούσε. Άρα λοιπόν δεν έχουμε κάτι ιδιαίτερο εδώ πέρα. Θα ήθελα να σταθώ λίγο όμως. Υπάρχουν προφανώς διαγενειακές διαφορές και τις βλέπουμε εκεί πολύ εντυπωσιακά. Αλλά κρατήστε λίγο το δράσεις γνωριμίας. Γιατί προφανώς, ανάλογα με τη γενιά, το αντιμετωπίζεις αλλιώς. Γιατί οι δράσεις γνωριμίας ανεβαίνουν όσο πάμε στις παλιότερες γενιές? Γιατί εκεί υπάρχουν άνθρωποι οι οποίοι κάνουν μεταπτυχιακά για επαγγελματικούς λόγους. Εκεί οι δράσεις γνωριμίας έχουν τη διάσταση της επαγγελματικής δικτύωσης. Γι' αυτόν τον λόγο και βλέπετε ότι εκεί τα ποσοστά, όσο ανεβαίνουμε στην ηλικιακή βαθμίδα, όσο πηγαίνουμε δηλαδή στις παλιότερες γενιές, αυτό το ποσοστό αυξάνεται. Πρέπει να το σημειώσουμε αυτό, γιατί είναι μια ανάγκη τους. Είναι και αυτή, και είναι και ένας και από τους λόγους που πολλοί άνθρωποι συμμετέχουν σε τέτοια προγράμματα, η επαγγελματική δικτύωση μέσα από τη συμμετοχή σε ένα τέτοιο πρόγραμμα. Πάμε σε κάτι το οποίο νομίζω θα πρέπει να κάνει και τη διοίκηση χαρούμενη, γιατί είναι μια επιλογή της. Ποια από τα παρακάτω θεωρείς ότι θα ενίσχυαν την εμπιστοσύνη στο πανεπιστήμιο? Και με μεγάλη διαφορά, η πρώτη επιλογή είναι να ακούει τους φοιτητές. Και αν μη τι άλλο, αυτή είναι μια δραστηριότητα που αυτό επιδιώκει να κάνει, να έρθει το Πανεπιστήμιο πιο κοντά στους φοιτητές, να καταγράψει με ένα συστηματοποιημένο τρόπο τις απόψεις τους και τους προβληματισμούς τους και προφανώς να χαράξει τις δικές του πολιτικές από εκεί και μετά. Αυτό βλέπετε ότι είναι η ανάγκη αυτή είναι πολύ ψηλότερη στους νεότερους. Δηλαδή στο Gen Z φτάνει το 76%, είναι πολύ ψηλότερα, είναι 10 μονάδες πάνω από τους Millennial, 16 μονάδες πάνω από το Generation X και ουσιαστικά εκεί που βλέπουμε μια μεγαλύτερη δυσπιστία, και αυτό μου έκανε επίσης εντύπωση, είναι ότι στις παλιότερες γενιές έχουμε πολύ ψηλότερα ποσοστά στο να επικοινωνεί με ειλικρίνεια. Βλέπουμε δηλαδή ότι οι άνθρωποι μεγαλύτερης ηλικίας, άνθρωποι δηλαδή που έχουν περάσει πλέον τα 30, είναι πιο δύσπιστοι. Θεωρούν δηλαδή ότι είναι κάτι που ενδεχομένως δεν συμβαίνει, το να αντιμετωπίζονται με ειλικρίνεια στην επικοινωνία από τους φορείς εμπροκειμένου από το πανεπιστήμιο. Και αυτό είναι αρκετά εντυπωσιακό. Οι νεότεροι άνθρωποι δεν έχουν τόσο έντονα αυτήν εδώ την εν πάση περιπτώσει, αμφιβολία. Πηγαίνουμε προς το τέλος, και εδώ έχει μερικά εντυπωσιακά πράγματα. Πόσο σημαντικό είναι καθένα το παρακάτω για σένα? Λέγαμε ότι το βαρόμετρο χρησιμοποιείται εκτός από το να δούμε τις εκπαιδευτικές τους ανάγκες, να κάνουμε και ένα ψυχογράφημα, να δούμε δηλαδή τι άλλες ανάγκες έχουν οι άνθρωποι και σε προσωπικό επίπεδο. Εδώ βλέπετε ότι τα δύο πιο σημαντικά πράγματα είναι η ψυχική υγεία, την επιλέγει το 82%, λέει ότι είναι πολύ σημαντικό, του δίνει το 5, του δίνει τον απόλυτο βαθμό, και η ποιότητα ζωής. Άρα λοιπόν αυτά τα δύο φαίνεται ότι βρίσκονται σε ψηλότερο επίπεδο από ότι για παράδειγμα η προσωπική και η οικονομική ασφάλεια, τα οποία είναι πιο χαμηλά. Θα περίμενε κάποιος να είναι πιο ψηλά, αλλά βλέπουμε ότι αυτά τα δύο, η ψυχική υγεία, η ποιότητα ζωής, είναι πιο ψηλά. Και να δούμε λίγο κάτι στο διαγενειακό, που μου έκανε επίσης τρομερή εντύπωση, είναι ότι στους νέους αυτού του είδους οι προβληματισμοί είναι πιο ήπιοι. Μου κάνει τρομερή εντύπωση, για παράδειγμα, ότι πηγαίνοντας στο Generation X, η κλιματική αλλαγή θεωρείται πολύ σημαντικό από το 51%. Θα περίμενε κανείς οι νέες γενιές να ανησυχούν περισσότερο για την κλιματική αλλαγή, γιατί τους αφορά πολύ περισσότερο. Είναι προφανές ότι αυτοί θα υποστούν σε μεγαλύτερο βαθμό τις όποιες συνέπειες προϊόντος του χρόνου. Δεν το βλέπω να συμβαίνει. Βλέπω ότι η αντίστοιχη απάντηση στη Gen Z είναι 36%, στους Millennials είναι 35%, στη Generation X, δηλαδή στους αρκετά παλιότερους πλέον, σε αυτούς που είναι ενδεχομένως γύρω στα 60%, εκεί φτάνει το 51%, δηλαδή οι παλιότεροι ανησυχούν περισσότερο από ό,τι ανησυχούν νεότεροι άνθρωποι. Τέλος, ποια από τα παρακάτω θεωρείς πιο σημαντικά για το μέλλον σου? Προσωπική εξέλιξη, το 73% η κορυφαία απάντηση. Θέλω λίγο να κρατήσουμε αυτό το κοινωνική αναγνώριση 12%. Είναι εξαιρετικά χαμηλό, μου κάνει τρομερή εντύπωση το πώς πλέον η ανάγκη για κοινωνική αναγνώριση, και πίσω από την κοινωνική αναγνώριση να βάλουμε σταδιοδρομία, να βάλουμε ανέλυξη σε αξιώματα, το βλέπετε ότι είναι εξαιρετικά χαμηλά. Προφανώς, πράγματα όπως η δημιουργικότητα και η σταθερότητα το καταλαβαίνω ως αξίες για τους νέους ανθρώπους. Κοιτάξτε πίσω, το υψηλό εισόδημα δεν είναι πλέον κυρίαρχο. Δεν είναι αυτό το οποίο ονειρεύονται οι άνθρωποι σε αυτήν την ηλικία. Ναι, έχει ένα ισχυρό 45%, δεν είναι κυρίαρχο όμως. Άρα λοιπόν έχουμε και μια γενιά που έρχεται από πίσω με άλλες αξίες. Και αυτό μπορούμε να το δούμε και στις διαγενειακές διαφορές. Βλέπουμε δηλαδή πόσο διαφορετικές είναι οι νέες γενιές, αυτό που έρχεται σε σχέση με αυτό που σιγά σιγά αποχωρεί και θα αποχωρεί στη συνέχεια και από το πανεπιστήμιο. Τελευταία ερώτηση, για να μην σας κουράσω. Έχουμε 3 προτάσεις. Πόσο συμφωνείς ή διαφωνείς με τα παρακάτω. Θέλω περισσότερες ευκαιρίες για να εκφράσω την προσωπικότητα και τις ιδιαίτερες κλίσεις μας. 65% συμφωνούν, 2 στους 3. Αυξημένο ποσοστό. Θέλω το πανεπιστήμιό μου να είναι ανοιχτό σε όλες τις διαφορετικές προσωπικότητες και προτιμήσεις, ακόμα και όταν δεν συμφωνώ μαζί τους. Έρχεται μια έκπληξη στην τελευταία κάρτα. Θέλω να επιβραβεύεται η εργατικότητα και η ανώτερη επίδοση. 84% μαζικό. Αλλά συνδυάστε το πριν με την κοινωνική ανέλυξη που λέγαμε. Θέλω να επιβραβεύεται η εργατικότητα και η ανώτερη επίδοση. Η αριστεία, η δουλειά. Κοιτάξτε, στους πιο νέους ανθρώπους είναι 55%. Είναι σχεδόν 20 μονάδες πίσω από τις προηγούμενες γενιές. Πόσο λοιπόν έχουμε μία γενιά η οποία φαίνεται, έτσι ψηλαφώντας, ότι δεν καίγεται τόσο πολύ για την καταξίωση, δεν καίγεται τόσο πολύ για την αριστεία, έχει άλλα πράγματα τα οποία είναι έξω από αυτό που είχαμε συνηθίσει εμείς που είμαστε στις προηγούμενες γενιές. Και με αυτό το σχόλιο, γιατί νομίζω ότι αυτό είναι από τα πολύ εντυπωσιακά ευρήματα στο πόσο διαφορετικά σκέφτονται άνθρωποι στον ίδιο οργανισμό, αλλά που ανήκουν σε διαφορετικές γενιές, θα κλείσουμε. Αυτά ήταν τα αποτελέσματα σε μία περίληψη. Προφανώς υπάρχουν πολύ πιο αναλυτικά δεδομένα, τα οποία είναι στη διάθεση της διοίκησης και του Πανεπιστημίου για να σχεδιάσει τις δράσεις του. Ευχαριστώ πολύ.
Ευχαριστούμε τον κύριο Τεμεκενίδη. Είδατε ότι υπάρχουν πολλά ενδιαφέροντα. Ένα σχόλιο από τους 3 αντιπριτάνης και στη συνέχεια θα κάνετε κάποιες ερωτήσεις, κρατώντας το χρόνο, για να δούμε αν θα βγουν τα συμπεράσματα που θέλουμε. Κύριε Ρέκανε.
Ευχαριστώ πολύ. Πράγματι, πολύ ενδιαφέροντα αποτελέσματα. Ένα σημείο το οποίο μου προκάλεσε έκπληξη είναι η σχέση των φοιτητών με τις μεθόδους διδασκαλίας. Εκεί διαπιστώνω ένα συντηρητισμό, δεν περίμενα να μην θέλουν νέα εργαλεία. Στην τελευταία διαφάνεια επίσης με έκανε εντύπωση το γεγονός ότι ενδιαφέρονται την προσωπική τους εξέλιξη αλλά και την κοινωνική αναγνώριση, μια άλλη έκδοση ενός ατομικισμού. Το ευχάριστο είναι ότι τους ενδιαφέρουν οι φοιτητικές ομάδες, που σημαίνει ότι μάλλον έχουν καταλάβει το νόημα του τρόπου, τον τρόπο με τον οποίο γίνεται η σύγχρονη έρευνα και ο τρόπος εργασίας, ότι πρέπει να συμμετέχουν πολλοί για να πετύχουν έναν κοινό στόχο.
Κύριος Μαγιώρος.
Κύριε Τεμεκενίδη, μας δώσατε πολύ υλικό για μελέτη. Και με αυτά τα λίγα που είδαμε, ενδεχομένως κάποια στερεότυπα ή κάποιες απόψεις που είχαμε μέχρι στιγμής ενδεχομένως να αντραπούν. Πράγμα που σημαίνει ότι χρειαζόμαστε συγκεκριμένη μελέτη ώστε να πάμε σε μια λογική αναμόρφωση των προγραμμάτων σπουδών. Και αυτό είναι πάρα πολύ σημαντικό και παράλληλα μια πολύ σοβαρή διαδικασία. 2 σημεία. Τα παιδιά είναι κολλημένα στην οθόνη. Και από την άλλη μεριά χρειάζονται την οθόνη προκειμένου να μπούμε σε μια ψηφιακή εποχή. Εκεί πρέπει να βρούμε μια ισορροπία, εγώ νομίζω. Μια ισορροπία. Έτσι. Το ότι το AI δεν είναι αυτονόητο για τη γενιά Z, ή μάλλον δεν είναι τόσο, πώς να το πω, μέσα σε αυτή τη διαδικασία, είναι ένα θέμα που μας δίνει χρόνο, ένα γεγονός που μας δίνει χρόνο να σκεφτούμε στην πραγματικότητα πώς θα χρησιμοποιήσουμε το AI. Όλοι μιλάμε για AI, αλλά τις ηθικές, τις ψυχοσωματικές ή άλλες διαστάσεις των χρηστών δεν τις ξέρουμε ακόμα. Ευχαριστούμε για την έρευνα.
Μου επιτρέπετε λίγο να συμπληρώσω κάτι. Το ψηλαφίσαμε το θέμα της τεχνητής νοημοσύνης εδώ. Και ουσιαστικά ανοίξαμε, ξέρετε τι γίνεται, κάθε φορά που ρωτάς κάτι και βγάζεις έχεις ένα έβριμα μπροστά σου και μετά αρχίζουν και δημιουργούνται άλλα 3-4 ερωτήματα που δημιουργούνται με βάση αυτό το έβριμα. Ένα λοιπόν βασικό ερώτημα το οποίο θα κοιτάξουμε σε επόμενες διερευνήσεις να το δούμε είναι το όχι μόνο σε τι βαθμό χρησιμοποιούν, αλλά γιατί, για ποιο σκοπό, με ποιον τρόπο, ποια εργαλεία, δηλαδή μπορούμε να πάμε πλέον σε μια ευάθυνση σε αυτό το θέμα για να σας δώσουμε ακόμα περισσότερη ποιοτική πληροφορία και όχι απλά ένα γενικό δείκτη χρήσης. Είναι κάτι το οποίο θα το δούμε στα επόμενα βήματα.
Κύριε Μιχαηλίδη.
Ναι, επιτρέψτε μου κύριε Πρίτανη να έχω ένα λεπτό περισσότερο. Η ανάλυση μου θα κυμανθεί μέσα από δύο οπτικές. Αρχικά θα μιλήσω με την ιδιότητα του ιστορικού. Κυρίες και κύριοι, η ανθρωπότητα τους τελευταίους 2 αιώνες γνώρισε 4 διαδοχικά κύματα βιομηχανικών επαναστάσεων, τεχνολογικών επαναστάσεων. Η πρώτη στα τέλη του 18ου και στις αρχές του 19ου αιώνα, ατμός, τρένα και κάρβουνο. Η δεύτερη στο δεύτερο μισό του 19ου αιώνα, αρχές του 20ου, πετρέλαιο. Η τρίτη τα κομπιούτερ αμέσως μετά το δεύτερο παγκόσμιο πόλεμο και η τέταρτη είναι αυτή που βιώνουμε, είναι η εποχή της ψηφιακής μετάβασης της τεχνητής νοημοσύνης. Υπάρχει μια σημαντική διαφορά σε αυτά, η οποία ερμηνεύει απόλυτα τα αποτελέσματα της έρευνας. Και οι 3 προηγούμενες τεχνολογικές επαναστάσεις έγιναν μέσα σε καθεστώς παγκόσμιας εφορίας. Το περιβάλλον, το πολιτικό, το κοινωνικό, το περιβάλλον μέσα στο οποίο γεννιούνταν και ζούσαν οι άνθρωποι ήταν ένα καθεστώς αισιοδοξίας. Επομένως, εκείνες οι γενιές προσδοκούσαν σε κάτι καλύτερο. Αυτή η γενιά που την παρακολουθούσαμε τώρα να αποτυπώνεται στην δημοσκόπηση είναι η πρώτη γενιά που βιώνει μία τεχνολογική επανάσταση και μάλιστα την πιο έντονη, την πιο δραματική, μέσα σε ένα καθεστώς ανασφάλειας, αβεβαιότητας και σκεπτικισμού. Γι' αυτό αντιδρά έτσι. Είναι μία συντηρητική γενιά η οποία έχει μεγαλώσει με πολύ χαμηλές προσδοκίες μέσα σε ένα αβέβαιο περιβάλλον. Τα αποτελέσματα για μένα είναι όλα ερμηνεύσιμα. Είναι δραματικό αυτό να το παρακολουθήσει κανείς, αλλά είναι απόλυτα ερμηνεύσιμο. Τώρα το δεύτερο, θα μιλήσω ως αντιπρίτανης φοιτητικής μέριμνας. Ακριβώς αυτή είναι η στόχη μας. Επειδή άκουσα μία συζήτηση για τις εστίες, πραγματικά βλέπω να μας κουνούν το δάχτυλο αυτοί που άφησαν τις εστίες και τη φοιτητική μέριμνα του Αριστοτελείου επί 100 χρόνια στο έλεος. Θέλει πολύ θράσος για να το κάνεις αυτό, είτε είσαι συνδικαλιστής, είτε είσαι όποιος κι αν είσαι. Λοιπόν, οι εστίες αλλάζουν, το πανεπιστήμιο αλλάζει και οι φοιτήτριες και οι φοιτητές θα έχουν σε λίγο διάστημα τις φοιτητικές εστίες που ανταποκρίνονται στη φοιτητική μέριμνα και ταιριάζουν σε ένα καθεστώς, σε μια κοινωνία του 21ου αιώνα. Θέλουν εθελοντισμό και να βρίσκονται μέσα με τους συμφοιτητές τους. Αυτό ακριβώς κάνουμε. Και ενδιαφέρονται για την ψυχική τους υγεία. Ξέρετε, παρακολουθώντας τους δείκτες, το αναφέραμε στην προηγούμενη συνέντευξη τύπου που δώσαμε, υπάρχει μία αύξηση των φοιτητών και των φοιτητριών που ζητούν τις κοινωνικές υπηρεσίες του Αριστοτελείου Πανεπιστημίου μέσα σε ένα εξάμηνο μεγαλύτερο του 200 με 300%. Και είμαστε ακόμη στην αρχή. Λοιπόν, μπράβο σε αυτά τα παιδιά. Ο σκεπτικισμός τους είναι απόλυτα ερμηνεύσιμος, αλλά εμείς εδώ τους ακούμε. Σας ευχαριστώ.
Κυρία Λουίζου, στη θέση σας έχετε το μικρόφωνο να συντονίσετε. Έχει το δικό της μικρόφωνο. Γιατί πήρε το κύριο Τεμεκενίδη. Πάρε το δικό σου, για να μπορεί να απαντάει ο κύριος Τεμεκενίδης.
Καλησπέρα και από μένα. Παρακαλώ τους δημοσιογράφους που είναι εδώ να θέσουν ερωτήματα. Κυρία Αβραμίδου, αν θέλετε πείτε το όνομά σας και το μέσο από το οποίο προέρχεστε.
Κάποιος να δώσει ένα μικρόφωνο στην κυρία Αβραμίδου.
Καλησπέρα, Σμαρό Αβραμίδου από το Αθηναϊκό και Μακεδονικό Πρακτορείο Ειδήσεων. Ήθελα να ρωτήσω κάτι ίσως λίγο τεχνητικό στον κύριο Τεμεκενίδη για τα στοιχεία αυτά τα διαγενειακά που παρουσιάστηκαν και έχουν πολύ ενδιαφέρον. Αναρωτιέμαι δεδομένου ότι το δείγμα των φοιτητών της Gen Z, των Millennials, της Gen X,
δεν είναι ίδιο. Έχει γίνει κάποια στάθμιση, δηλαδή έχουν βγει με ασφάλεια αυτά τα αποτελέσματα, είναι αντιπροσωπευτικά.
Ίσως το είπα, δεν το παρέλειψα να το πω, είναι στην ταυτότητα που έδειξα, αλλά δεν το είπα ίσως για λόγους ταχύτητας. Όλα τα αποτελέσματα σταθμίζονται σε δύο επίπεδα. Το ένα επίπεδο είναι η σχολή, γιατί έχουμε διαφορετικό αριθμό φοιτητών σε κάθε σχολή. Άρα, λοιπόν, εμείς έχουμε ένα δείγμα το οποίο θα πρέπει να σταθμιστεί έτσι ώστε να έχουμε μια αντιπροσωπευτικότητα ως προς την κατανομή των φοιτητών με βάση τη σχολή στην οποία φοιτούν. Και κατά δεύτερο λόγο, επίσης πολύ σημαντικό, ως προς το έτος ή το στάδιο φοιτησης, το επίπεδο φοιτησης, δηλαδή αν είναι προπτυχιακός, αν είναι μεταπτυχιακός, αν είναι διδακτορικός. Γιατί έχουμε ένα δείγμα το οποίο έρχεται με μια τυχαιότητα, γιατί είναι μια τυχαία δειγματοληψία. Άρα, λοιπόν, αυτά που βλέπετε εδώ έχουν εκ των υστέρων σταθμιστεί έτσι ώστε αυτό που παρουσιάζουμε να είναι μια μικρογραφία του Αριστοτελείου ως προς τη σχολή φοιτησης, άρα λοιπόν ισορροπημένα αποτελέσματα και ως προς το έτος ή τη φάση φοιτησης, προπτυχιακά, μεταπτυχιακά, διδακτορικά. Ναι.
Ευχαριστώ πολύ.
Κυρία Βραμίδου, η διαφορά των ερωτηματολογίων από τον Γκάλοπ είναι ακριβώς αυτή που είπατε. Εμείς κάνουμε Γκάλοπ. Ερωτηματολόγια υπάρχουν. Μπορώ να έχω 50.000 απαντήσεις από ερωτηματολόγια που είναι εντελώς αστάθμιστα. Και αυτά τα 1.600, 1.700 που έχουμε εμείς, όχι είναι απλά σταθμισμένα. Σκεφτείτε μία πολιτική δειγματοληψία που γίνεται, τα γκάλοπ γίνεται με καινίδι των πολιτικών αποτελεσμάτων. Σε τι νούμερα είναι?
Η υποχρεωτικότητα πανελλαδικά, γιατί ο καθένας μπορεί να κάνει
πανελλαδικά.
Είναι
1.000. Εμείς έχουμε 3.500, 4.000, μιλάμε για νούμερα πίστευτα. Άρα δεν μιλάμε απλά για σταθμισμένα, μιλάμε για γκάλοπ απόλυτα. Και αυτά που σας δείχνουμε εμείς όλες αυτές τις φορές στο βαρόμετρο των φοιτητών είναι γκάλοπ. Δεν είναι ερωτηματολόγια, έτσι. Είναι απόλυτα σταθμισμένο.
Κυρία Πιμενίδου, από την ΕΡΤΡΙΑ.
Καλησπέρα. Μου έκανε τρομερή εντύπωση και για την ψυχή, για το ποσοστό που είναι τεράστιο. Αυτό έτσι δείχνει και γενικότερα ότι η γενιά Z δεν θέλει και ένα κακό εργασιακό περιβάλλον. Γενικά ότι φροντίζει πάρα πολύ τον εαυτό του, φροντίζουν αυτά τα παιδιά. Εξαιρετική εντύπωση μου έκανε. Και όπως επίσης βέβαια και για την κοινωνική αναγνώριση. Αυτό φαντάζομαι, κύριε Τεμεκενίδη, εσείς αργότερα θα το αξιοποιήσετε και σε άλλες έρευνες ενώ πολιτικού περιεχομένου. Απλά ήθελα να ρωτήσω και τους αντιπριτάνης και τον κύριο Πρίτανη, σε σχέση τώρα η έρευνα αυτή που είναι πραγματικά εντυπωσιακή, πόσο μπορεί να αλλάξει, να επηρεάσει τέλος πάντων το πρόγραμμα σπουδών, πέρα από αυτά που είπε ο κύριος Μιχαηλίδης για τον εθελοντισμό, την ομαδικότητα και όλα αυτά. Δηλαδή, πραγματικά να αλλάξει το πρόγραμμα, είτε σε προπτυχιακό επίπεδο, είτε σε μεταπτυχιακό.
Καταρχάς, κύριε Πιμενίδου, γι' αυτό κάνουμε και το βαρόμετρο. Ακριβώς από την πρώτη στιγμή είπαμε ότι ακούμε τους φοιτητές μας και κάνουμε τη στρατηγική μας ανάλογα με τις ανάγκες τους. Το πρώτο πράγμα λοιπόν το οποίο θα κάνουμε, επειδή πλέον κλείνουμε τον πρώτο χρόνο, γιατί το πρώτο γκάλωπ το κάναμε με τους πρωτοετής φοιτητές, συνεχίσαμε το Δεκέμβριο-Φεβρουάριο και τώρα είναι αυτό που βλέπετε. Έχουμε πλέον ετήσια αποτελέσματα. Θα δώσουμε feedback στους φοιτητές αυτούς που απαντούν. Άρα θα έχουμε από αυτούς καταρχάς τις δικές τους κρίσεις. Γιατί το να το πάρεις πίσω, γιατί όλοι αυτοί που συμμετέχουν, οι 3-4 χιλιάδες, όταν παίρνουν και τις απαντήσεις επιλεκτικά και επεξεργασμένα από εμάς, από την Παλμός και από το Αριστοτέλειο, καταλαβαίνετε ότι δημιουργείται αυτή η διάδραση. Απαντήσατε, σας λέμε τι απαντήσατε. Στη συνέχεια, προφανώς είναι το θέμα της προσαρμογής. Σίγουρα αυτό που χρειάζεται είναι η μεγαλύτερη έκθεση των φοιτητών μας στην τεχνητή νοημοσύνη. Αυτή τη στιγμή φαίνεται ότι έχουμε θέμα. Το βλέπετε. Θα μπορούσε να πει κανένας και ανησυχητικό θέμα, εάν θέλουμε να προλάβουμε τις εξελίξεις, χωρίς να σημαίνει ότι εμείς είμαστε μόνο υπέρ της τεχνολογίας. Το είπε νομίζω ο Αντιπρίτανης, ότι προφανώς ένα πανεπιστήμιο πολυθεματικό που έχει μάλιστα τις ανθρωπιστικές σπουδές κεντρικά, δεν μπορεί να λέει ότι είναι μόνο υπέρ της τεχνολογίας. Προφανώς χρειάζεται έλεγχος, προσεκτικά, να μπουν όλα αυτά, αλλά δεν μπορεί το πανεπιστήμιο να χάσει αυτή τη στιγμή τις εξελίξεις, γιατί η Gen Α που έρχεται, σε λίγα χρόνια θα είναι οι φοιτητές μας, προφανώς θα χρειαστούν, το ανέφερε ο κύριος Μαγκιώρος, προγράμματα εναρμονισμένα, θα πρέπει από το πρώτο έτος να αρχίσουν να μαθαίνουν τεχνητή νοημοσύνη και μάλιστα σε core curriculum, όχι σε μαθήματα επιλεγόμενα. Θα πρέπει σιγά σιγά τα εργαλεία να είναι μέσα στο πανεπιστήμιο. Όσο και να θέλουμε να κρυβόμαστε, αν οι φοιτητές βλέπουν τα LLMs, τα GTP που έχουμε όλοι μας κτλ., το κάνουν. Όσο και να προσπαθούμε να πούμε οι διδακτορικές διατριβές ή τα masters, τα thesis δεν είναι AI, είναι. Άρα θα πρέπει προφανώς να προσαρμοστούμε. Και όπως βλέπετε, ψιλοπροσαρμοζόμαστε. Είδατε εκεί υπάρχει ένα avatar που κάνουμε AI στην νομική σχολή, που είχε την ευγενική καλοσύνη ο Πρωθυπουργός να μας το δώσει πιλωτικά. Είμαστε εκεί και θα το κάνουμε. Άρα προφανώς και θα προσαρμοστούμε και γι' αυτό κάνουμε τα γκάλωπ. Αυτό τα κυλιόμενα γκάλωπ, έτσι. Κάτι θέλετε, κύριε Μαγκιώνα?
Νομίζω ότι αυτό ακριβώς είπα και εγώ, απευθυνόμενο στον κύριο Τεμεκενίδη ήδη από την αρχή. Δεν έχουμε, νομίζω, περιθώριο να μην λάβουμε σοβαρά την έρευνα αυτή και να μην κάνουμε μια προσπάθεια ώστε ακριβώς να αναμορφωθούν τα προγράμματα σπουδών και, αν θέλετε και πιο συγκεκριμένα, τα περίφημα μαθησιακά αποτελέσματα. Έτσι. Δεν είναι μόνο γνώση και skills και δεξιότητες. Έτσι. Υπάρχει μια ηθική, πνευματική διάσταση που εκπαιδεύουμε τους φοιτητές μας, τα competencies, ικανότητες, τέλος πάντων το λέμε στα αγγλικά. Άρα με βάση αυτή την έρευνα, τα τμήματα πρέπει να ενημερωθούν για τα αποτελέσματά της και από εκεί και πέρα να ξεκινήσει μια διαδικασία ανάλογα με την ειδικότητα και το γνωστικό αντικείμενο, προκειμένου να μπορέσουμε, όπως πολύ σωστά είπε και ο κ. Μιχαηλίδης, να λύσουμε. Εδώ προκύπτουν και προβλήματα. Δηλαδή, ότι εδώ μας λέει ότι στο προσεχές μέλλον θα έχουμε προβλήματα αν δεν το προσέξουμε από τώρα. Και όλο αυτό έχει να κάνει, και κλείνω, με την έννοια της ποιότητας, της διασφάλισης ποιότητας των σπουδών μας. Έτσι. Εδώ το πρόβλημα είναι και ακαδημαϊκό και κοινωνικό και επιστημονικό, με την έννοια το ότι πού πάμε σε σχέση με την artificial intelligence και πώς αυτή θα συνδυαστεί με κλασικές επιστήμες.
Υπάρχει άλλο ερώτημα από δημοσιογράφα? Όχι.
Κύριε Τεμεκενίδη, ένα σχόλιο δικό σας για να το κλείσω.
Μου βάλατε φυτίλια. Πολλά, ναι. Πολλά, λυπηθείτε με. Να σας πω γιατί. Γιατί αν δείτε, εγώ το έχω δει από πίσω, αν δείτε την ανάλυση των αποτελεσμάτων με βάση τη σχολή φοιτησης, είναι τόσο εντυπωσιακές οι διαφορές ανάλογα με την επιστημονική κατεύθυνση του καθενός, με το επιστημονικό background του καθενός. Βλέπεις πόσο διαφορετικά αντιμετωπίζουν τεχνητή νοημοσύνη σε θέματα δεοντολογίας, ηθικής, κανόνων, τα παιδιά τα οποία φοιτούν σε θεωρητικές, όπως λέμε, σχολές, δηλαδή στην φιλοσοφική για παράδειγμα. Και πόσο διαφορετικά το αντιμετωπίζουν αυτοί που είναι στην ιατρική ή αυτοί που είναι στα πολυτεχνία, που είναι τεχνικός κλάδος. Άρα υπάρχει ένας πλούτος στοιχείων που χρειάζεται χρόνο για να αφομοιωθεί, χρόνο για να αποτυπωθεί και κυρίως πολύ σοβαρή, όχι διαγώνια ανάγνωση, μια πολύ σοβαρή ανάγνωση για να μπορέσει κάποιος συνδυαστικά να φτάσει στα κατάλληλα και όχι σε επιπόλαια αποτελέσματα. Οπότε, ναι, υπάρχει πολλή δουλειά από πίσω. Αυτό ήταν απλά μια γεύση στα πλαίσια μιας συνέντευξης τύπου.
Ευχαριστώ. Θα το κλείσω αισιόδοξα, γιατί πιστεύω ότι η εκτίμησή μου για τη μελλοντική σχέση του Αριστοτελείου Πανεπιστημίου και της τεχνητής νοημοσύνης δεν μπορεί παρά να είναι αισιόδοξη, γιατί παρακολουθούμε τις εξελίξεις. Το βλέπετε. Οι προηγούμενες γενιές έμαθαν να ψάχνουν στις βιβλιοθήκες. Εμείς. Έτσι ήμασταν στο Πανεπιστήμιο. Αυτή η γενιά όμως έμαθε να ψάχνει στο ίντερνετ. Η επόμενη γενιά θα μάθει να σκέφτεται πιο δημιουργικά από τις μηχανές. Για όσους και όσες πιθανόν φοβούνται ότι για το μέλλον αυτό, έχω να πω, και ελπίζω να μην ακουστεί σκληρό, ότι η τεχνητή νοημοσύνη δεν θα αντικαταστήσει τα πανεπιστήμια. Αυτό που θα συμβεί είναι ότι τα πανεπιστήμια που διδάσκουν τους φοιτητές τους να συνεργάζονται με την τεχνητή νοημοσύνη θα αντικαταστήσουν εκείνα που δεν το κάνουν. Γι' αυτό είμαστε λοιπόν εμείς εδώ, γιατί θεωρούμε ότι η ευκαιρία στο Αριστοτέλειο να γίνει ένα από τα πρώτα ευρωπαϊκά πανεπιστήμια σχεδιασμένα για την εποχή της τεχνητής νοημοσύνης είναι μεγάλη. Το πανεπιστήμιο, τελειώνοντας, θέλω να πω ότι δεν υπάρχει για να διδάσκει στους νέους πώς να χρησιμοποιούν τα εργαλεία. Είναι πολύ λίγο. Υπάρχει όμως, το ανέφερε έμεσα ο Αντιπρίτανης, για να τους διδάσκει πότε να τα εμπιστεύονται και πότε όχι, στη διαμόρφωση της σκέψης τους και των προτάσεών τους. Και γι' αυτό είναι απαραίτητο να γνωρίζει βαθιά πώς χρησιμοποιούνται. Αυτό λοιπόν κάνουμε, γι' αυτό τους ακούμε, γι' αυτό είμαστε εδώ και να ξέρετε ότι αυτό είναι που προσπαθούμε να κάνουμε στο Αριστοτέλειο Πανεπιστήμιο. Σας ευχαριστώ λοιπόν όλους που ήρθατε. Νομίζω η κυρία Λουίζου θα κυκλοφορήσει ένα slide set για όλους σας, για να πάρετε τουλάχιστον τα βασικά αποτελέσματα. Επειδή αυτά χτες τελείωσαν, θέλουμε και εμείς λίγο χρόνο να κάνουμε μια βαθιά επεξεργασία. Ίσως έχουμε ένα συνολικό την επόμενη φορά, γιατί θα έχουμε την επόμενη φορά και τα νέα, αλλά θα έχουμε και τα συνολικά με πολλά αποτελέσματα. Όπως βλέπετε όμως, αποτυπώνονται πολλά στοιχεία. Και αποτυπώνονται στοιχεία όχι μόνο για τους φοιτητές μας, αλλά για τη γενιά, για αυτά τα νέα τα παιδιά που δεν υπάρχουν και παγκόσμια πολλά στοιχεία. Τα ακούσατε και από τους τρεις εδώ και από τον κύριο Τεμεκενίδη. Ελπίζω να είναι ενδιαφέροντα και θέλουν λίγο προσοχή και πώς θα τα γράψετε. Γιατί αυτή η νέα γενιά είναι απίστευτη στη δυναμική της και φαίνεται ότι, όπως είπε ο κύριος Μιχαηλίδης, και ευαισθησίες έχει και πραγματικά αποτυπώνεται και το περιβάλλον μας πάνω τους. Άρα είμαστε εδώ για αυτούς και θα τα καταφέρουμε. Ευχαριστούμε πολύ.
Outh Radio, η φωνή της γνώσης.
What is love anyway? But a fire that burns too close. I gave my heart to the flame, and it turned me into smoke. You said forever, I heard goodbye. The echo still lingers. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. Your words cut like a knife, and the scars still sing your name. I thought love was my savior, but it played a crueler game. You said forever, I heard goodbye. Your shadow's a dagger. Why'd you lie? You're the love that kills. No second chance, no thrills. What is love anyway? Just another way to decay. You're the love that
Another midnight, another drink. Silence wraps around me. Can't escape this noise inside. Need the world to stop. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Crowds keep pressing, always wanting more than I can give you. Lost myself in all their needs. Time to disappear. Let me breathe in empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Don't come looking, don't come calling. I'll be where the silence falls, where loneliness feels like home, and I can finally be. Let me breathe empty rooms where your voice can't follow. Tired of all this damn pretending. Just need quiet now in these empty rooms. Just me and quiet.
Αριστοτέλειο Πανεπιστήμιο. Youth Radio. Συντονιστείτε.
School of Medicine at the Aristotle University of Thessaloniki in Greece, and part of this initiative which is called City Science Initiative. And we are going to present you different aspects of what this is all about and what we have been doing all day today. I have a panel of speakers which I will introduce to now. I'll start with Caroline Nevigans, who was one of the founders, I would say, of the City Science Initiative and has been the whole soul of it for the entire period. If you want to introduce yourself as well.
Yes, my name is Caroline Nevian. I used to be the Chief Science Officer of Amsterdam. I retired of that position in the summer of 25, and I'm still a professor at the University of Amsterdam. And I'm very happy to be here. Thank you, Panos, for inviting me.
Then we also have with us Christian Ioine from Italy. Christian.
Thank you, Panos. I'm professor of Law and Policy of Innovation at Luis University in Rome, where we have also a laboratory that does work with cities on the governance of innovation. And in this capacity, I'm also city science officer for a small town called Reggio Emilia that has been quite active, even though, you know, it's tough these times.
Thank you very much. A local stakeholder is my good friend and colleague Eri Toka. Eri?
Now you hear me, okay. Thank you very much. I'm Eri Toka. I'm here as the president of the board of directors of NOISIS. NOISIS is the Science Dissemination Center and Museum of Technology located here in Thessaloniki. And also I am the head of the Technology Transfer and Innovation Unit of the Aristotle University of Thessaloniki. And thank you so much for the invitation to participate in this very interesting panel.
Thank you, Eri. We also have with us Maria Gerogianni, who is from the European Commission.
Okay, thank you. Good afternoon to all. I represent the European Commission and the DG Research and Innovation General Directorate. And I work in the DG Research for a lot of years now, 33 years, and I'm working on the file of the mission, Horizon Europe mission on climate neutral and smart cities mission, and also the Member States Partnership Drive Urban Transition, again of the Horizon Europe, and of course with my colleagues Maria Caroline and Panos and Christian on the City Science Initiative to strengthen the science dimension of cities.
And last but not least, we have in the panel Professor Maria Arce from the University of Greenwich, who is the current director of the Science Initiative.
Thank you, Panos. My name is Maria Arce. I'm a professor of linguistics at the University of Greenwich in London, and I'm enchanted to be here. So I also look forward to hear your comments at the end of this panel. I hope that we manage to raise your interest in this initiative. Thank you.
Thank you very much. So after this roundtable introduction, I will ask Caroline to say a few things on what this is all about. I mean, what is city science? How did it start? How it is going to be continued? How it is being formed?
Yours? No, yeah, it works. There it is. Okay, so my name is Caroline Nevian, and I was appointed the Chief Science Officer in 2017 in the city of Amsterdam. I was the first city science officer in Europe, I think, as far as we know, Maria and me. And I was faced with a situation that they said, well, why don't you do something with science in the city? Something. So I thought, what is the something? And I came from Delft University of Technology, where as a social scientist, I'm a sociologist, and as a social scientist to be in a natural science faculty is great. Because critical thinking is a very different character than in a social faculty, social science faculty and humanities. So I really enjoyed the freedom, and I really enjoyed the fact that in this University of Technology, we were solving things all the time. So there's an issue and you solve it. I came back to the University of Amsterdam, which was my alma mater, and I saw this whole department of social sciences and also a lot of the natural sciences being very distant from the issues that the city was facing. So whether we talked about obesity, or whether we talked about energy transition, or whether we talked about transport, or whether we talked about housing, there was no relation between the university and the civil servants who were having the task to solve those issues. So I started to talk around and started to see how can we find collaborations. And quite soon I found that the first thing is that a lot of research is done, but the way it's published is inaccessible for the people who live in the city and who work in the city. Including the European Commission, there is so much research being done that could be interesting for cities, but it's not accessible to the civil servants. It's a question of where it's published, how it's published, the language in which it is published, but also the research questions that are posed by academia do not resonate with the questions, the solutions that the society needs. So I started to work with scientists and academics and civil servants to find research questions to which they can both relate. And then I found when I started creating projects, this made a huge difference. But there were very mundane issues I had to take into account. For example, civil servants don't like to take too much trouble. So I had to position the lab on the way from the city hall to the metro. And then they just had to go a little step to the right and they could see the research results of the students, for example. So there's a lot of nitty-gritty details that you have to take into account. And we started to found openresearch.amsterdam, which is, I really recommend you look at it. It's the platform where, as a city region of Amsterdam, all the universities, all the research institutes, all the departments of the municipality, and the utility boards, the water board, the transport board, they all publish their research there. And when they started to do that, we've had a very simple format. You have to have a title and a summary that is understandable for any person. And then you can go in your own language of your profession. So to learn to work interdisciplinary, both for the civil servants as well as for the academics, became locally very interesting. So I thought, who else is doing this in Europe? And then I met Charlina Vicheva, who was then the deputy director of GRC. I met Maria Yeroyani, Patrick Child. And we said, this is actually really important that the cities become much more visible, because 75% of the people in Europe already live in cities, so that's where the big issues are. And we invited, through the Innovation Action Award, we invited cities through the CTO network, your networks, who you know people. And then we made the first meeting in Brussels. It was called Science in the City, to explore, is this an issue? Is it just Amsterdam, or is this also happening in other cities? Thessaloniki was present, Reggio Emilia was present, Hamburg was there. There were already like 20 cities sort of present. And we did a workshop that I chaired where we said, okay, what are the issues we are facing? And we found that in all the cities, the complexity, the new complexity, because of digitization, because of climate change, because of increasing inequality, civil servants, cities, need the support of academics and of scientists. So we found there is a new need for collaboration between cities and universities, between cities and research institutes. And then we decided to see if this was just us. So we did an experiment. We identified 5 themes: mobility, circularity, tech in the city, health, and one more. Anyway, we had 5 themes. And then we worked with all the cities online to see, does it really make sense to connect cities with universities? Can we find shared research questions? That became very successful. And then our City Science Initiative was born. And since then, we have made 4 reports. The 4th report was presented today. I retired as a chair of the City Science Initiative last summer, and Maria Archer took over, and she finished the 4th report. The first one was on city science for urban challenges, showing that it's actually important to do this, and also already mentioning the hurdles that you have to take in language, in collaboration formats. The second was called Urban Challenges. Sorry, what was the second one? Huh? No, the first was urban research ecology. So if you want to do city science, what do you need? So you need to have, for example, good data. You need to have publication formats that you can share. You need to have formal agreements between the boards of university and cities. You need to have catalysts like city science officers. You need to have research lines that also student work can add up on each other. Then the 3rd report was on social impact for climate justice. And the 4th report was just published today, which is called Blueprints for Messy Cities. And that's about how can you, what kind of formats can you actually use to make it work. And this all sounds very easy, collaboration between city and universities, but you have to realize it's about different disciplines, different kinds of knowledge, different stakes politically, different habits of communication, and that you have to all bridge. But you manage to do that because you share values, and you share the solution, the purpose, the mission, why you want to do it. Till here, I thought.
Thank you, Caroline. And I will give the floor to Christian. And since you have one of the city science laboratories, in fact, in the sense that you are working on that every day, and you are acting as a city science office as well, would like to share a few of your experiences from the Reggio Emilia.
Okay, so I'll share some experiences from my point of view. Of course, also includes Reggio Emilia. I founded this City Science Lab inside the university in 2012. Ever since, we have every year a capsule module within my courses in which we have students working on city challenges, as Caroline was saying. At some point in around 2016, in working with the city of Reggio Emilia, and after working with many other cities also, like Barcelona and other cities in Europe, we decided to establish, inspired by also by the example of Caroline, we decided to establish right after probably it was 2017, 2018, a city science office in Reggio Emilia. You're right, you were the first one. We followed right behind you, inspired by you. The idea was to not just the university working together with a single city, but it was about bringing many universities to cooperate with each other around some of the daunting challenges that the single city was tackling. In the case of Reggio Emilia, because Reggio Emilia is very innovative, is very quick, very fast in adopting solutions. There is a highly skilled group of civil servants there. We worked on the ownership of emerging technologies by citizens. So, for instance, we were amongst the ones, and DG Connect even gave us a sort of a prize for creating the first broadband digital community, wireless community. So there are citizens in this small neighborhood called Coviolo. Coviolo Wireless is self-providing itself digital broadband, which is important because, with 10 euros, they have broadband services for people that did not have access to digital broadband services. Or there is another neighborhood that has established an energy community, so they self-produce energy. So this was the first challenge in Reggio Emilia. But then, of course, we wanted to, as Lewis University, we wanted to work also with our city, which is Rome. It's where Lewis is established, and long story short, the current project on which we are working is very important because it's a sort of inspiration. We are getting inspiration from you because it's about transforming this former mental hospital into an exposome hub. As a medical oncologist, a clinical oncologist called it, the idea that all these environmental exposures that harm the health of people need to have a place where we bring together all the data from different fields, and we are working with the Faculty of Medicine of Sapienza, so it would be great at some point to because they really talk about integration of data, much like you, Panos, are doing with your medical physics lab, and the idea is to have a place where we can bring together all the people and all the scientists that have to do with the well-being, and especially the mental well-being of people. Because one of the aims is to talk about urban well-being, urban welfare, rather than urban health services or medical health services, to have all the professionals in the well-being sector working together in order to today we discovered this concept of Paolo Marchetti, who is a world-renowned scientist in personalized healthcare. So he's doing all this, and so today we talked about this personalized social care. It was Sofia from your lab that talked about this. The last project that I really am proud of is because it's in the very south of Italy, and it's still related to health and planetary health, as you want to call it. It's in Castellana Grotte, 19,000 people in the south of Italy. You know that the southern regions of Italy are part of the cohesion policy initiatives, and this is about creating, together with the local school and the city of Castellana, an aquaponic plant. So it's the combination of hydroponics and aquaculture and wastewater reclamation. So the University of Salento, we of course do all the social science part. University of Salento, which is a beacon of science in biodiversity and management of water, is creating this tertiary treatment to reclaim the wastewater and use this wastewater in a region that has a huge problem with water scarcity, in order to feed this reclaimed water to these basins where they farm fish and vegetables. And the schools, the kids, are really impressed by this, and it's also an inspiration for younger and new generations. We hope that this is going to be, you know, some sort of also the basis of an industrial plan. So, because many people, many younger generations members leave these regions, these small town cities and these regions, in order to go to somewhere where they find, you know, the big technology hub. Instead, what we are trying to say is that you can stay, you have the right to stay, and this is something that probably the European Union is already working on, and you can have access to these kind of opportunities in your place so that you don't have to leave and bring your knowledge capital somewhere else and deprive your regions and your city, your small town, or your vulnerable region from this important talent that you have.
This is very important because I think we also experience the same kind of troubles in Greece and probably in many other countries over the world, overpopulation of main cities and capital cities, but deprivation in the rural cities, and I think that's the current challenge of innovation and city science, how to promote the urban populations to live a high quality of life as well as work and live at the same place. So I'll turn to Maria Arce, and ask her to say a few words about her experiences with the city science, as well as refer to the blueprint of messy cities and city science that was presented and published today, and we are honored to have it. And we have a few copies for you if anybody's interested, and there are a few copies available to spare. Yes. So Maria?
Okay, thank you. I got engaged with city science because I bumped into Caroline at a bar where she was chairing a panel on a book that had just been, that was being presented on Science Meets Power. And that's how we met. And then the panel, the discussion of the panel and the discussions we had after that in that year that I was spending in Amsterdam resonated with a lot of the work that I had initiated 2 years before. I am the Deputy Director of a research institute of inclusive communities and environments. So the institute encompasses 6 different research centers that from different angles, it's very multidisciplinary. We encompass 6 research centers which come from 4 different schools, from one part of the faculty of the university. And one of the aims is to address challenges that affect citizens in the regional communities and in the city communities from all different perspectives. So from my university role, that was already resonating, and I wanted to learn more about it. And also, the other port of entry for me with city science was the work that I'm developing with a cost action. Is a scheme from the part of the Horizon scheme that is for cooperation in science and technology, and is a project about language abilities in the youth justice population, in the population that is young and is engaged and is going through criminal justice procedures, you know, when being very young. And we are undertaking this project, including 30 countries at the moment. And what we find in that agenda is that we want to affect policies, we want to deliver change, and the changes have to happen at many different levels. We are, of course, interested in affecting the directives that come at European level, but then also the implementation of the policies, the implementations that affect people, that affect the children, have to happen, have to be affected at city level. In the UK, for example, this is very visible because youth justice services are localized within local authorities, which is the name we give to municipalities. So we have the affected citizens at the city level, and we want to make sure that all the changes that we propose agree with the views of the practitioners and with those that are not only designing the policy but bringing the policy to reality, and in accordance with the experiences of the children and the citizens affected by them. So one of the very active streams that took off a year and a half ago is based on lived experience, and we have a very strong group of academics, policymakers and people from the city, professionals from the city, but also we have the children who are participating in workshops that we are developing, and these children are children who have gone or are going through criminal justice at the moment. So that was the other reason why city science and connecting knowledge that is evidence-based with policy at the level of at the city made a lot of sense to me, and I wanted to do more for it because I think it's a great cause that is quite underknown, and we need to raise our awareness about it and to bring this connection between science and the benefits of science and having reasons to make things well proved is important for citizens. So that's how I came about to this.
Thank you, Maria. I'll turn to the other Maria, Marie Gerogiani. And you are working in the European Commission, but you work with cities, you work with regions. Tell us on your experiences and your perspectives on how do you actually see city science as a from your own role in the European Commission.
Yes, I was taking some notes to structure my thoughts here, and so CSI we were discussing yesterday with Caroline, and I was saying that we are doing a lot on dissemination. We are publishing reports, we're publishing every detail. For instance, you can go on the Net Zero Cities. This is our mission platform, which supports the 112 climate neutral cities that we want to have by 2030 in the Horizon Europe mission, and these cities will be the front runners for the rest of the European cities to follow suit by 2040, 2050. And so Europe is the first green planet, climate neutral planet. And so I was saying that we have this portal, and we have also the portal under Regio, the structural fund, and the new cities agenda run by Regio. And Caroline said, yes, but we need communication, and indeed we need dialogue, and communication is what we have been doing in CSI. So in CSI we were exchanging, we were meeting in the municipal libraries, that's also we did today, meeting, and city servants, science officers, project officers, policy officers like me, citizens, architects were exchanging best practices in their city. So one city could learn from the other, and share concerns and share best solutions. So I think that is a very important role for CSI, share openly concerns, but share also solutions and best practices and how they did it in one city. This also contributes to the implementation of the city's mission, because in the city's mission we have the mission cities, some of them are also CSI cities, but we want also to get on board the mission-minded cities. So this is a very good learning exercise, peer learning, but also invitation to the mission-minded cities, which can happen through the network of the City Science Initiative. So this is the part for the dialogue, and so also strengthen the science dimension of the cities and support, for instance, the 112 mission cities, because they are now starting to implement, so they have been committed, they will become climate neutral, the work starts now, and so together with their mayors, They are putting their plans, their climate action plans, working really on the site on all the pillars: energy, mobility, which is health and well-being, circular economy, which is also covered by the CSI. Also, the City Science Initiative, I see also a very important role with regards to the Drive Urban Transition Member State Partnership, where we have 28 member states and national funding agencies doing research, launching yearly calls every year. And we want to increase the participation of cities in this project. So the annual conference of DUT is taking place in Brussels on 10 June. And you can also, if you cannot be physically there, register, but you can also participate online. All the projects, research projects are there. We're trying to get more CSI cities there. And finally, as also was discussed in the morning with my colleague in Regio, the structural funds, they are leading the new cities agenda. And there we could position CSI in the portal one-stop shop for cities of Regio. So they could be positioned very well there in the portal, since you are the holders of so much knowledge now, and open and accessible knowledge. Thank you.
Thank you, Marie. And I will now, last but not least in this sense, but Eri, as a local stakeholder, what do you think is the essence of city science, if you see it from your role as the director of Noises, the Science and Technological Museum of Thessaloniki, but also your role as a technological transfer office of the university?
Thank you so much. I actually understand that I am the one to learn from this panel. Because I'm quite new to Citizen Science Initiative, but I'm really interested in what I am listening to today. I have also put down a few thoughts on what we are discussing, and actually these thoughts come under both of my hats, Professor Bamidis, both as President of Noises, but as head of the TTO, Technology Transfer Office of Aristotle University. But this is an opportunity, just if you allow me to talk to you a bit about Thessaloniki and our ecosystem and how this matches this discussion. Thessaloniki is home to one of the largest universities in Europe, Aristotle University of Thessaloniki. This is the largest in Greece and one of the largest in the Balkans. So we have over 80,000 students, dozens of research groups. One of them is the lab of Professor Bamidis. And we have many decades of scientific output. So this is also home to Greece's only one institution that is specifically mandated to disseminate science and technology to the general public. And this is Noises, the technological body I'm representing today. So these two facts sit side by side in the same city, Thessaloniki. And yet the distance between them is quite large. This is what we have met recently with Professor Bamidis. And this distance is not only unique in Thessaloniki, but in Greece in general, because as you know, Greece is a very small country. We have, on a country level, we have half the population of New York metropolitan area. So you can imagine that we're a very small ecosystem, and yet we don't speak to each other so much. So this conversation is quite important for this small ecosystem. Let me say something about Noises. This is the Science Dissemination Center and Museum of Technology. It has a dual role in the ecosystem. And I think this is quite relevant for this discussion. In most European countries, also I heard about Italy, science centers and technology museums are part of the ecosystem. There are many of them at different scales, serving different communities. In Greece, that ecosystem does not yet exist in the same way, if you agree with me, Professor Bamidis. But what is the opportunity here, and why we have brought Noises in this discussion? Noises is the only institution that has the mandate from the Greek government to make science and technology accessible, engaging, and meaningful to all the citizens who are not scientists. So I think this is what is in the core of the City Science initiative we are discussing today. So that means that Noises every year hosts thousands of people, children on school trips, families on weekends, young people who may never enter a university campus also. All of them come to Noises and meet with science in a very alive way. So I think this is not a small thing, and that is, I understand from what you have also shared with us, that is the foundation of which public trust in science is built. I will share with you my point of view on technology transfer, because I think in Noises also what we are making actually is technology transfer, a direct one. So my framework, what I'm thinking, has 2 points. Science reaches citizens in 2 distinct ways. The first one is the direct channel, what we are doing in Noises, science centers, public engagement, education, experiential learning. And this is Noises, and it's the place where the public sees science as something visible, something that people can understand, people can catch with their hands, they can discuss about it, they can understand it. In Noises, citizens do not need to be experts on something. So they just have to walk into the door of Noises and learn something new. So this is the direct channel. We also have the indirect channel, which is the technology transfer as we know it from the university, knowledge commercialization, spin-offs, university innovations that come out of the research labs to the city as products, services, and also solutions. So this is the work of our technology transfer office at Aristotle University. We are trying to connect the research groups with industry, turn IP into ventures, and build bridge between academic knowledge and economic and social impact. So we have two channels, 2 parallel channels, an indirect and a direct one. And they almost never speak to each other. This is what we are facing right now together with Professor Bamidis, since we share positions in the same board of directors. So we have the science communicator from the one side, and we have the technology transfer on the other side, but they have different vocabularies, different metrics. They do not meet anywhere. So from what I understand, and I will conclude with this for now, City Science Initiative is positioned at this point. So how can we make these 2 worlds meet and speak to the people with the same language and make them engage in common initiatives?
Very good. Thank you very much. Thank you all to all panelists for this first round of statements. And I would turn back to you, Caroline, and say, how do you see this being formed? I mean, if you were to suggest, changes in, promoting all these activities and solving problems in real life, what do you think? What do you suggest it should be happening? What do you recommend?
Hello, yes. When I started as a chief science officer, nobody was speaking to each other. So that is a very normal situation, what you described, that, the left hand doesn't know what the right hand is doing. Also within universities, by the way, even within departments. So in universities, sometimes, it's like no communication between colleagues. It's amazing. And I only came back to academia after 25 years of entrepreneurship, and I thought much more knowledge sharing in entrepreneurship than in academia, despite all the publications. So I thought there are different levels that you have to do at the same time, in my perception. I think it's very important that the board of the university meets the board of the city. So we do once a year a dinner for the boards. And that dinner is very well prepared. It's very well prepared to understand the concerns of the board of mayor and aldermen. And we also inform what is the concern of the board of the university. And we have 3 universities participating. That is a whole diplomatic circus that we do. And then we have a thematic theme, and we have 3 scientists present from different institutes, and that really helps because it's good food, and then they have time to talk and ask questions, and then we make formal memorandum of understanding that we can collaborate. This is very important because then the deans are going to give the scientists the time to invest in relationship with the city. So sometimes I have to talk to the dean and say, please let your researchers spend time. No, they have to write publications. I said, no, they have to have social impact. And then I can refer back to the memorandum of understanding between the boards. So that's very important. Then it's important that the researchers from the university learn to take the time to build relationship with the people in the city. You cannot just extract data or push a project into a neighborhood. It requires time to participate. So sometimes we have an energy lab site Oost. It's very successful. It now exists for 10 years. It does data center heat into heat for the social housing. It changes the housing. It works with the residents, with the business people. But I was coaching the researchers in that energy lab for over 2 years. How to deal with citizens. Very interesting. They also found, for example, that the university, if they want to participate in the neighborhood, they have to underwrite a manifesto. They cannot only take, they also have to bring something. So the students are energy coaches for the residents. Very nice, because energy bills go lower. So the residents love the students, because it saves them money, Then in the city, I organize a lot of networks where they learn how research can enhance their own practice. Because civil servants, I tell researchers sometimes, the level of complexity that you deal with in a month in a university, a civil servant deals with in an hour. Because, it's always about money, it's about budget, it's politics, it's really complex. So they will only engage when there is a benefit for their own job, for their own task. But once they see it, they are so happy. And then the challenge is to make sure that the work of students, like what you also do, Christian, and we also do in many research institutes now, that the work of students builds upon each other. That you don't get all these incidents, but that the work of the students of this year is built upon the students last year. And that makes also a whole new knowledge flow happening, which benefits the city and the citizens in the first place.
This is all very useful. Christian, what is your point of view on this? What do you think is going to be the best recommendations to follow and enhance these activities?
I call it the waterfall effect. The idea that class after class they keep nurturing the same pond, right? The same. I had a breakthrough listening to Harry. Sorry, Harry, because I have to bad memory. This is a proposal for Maria and Maria, the Marias. And I have to say, I have to public acknowledge, throughout these years, we have had the leadership of Karen, but without the stewardship of Maria Ieroianni, probably won't be here. And I'm happy that it's a civil servant from Greece and from the south. Yeah, it's well deserved because to have the year of the commission, it's not an easy task. So, and she's been fighting within the European Commission to put the spotlight on initiatives like ours. And so, Harry, and I wish my university, Louis, had TTO, and this is something that I've been asking for now 10 years. Why isn't that we don't have a TTO? I think because there is no culture of technology transfer. And we even built this house of emerging technologies. We got the funding from the national government to establish the house of emerging technologies in Rome, together with other universities, in order to work together, because 80,000 students is fantastic. This is the same argument that I used with my university. I say there is Sapienza University. I see here Luciano Sasso. They have 120,000 students, something like that. It's a power. Knowledge is power. This is not me, but is a famous former president of Republic of Peru who is writing a book on knowledge is power. Francisco Sagasti. We should invite him at some point, and he's a science and technology expert. I think we should have. The reason why at this time I'm a little bit struggling about looking at this, because I'm a person that likes to do stuff. And I need to see concrete, pragmatically material stuff happening on the ground. And so maybe the City Science Initiative should have a sort of technology transplant office, so that, for instance, the things that, because I'm so much inspired by the work that you're doing with the medical physics. And now Eris told us about, the Noises museum and bridge. It's a bridge. She used this word, bridge. And I think we need these bridges inside these ecosystems, because people don't talk to each other not only within a single university, but also across universities. And this knowledge, this power, this energy gets lost in translation, gets lost in use. So I think that the City Science Initiative should have a space, and I'm looking at also Peter, who is another great pillar of the initiative, together now with our lighthouse, Peter Vandermaas, together with Maria Arce. I think we should have a room, a space in which we talk to each other on how to bring and to build projects that do similar stuff, like you're doing here in Thessaloniki, we're doing in Rome, and maybe other universities. So the typical grammar of innovation within Horizon Europe, bringing cities, citizens, universities around a specific project, and work together in different hubs, in different cities, on the same project.
And I think I can really second it, because what happens in Amsterdam, we do the project over, network gone, lessons not learned, implementation not happening. And to have the technology transfer, it would be also a methodology transfer. That is something that would be so valuable. But it really requires another way of finishing projects, really. And maybe designing them from day one.
It's a sort of like they have in Hollywood, like the copy, the editor's room, where people write the scripts of. So we should have a group of people that want to write projects together on different, and then tap into the network of Unica, Aurora, all the other Eurocities, so that those who want to write a project, then they can have this one-stop shop. What do you think, Luciano? You like it? He has 80% of the universities engaged in the universities alliances, so he's a huge power.
Does it work? Yeah, I think it's a very serious proposal. It's like Delft University of Technology. We have also a technology office. So you only get into the technology office by the moment you have patents or things you can sell. So we can't sell communities. We can't sell cities. So it is your work of Noises, and then translated to a transfer office. So this is more about how you work with elderly. It's not, we don't need the machine. We need the methodology, how you created the relation that yesterday 200 elderly were doing your experiments. How do you do it? So there's a methodological need that we don't fill, and we maybe don't even have the language, or we don't have the format, but it's something that we need to develop. So I think, Luciano, what do you think?
It's a complicated issue, but I mean, I
very
think we
complicated.
do, we do have the resources. I think now under the leadership of Maria, I think we can discuss Maria Archie, because we have a lot of Marias in the room, I know. So Maria Archie, I think we should actually debate and use also this opportunity of the revamping of a CSI, I think, to do more things. From my side, I'm very much committed. I represent here actually not so much my own university, which I love, Sapienza, but in this case I represent UNICA, which is a network of university which goes much beyond Sapienza itself, because it's 52 universities. So I'm happy to help as much as possible. Thanks.
Okay, thank you very much. Maria, are you going to fund this? What do you think is the best way forward in terms of funding, but also sustaining it, which is the basic thing that sustaining its effect, its impact, and it's not a matter of dissemination. It's a matter of cultivation. It's a matter of transplantation, as Caroline said. I mean, getting it to the people to get it well known is one aspect. We can cover that in many different ways. But getting it to do something different and have a proper impact is something else as well. So, but how do you see these being maintained, being promoted from the European Commission point of view?
Okay, I cannot reply on the funding, but okay. I think it's very important you promoted the talking to each other, really. You really raised the talking between different communities, and I think you should continue like this. And I think you need to involve also young people, because we had the European Week of Youth in Brussels, and we also did a youth session. And in fact, we were training our young panelists because they were not aware of what is happening, how we mitigate climate change, what possibilities there are, what possibilities of exchange there are through Erasmus program, for instance. And then some stakeholders came to visit us in Brussels from the private sector, and they had a very nice system to suggest on waste management, circular waste recovery. They were not either aware of, we had to tell them, I mean, the cities mission, what is that? Horizon Europe cities mission, the Horizon Europe member states partnership, the calls, they were not aware. So that means that there is still some fragmentation, and I think we still need to work on the dialogue part and communication part. For instance, as this initiative had started in the past, meeting in the municipal libraries, also in Brussels, and where we were inviting, because you need also to see the mapping, what exists, what needs to be done. I mean, that could be, it's not a research project, but could be a coordination support action, as we call it. So this is really like putting different initiatives together. You have it's a support action, you have a coordinator, and then you have different packages. So this is like a project which remained a project of individual efforts and of common efforts, but of voluntary. So putting really your resources together. So that's how I see it for the future. And then there are, of course, a lot of possibilities. That's why I wanted to connect you with the Drive Urban Transition Partnerships that are annual calls. But of course, it requires resources to prepare a project. I understand this.
And I think we have some today's discussion, all-day discussion, which also incorporated thematic table discussions over lunch, thinking lunch tables, as we call it, Maria. There are already perhaps not work packages, but ideas that some of these may be cultivating a support action, for example, or at least something which will start running on a voluntary basis like we are now doing, but then progressively developed into something more formally funded and more formally sort of promoting itself. So would you like to give us a a kind of an idea of what has been discussed and perhaps some of the sort of points that struck you?
Yes, well, in those discussions in particular, but if I can say something about what has been said before, because I think that there's a lot of potential in, and then I'll tie it back with to the question. I think that what we have done all these years, all the people who have been working so much and so hard and so with so much focus on bringing this to the point. I mean, and I said this at the beginning of the day today. We may not see it because we are in it, but we have normalized communications and relations that are not the usual. I mean, to communicate with cities, the fact that we just take for granted, the members of the City Science Initiative, that we need to be working with the city people, that we are part of the same, that we are thinking about the projects together from the beginning, that we've done a lot of work in understanding, translating the language. It's, again, we cannot take it for granted, and we have to remember when we bring new people on board, we need to go back to that and do a refresher course and refresh our minds. And you were mentioning the different languages, and we have a lot to share about that, and we shouldn't minimize the point in which we are now. And we have broken walls. Caroline mentioned memoranda of understanding. My university had signed a memorandum of understanding with the municipality many years ago. I was the first one to make use of it once all this was in my radar, because the memorandum existed, but if people are not in the mindset, nobody's gonna call for it, because to do what? Are we going to do what exactly, and how are we going to benefit from it? And all this has been the background of the discussions today, how to take it forward. We've been discussing different topics, AI, democracy, well-being and mental health, and barriers for citizens. We've been discussing cultural barriers, language barriers, how to improve access to services and access to education for all people included in the city. And now we'll be thinking in two ways: how to take a stock of that in whatever shape it takes. It can be a report or any other output as well. And how to go deeper is what we are saying here. How to go for projects, how to take it for real. I mean deeper, not for real. Real is everything, right? Because we are doing it. But to go deeper, which is something that we also mentioned in the final round. How can we go deeper? How can we make the contacts that we have thanks to the network something that cannot be forgotten again? We take it for granted, but I have a meeting on Tuesday because there is a borough in Greenwich that is crying to be part of a network, to learn about these things. So again, there's a lot of work to do there, and to create, and maybe go beyond and do projects, do themes, communicating now, putting in contact cities, and taking off the ground specific projects that align with what we heard this morning about the European Commission, and bringing us together instead of us working in our cities. There will be a point in which we can do the comparative and make use of the network.
Yeah, add one thing, because I think it was really nice at the presentation of Pia Laurila from DJ Reggio. Yeah. She really invited the City Science Initiative to be part of the one-stop shop new platform for cities for Europe that will be launched in 2028. And I think this methodology, we should have developed it by then, and it should be really part of that platform. So people, cities can use it. And it should be designed from the civil servant perspective, that the science can really contribute. I thought it was very nice that we had that invitation.
But do we have the blessing of the coordinator of the CSI, for me, Panos and Despina and Victor, to start working on a concept idea for a project under the CSI umbrella, and maybe with Luciano as
you have all the blessing, and I think Eric has also a proposal.
Can I answer to that? I was going to say that the best project is the project that the people want to do. So I would say go for it.
Thank you.
Yeah.
Just wanted to apologize for motivating a discussion that asks for funding.
We will call it
I'm really sorry for that. I didn't want to do that. But just one last sentence, because we have also the Deputy Minister here. I just wanted to say that Noises is here. We really want to be part of your initiative. We really want Thessaloniki to be a living lab for what you are working on all this time, and we are here to work together with you, me, Professor Bamidis, and all of our team members, to see and answer the question, what would Thessaloniki look like if we bring people together? So thank you very much for your presence here from my side.
And I would like to ask the Minister to step forward. Perhaps you can go to the podium if you want. Thank you very much for being with us, first of all. We know you have a very busy day and you had to be swift to come with us.
Okay, thank you very much, Panayotis. To be honest, I would like to be earlier here, but as you mentioned before, really it was quite a hard day. I was in the parliament this morning, then I had 2 meetings in Athens, then I had to give 3 speeches here in Thessaloniki. Now it's the 4th one, and I have 1 more. But I couldn't miss it, because now Thessaloniki is becoming the center of innovation, and this is something that we are trying to do. So, I mean, in our government, innovation and the conjunction between the product of the research centers and universities with the needs of the society and the economy is the main purpose, actually, and that's what we are trying to do over the last few years. The good thing is, which is quite significant, is that Prime Minister himself, Kyriakos Mitsotakis, knows very well that this is the way, actually, to progress, to development. Since we're facing a new era, we know that AI is not just a new technology, it's a new kind of status, let's say, and we need all of us, governments, the society, businesses, entrepreneurs, everybody has to adjust to this new reality, which is, of course, has so many opportunities, but at the same time, it has some traps. And I think everybody knows what I'm talking about. But let me say a couple of words, just 2 minutes. I prepared something to say to you, so I need to share my thoughts with you. So, dear Panayotis, distinguished representatives of the academic community, distinguished representatives of local government, dear guests and partners from Europe, it is with great pleasure and honor that I welcome the commencement of the annual meeting of the European City Science Initiative Network. It is of paramount importance that the heart of European urban innovation beats here today in Thessaloniki, a city that consistently demonstrates its dynamism as a hub for research and technology. I would like to extend my warmest congratulations to the Laboratory of Medical Physics and Digital Innovation of the Aristotle University of Thessaloniki for hosting and organizing today's meeting, as well as for its outstanding scientific contribution. Thessaloniki's participation in the CSI network since 2018 is by no means accidental. Through an exemplary partnership between the Aristotle University of Thessaloniki and the municipality of Thessaloniki, the city leads the thematic pillar Thessaloniki, health and well-being. This model of collaboration serves as the compass of the strategy we wish to see in practice. Science in direct dialogue with society and local government, translating academic research into applied solutions for the daily lives of citizens. At today's meeting, the synergy with leading networks such as Net Zero Cities, EuroCities, and the Aurora European Universities Alliance underscores that the challenges of our time are shared and demand collective intelligence. The themes you will address lie at the very core of the priorities of the Ministry of Development: digital transformation and smart cities towards the creation of sustainable urban ecosystems, urban resilience and green cities to shield our infrastructure against the climate crisis, circular economy and health to safeguard the quality of life for future generations. As the Ministry of Development, responsible for research and innovation, we systematically invest in the outward orientation of Greek research institutions. Our goal is for this meeting to serve not merely as a platform for dialogue, but as the launching pad for new, targeted synergies through funded European programs. We want the institutions of Thessaloniki and the entire country to play a leading role in European consortia that bring resources, expertise, and added value to our economy and society. City science is not a theoretical exercise. It is the tool to design the cities of the future. I wish you productive discussions, fruitful exchange of experiences, and every success to the proceedings of our meeting. I see that this is already happening, and I can leave you to continue the conversation with this music which is combined with you. Thank you very much.
Thank you. That was the best conclusion we could have because it gives us not just pleasure but power if you are with us, and I think together we can do many things. Together we can speak and speak, but if we don't have the engagement of the policy makers as well to understand the problems, like you do, for example, and then go hand by hand and then seek for funding, then we may do nothing. Volunteerism is good, but it has to be supported with enough power, and power is what we discuss now. So I think we can conclude here because we just had 1 hour and we exceeded the time slot that we had. So thank you for your attendance. Thank you very much for the panelists. I'd like you to stay just 1 minute to have a picture. And thank you all for this event.